We're live. Wow. Hello,
Woo!
everyone.
Morning,
Yay.
Martin.
Good morning. Good morning.
And
Well,
good morning,
morning to
everyone.
us.
Yeah.
Morning to us, but people are watching from everywhere. So if you want to share where you are joining from, would be fantastic to see in the chat. It's always nice to see the different regions of the world be present. Also, if you are here for day two, and you were here yesterday as well, would be fantastic to hear, because you can all tell me I was wrong with two things. One is that I said this was year 5 of .NET Days Online. It's actually year 6. So I was living in the past there. And the second one, and this one is going to mess with your minds, is that
Don't
the
do it.
eclipse that you see in the
Don't do it.
backgrounds, I'm going to do it anyway.
Don't do it,
Who
Martin.
else thinks that it's animated? We have a vote going on in the background where some say it's not animated, others say it is animated. I can see it pulsating. So let us know your thoughts. I'm in the pulsating camp. Matthias just doesn't believe me, and the techies are also shaking their heads. I see in the background, so I don't think it's actually the case.
It's not that I don't believe you, but the thing is, for me, it was extremely distracting. So I had to take a moment and find my Zen mode, only to continue with actually watching the talk in that moment when you said it. So, but yeah, it looks like it's pulsating a little.
All right.
Sure.
Speaking of talks, Matthias, you want to introduce our first speaker of the day?
Yeah, our first speaker is Roman. I'm very excited for that, for one simple thing, that it's about DSLs. So his talk is named or called Building Functional DSLs for Life-Saving Applications. And with that, let's add Roman to the stream. Oh, 2
Hello.
clicks once. Hi, Roman.
Hello. I don't think it's pulsating, by the way, but we will see.
We will see. All right. Let's add your screen to the stage and then give you the stage, and you can kick off.
Okay. Thank you. Thank you
Okay.
both.
Good luck.
Thank you. Thank you. All right. Hello, everyone. First of all, I really want to thank Martin and JetBrains guy to invite me here to talk about my beloved things, which is especially F#, but also the other things we will get to later. My talk is called really Building Functional DSLs for Life-Saving Applications, but you will see probably more than just DSLs, but we will get to it later. Quickly about me, my name is Roman Provazník. I'm currently head of product engineering at a company called Cecil, Czech Republic and Slovakia. By the way, the abbreviation for head of product engineering is HOPE. So I think good things are coming for us. I used to be a very active person in Czech F# community. Unfortunately, not so much today, but I'll work on it. I promise. I'm trying to get back with day-to-day work with writing some more F# code. I'm an occasional speaker, a big fan of F#, trying to push F# really everywhere. This is the second time I'm talking at .NET JetBrains .NET Days. 2 years back, I was also talking a lot of F#. And of course, because in these days everyone has a podcast, so I'm a podcaster. So I don't know if you are aware of this new European Union rule, but to stay in IT and be active in IT, you need to have a podcast or newsletter. It's up to you. I decided to run podcast, so it's called Podvodcasem. But name is somehow funny only in Czech, so I will not translate it. But it's only in Czech language. So if you are language speaking, if you are English speaking, I'm sorry. However, you can feel free to check. Okay, let's go to today talk about my beloved things. So what we'll be talking today about, there will be actually 3 things. First one will be about domain specific languages. What is it? Why to use it? How to use it? Second thing I will talk a lot today is F#. Why I believe it's most likely the best .NET language. Why is it having so many amazing features? And which of these features could fit to our desire to have custom DSLs for our application? And third thing I will slightly touch today is something which is called Fable or Fable compiler. And I will explain why using JavaScript compiler on the top of F# is actually great productivity booster, and how this cool mix help us in this company to provide to our customer a critical part of their emergency application. So first of all, to really start, let's talk about dispatcher application, because before we jump in the code directly, we need to get some context and we need to understand the whole business problem. So let's talk about typical emergency situations, emergency systems, and our application. So imagine you had an accident, there's some kind of emergency. I heard something also happened to JetBrains guys yesterday. It's like you fell from the bicycle, or you did, I don't know, something completely different. You had too much inheritance in C#, whatever. You're just not feeling well. So you're laying on the ground, terrible pain. Your stomach is full of abstract factory classes, real bummer. And someone picks up the phone and calls 911, 112, or whatever's your favorite emergency number in your country. And on the other hand, usually there's operator sees your call in application, responds to it, find your location, and helps you online or over the phone to send you help right away. Help arrives, you get better, and after some time, you are all good and you can continue whatever you're doing. Ideal scenario. All right. So typical emergency situation, you have trouble, you call for help, help arrives, you get better. Hopefully, this is how it all should work in all countries. So if we look at this from application perspective, let's say, what really happens is that caller calls 112 or 911 emergency. Call is redirected to one of existing dispatcher centers, because there can be more than one. Usually there are more than dispatcher centers, depends where you are, because if you are, for example, located, I don't know, in south of your country, probably you won't get help from people sitting on the south of your country. You don't want to spend 5 hours waiting when help arrive. And usually rule is there should be at least one emergency or dispatcher center around you. And one of the currently sitting people, we call them operators, answers your call and send you help. What does operator really see is a terminal with running application where they can see all waiting calls. They can look at the history. They can quickly locate you on the map based on what you are calling from. They can quickly respond to incoming call. They have any other, I would say, additional functionality like push to talk, to quickly talk, another part of rescue system. The application is actually quite complex, a lot of hardware behind, cables, telephones, dispatchers, calling dispatchers, and it's quite complex system. And our customer one time came to us and said, look, we already have all the infrastructure. We want to modernize our old crappy Windows-based application into something more fancy, more reliable, more up-to-date. So we have all the infrastructure, we have all the background, but because we believe it's good to introduce new technologies, we want web-based awesome application running in the browser directly in our dispatcher center, because of course, like having your life emergency situation handled by JavaScript is always good and brilliant idea, right? And on top of that, what you're going to build, it needs to be .NET backend compatible, because we already have tons of infrastructure behind. We don't want to rewrite, because there's also a lot of applications in background running and really like making all those things happening. So we don't want to rewrite it. We just want an additional layer on top of it. And this is pretty important, it must be highly configurable by non-technical people, because we want to make the whole operator UI on the terminal to be different for, let's say, police, for firefighters, for ambulance, just for different part of rescue system should use the same application, but in different layout. So, for example, application for ambulance can look like this, while firefighters can have same functionality, different configuration, and probably different layout. Or for police, it could look like that. Again, same, let's say, part of the system, but slightly different layout, slightly different functionality based on the configuration. So whole configuration needs to be configured, whole application needs to be configured by non-technical people in user-friendly way. At that time, we started to think, hey, we may need a custom DSL for configuring that, which bring us to the world of DSLs or domain-specific languages. And before I will jump into how we did our domain-specific language in F#, let's for short time stop with what actually DSL mean, what it is, domain-specific language. Domain-specific language is a programming language which is specialized for a particular application domain, offering specific contracts and abstractions to solve the problems within the domain efficiently. And there's big exclamation mark on word domain, because you may think it sounds somehow familiar, right? The truth is that you are already using in your day-to-day job many DSLs, because already right now, when you finish with the .NET Days Online and you go back to your work, you will start writing some kind of code or design web pages or write SQLs, and all those things are actually domain-specific languages. So, for example, if you want to go and query and manage database, use SQL. For web pages, use HTML and CSS. For hardware freaks, you probably use VHDL. For those who really like pain in their life, they use LaTeX and blah, blah, blah. So every different domain has their own language anyway. Good thing about DSLs, actually, is they are really productive in certain domain. For example, if I go to SQL, this is like everlasting. It will never be killed, in my honest opinion. You can manage databases and tables and rows and views really effectively. But if you will try to create, for example, a web page in SQL, like, good luck with that. So usually DSLs are often they're great in certain domain. They provide syntax and all semantics, which is familiar for domain experts. And what is really good is they can be optimized for the specific task they are designed for, so usually providing better performance. Bad things about DSLs are obvious. They are the opposites. They are not suitable for any general purpose programming tasks. Their narrow focus means they are usually less versatile. And for those of you who are not familiar with domain, it may need some time to jump into the domain, understand what is it all about, and understand the DSLs. And of course, integration with, let's say, other out of the domain tools or systems could be a little bit clunky. Just the example of the opposites of DSLs are GPLs or general purpose languages, but their pros and cons are exactly the opposite. So they are versatile, with large ecosystem, with libraries and frameworks, with huge community around, easily integrated with the rest of the technologies, but they are not tied to specific domains. So for domain experts, they are not so, let's say, productive, and it's sometimes difficult for non-programmers to start using them. So that was one of our thinking, like, what we're gonna do. Of course, you can use, for example, MPS, one of the existing tools to build custom DSL, which is coming from JetBrains. But in our case, it would bring an additional complexity, and we decided not to use it. We consider it, but we decided, okay, let's stay with our tech stack, and let's rather use something we already know. So when we revisit the customer's requirements, web-based, yeah, we can use React, Angular, VJS with TypeScript, or we can go full step with Fable compiler, and I'll get to this part later. For .NET backend compatible, yeah, we have some spare F-sharpers at home, so let's do it. Let's use it. Let's use it F-sharp because we have nice interop with C# and rest of the .NET family. And to make it all configurable and make it all configurable by non-technical people, we may use some DSL, which means that we already have F# in place. What about giving a try to something which is called computation expression, and what about to write custom DSLs in F#? So let's talk slightly about computation expression in F# and what it really is. Computation expression offers a uniform syntax and, let's say, abstraction model for encoding context-sensitive, again, like context domain-sensitive computation. From my perspective, this is probably almost criminally underrated F# syntax feature. And I personally, from my experience with F# for many, many years, I find this really, really powerful. If there are any functional freaks listening to us right now, they can be also thought of a way how to express monads, monoids, and applicative functors and all the other stuff. Sorry, I just had to say the word monad in my talk because this is sort of like requirement for F# talks. But even if this syntax can be also seen from functional programming perspective, something more complex, I would say it's amazing if you do it right, that it can be used by really non-programmer people. If you ever worked with F# or you saw F#, you most likely already know and use some of those pre-built computation expressions like async, which is for asynchronous expressions, or task expressions, which is for using traditional .NET tasks, like when you have async function in C#, you would probably wrap it into task computation expression using the task keyword in F#. For those who like working with iQueryable and collections, there's a query expressions, and for typically when you want to create your own collection based on some logic, you end up with sequence expressions which use this the keyword sec. So computation expressions are already in F# at your service, ready to use. But what is really, really nice here, and what is the real deal, is that you can create your own computer expressions based on your logic, based on your understanding of the domain. So like in this example, if you look at the screen, there are 3 steps, and it's pretty easy. Imagine I need a computation expression to work work with uncertainty express in F# typically by option type. And first thing I need to do, that's the first step, is I need to create builder class, give it some name. For example, here it's the option builder, and implement few methods, where usually the most important one is the bind method to handle let with exclamation mark, or as we call it, like let bank. Then you create instance of this builder and name the instance. In this case, it's called option, to be like it will be used as a keyword for computation expression. And the third step is using this option keyword for wrapping your logic. And in this case, again, you're dealing with option type. So it's pretty easy. 3 steps: define builder, create instance, and name of this instance is actually right now used as let's say keyword in F#. What is pretty cool is that you can also use this for like custom operation. So you can create your own keywords for your own computation expressions. So this is where looking at your own logic, you can introduce more and more custom keywords, which together creates your instance of your record or something you want to do with your logic. So in this case, using custom keywords, you are creating your own logic, your own domain-specific languages. So I will now jump back to quick demo. So here we are in my beloved writer. And as I said, first of all, I can here define the option builder. Then I create an instance. In this case, I call it maybe, but I can also call it, I don't know, Martin, why not? And in this case, the Martin will become the keyword, but still the logic is still the same. So if I just execute all of it, you see that if I am evaluating some 10, it means that I either have or don't have 10, but in this case, I do have value 10 and value 20 and value 70, and I just wrap it again in the option. So now I return some 100. What is really nice is that in this computation expression, I can do the none, like last part doesn't return anything. And if I run it again, the overall result of this Martin computation expression is actually none, like null, whatever you like it. Good thing is, as I mentioned, is when it, like this is, let's say this is the basic stuff. This is the basic F# stuff. And when you start dealing with custom computation expression, you will get to it pretty quickly and you will understand how it works. Custom operations are pretty cool because here you can, as I said, add your own logic on your language or your own keywords. So let's say I want to build something. I want to build a record which is called input, which has a label and some kind of the input, where kind of input is either text, which has some kind of placeholder, or password. It can be anything else. I can add like more and more options here. Doesn't really matter. So I can either create input like that, or I can create input builder. So imagine you want to create application for building forms for web, for example. So I have input builder here, and I can create again this instance. It's called input, and I will use my custom operation, which is called text and label, just to create this thing. So again, I will execute it, and then you see that the result of this is actually a record which is filled by the information which is provided by this my own keyword. So if I want to say, okay, I want to not add another custom operation, which will be, again, for example, Martin H. In that case, I will probably need it also here. So I will do it as an integer. So in this case, for Martin H, I say, okay, whatever I will get, it will be H, and it will be H, and that's it. And in here, I just need to kick it with some. Okay, let's say Martin is 18. Hopefully, he's not. Okay, so and now I can use this as a specific keyword, also now requiring me to add some kind of number. So if I put here text, it like shouldn't actually work because it's integer. So I will try to run it, and okay, it used the previous value. So if I put here, let's say Martin H is 25. Now we have a 25. So this one is, I would say, pretty cool. And one thing I really love is you can also overload this custom operation in F#. So frankly speaking, if let's say I want to create a person, again, like I want to create instance of person record, and this person record I can either create like this manually, or I can provide DSL for someone who will creating these records on their own, let's say Rider or Visual Studio Code or whatever. They just want to work with this. So again, having something like that with custom operations that can also take different kind of parameters, different kind of types. So I can together create something like that, and people from, let's say, no F#ers can actually only set up something like that. They can open this builder class, and they will just start creating this DSLs. So Coming back to our computation expressions. So, as you already saw, what we did for our application is that we introduced something which is called definition. Again, it's the same record like you saw when we did the overloading with different kind of records, like just our custom record in F#, to describe the whole application with different properties like width, height, and so on. And this definition is part of shared domain, which is basically a F# class library reference from both sides, like front end and back end, client and server. And we created discriminated union for panels. So just for the record, in real application, there are like tens of different panels. So this is just simplified for this demo purposes. And panel is just a set of functionalities. Can be simple button, can be more complex functionality, can be list of waiting calls, can be map showing where we are calling from, log with history, whatever. Just some set of standalone functionality. And each panel lives, in big quotes, lives in some kind of area. Depends what it makes sense from UX perspective. And by having own sets of computation expressions and own sets of keywords, we created this like DSL. So person configuring it, non-programmer, just open their VS Code or Writer or whatever and start defining the definition. And they know that if they are in definition, there's width, height, rows, layout, blah, blah, blah. And each custom keyword has own rules, so they cannot provide to the width and height, for example, I don't know, name, because it only accepts certain types, so it's really type safe. And by that, you can really create various parts of the application and various systems without actually being aware that you are writing F#, which is pretty cool, because many times people are scared of technical stuff. So in here, you can see the detail, how single area is defined. And again, you can see the beauty of computation expressions, because each type and of panel can have very own keywords, and it's pretty cool. And if there's no behavior defined, it falls back to the like default configuration. So it's also like sort of like overriding default values. It's pretty cool. It's like programming without being aware of that you are programming. The overview of the whole process is that we have a configuration engineer. This is on the left, on the bottom, configuration engineer, using one of those easy code editors, just a normal F# code with shared library. And based on that, they are generating configuration using CLI tool. Then the configuration is serialized to typical JSON, and JSON is stored on backend. And then API server is providing back to front-end application as a strongly typed definition record. So again, we are still in the strongly typed world. It's not, even if this JSON is only here the storage mechanism. And again, the application itself is using the shared definition from shared F# library. So all the way, everything is safe and strongly typed. So again, I will jump quickly to demo version, which if you look at this overall application, let's say that I have here, I have on the shared, I have the definition I was talking about. So I have length, area direction, column, different kind of panels with different kind of properties. And on the bottom, there's record code definition, which wraps whole the application, like width, height, columns, rows, layout, areas, blah, blah, blah. And using that, I have builders on the backend. So I can, based on this, I can create, let's say, my own computation expressions. So again, you see like custom operation, width, height, background, blah blah blah. It's looks strange, but it's pretty easy. really. You can find a lot of information about how to write custom operation, how to override the custom operation, or overload. So you can use for the same operation, you can use the different type of parameters. Is pretty cool. So in this example, this one is called no panels. I have just definition. It's 800 by 600 with 3 columns, 2 rows, and like 3 rows. 2 rows are fixed. They are fixed, and one is automatically filling the rest. Here is how I want to create the layout. People from CSS already realized that we are using some things from Flex. So yes, we do not reinvent the wheel here. And I just say, okay, I want to put here into application the areas. Here are the header, main, and side right. And here again, you see the side right. Here is the main, and here is the header. So whatever, every type of this again, the area is again custom keyword. So it also helps me with the copilot, like what should I fill in there. So okay, on the just quick demo, I will just say on server that sorry, it's here. I want to use the it's here. I want to use in the web app, I'm going to use this definition of no panels, which I just shown you. And if I go here, you see exactly as I said, like 3 rows, 3 columns, and different colors here. So if I come back and I say, look, I'm going here, and you know what? Let's make the header panel fuchsia. It's terrible. Let's put yellow, because why not? So I created the yellow one, and right now I'm waiting for my application to be loading, because on the background it's now like refreshing, because this thing's usually happening one time. So hopefully, yes, now I see I have the yellow one. Pretty easy, but the change I did was still in the context of custom DSL for changing the application. You see, I'm not aware I'm working with F# actually right now. So if I say, okay, I have, let's say, way more complex definition, which again, we are in F#, so we will start reading from the bottom to the top. So I have a definition which is called fold, and it contains probably the let's say, dimensions are the same, probably same layout with the same areas, but each area right now has a different kind of setup. Also, it contains some panel, and each panel has own set of custom operation in DSL. So for example, for placeholder, I know there's width, height, background, label. For example, for active call panel, I can call it completely different, or I can also for call queue panel, which is the panel that shows that who is waiting for emergency to be resolved. I can say, okay, I want to show only 8 last calls, or I want to show only 5, but it shouldn't be able to accept anything else. So I'm going back to my application quickly just to show you that. Okay, so it's definition number 2, full. Again, I will save it. It will probably take some time, since I'm also sharing just to reload and on background to create the JSON. But right now, voila, we have same application, same DSL, same functionality, but configured in different way again, without me being aware I'm doing something in F#. I'm led by the keyword. So as I said, here is call panel. It's just a demo application. It doesn't look like that in production, like, trust me. But just for you to understand the beauty of those things, that I can truly go to each definition and create own version of the based on keywords and based my custom DSL. And I'm led by IDE. Rider really helps me to understand what can I do here, what kind of custom operation are valid within my placeholder panel. And again, this is all defined by me, by having very custom operation based on my own domain specific logic. So this one I would say it's pretty cool, and I actually like it a lot. Okay, so why we did it? Overall benefits. I already said, first of all, DSL means here in this context F# code. So it's still code. So it means it can be versioned, it can be stored, you can have a pull request and all your fancy ceremony around writing code. You can use your favorite IDEs like JetBrains Writer, Visual Studio, VS Code, like whatever you like. Of course, VS Code in this manner is pretty cool for non-technical people. It's easy to jump in. You use the Ionite as a plugin, and you are in the context of like writing F# code without being aware you are writing F# code. So probably you are now saying, "Oh, that's really cool. That's smart approach. Great idea." Right? Yes, it is. However, this is not, again, we are not reinventing the wheel. This is not our idea. It's already existing in whole F# ecosystem. There are many, many, many libraries using this approach to provide you better experience, not as a, let's say, non-coding configurator, no, but as a, let's say, day-to-day developers who are trying to get their work done. For example, here, Saturn Framework is a neat way how to write ASP.NET MVC application just by using custom DSL with custom keywords. Again, the same approach. So instead of writing tens of lines and using many attributes and wiring everything up, you just use something which was inspired by Elixir's Phoenix, and you use custom DSL here, like custom operations like router, and for each endpoint, each HTTP method, you either redirect on, you provide the layout, whatever. It's pretty cool. Another one from this is, for example, Farmer, a brilliant way in F#. I would say this is probably one of the best usage of custom DSLs using computation expression in whole F# ecosystem. It's called Farmer, and it's great for building and generating ARM templates, because if you ever get your hands dirty with ARM templates from Azure, they are really, really ugly. On the background, it's just a terribly awful JSON. So to write it a nice way, you can use this amazing library called Farmer, which will again let you to understand what you are dealing with. So if you are in container group, it tells you it needs a name and it needs instances and probably public DNS, and DNS needs some kind of protocol and port and stuff like that. So it also let you using this DSLs. This is very cool. It lets you to understand what you are dealing with and understand those used resources on Azure. So it has like two amazing benefits. First one is understanding, or like writing fast, and second one is understanding what you are actually writing, which is pretty cool, amazing. This is shameless plug for myself. I created library using this approach in F# ecosystem for Dapper, which is from like Stack Overflow Dapper library, where you write SQL queries and just run them in really easy way. Here again, you see that I'm using custom keyword select, which sounds like this is already built in F#. It's not, but by using this library, you can have it. So you can write MySQL, MS SQL, Postgres, SQLite, and the other libraries, and it's open source. So totally feel free to grab it. And as I said, there are many great approaches using this. This monster, for example, is trying to jump you into Blazor application, and if you are brave enough to do it, like, be my guest. This library will definitely help you. And again, it's still the same story. You can see how easy it is to write custom stuff, in this case HTML snippets with just a few lines of custom DSL, so we can combine like functionality from Blazor and the functionalities from HTML itself. So it's great. So we have F# everywhere. It's perfect, cool, and we are really happy. However, I need to say I slightly lied to you when I said we have F# everywhere, because in our application there was a technical requirement to keep the server side in C#. It was understandable, but as we already had all connections from backend to hardware, it was already prepared. Our customer don't want us to rewrite again everything, and there was also some ugly WCF legacy on background, and you don't want to deal with it neither in C#, but especially not in F#. Trust me. So we made a deal. We took some of our poor C# developers and put them into project to take care of the API service, and we let the rest of the team to take care of the front end just front-end stuff using this Fable compiler, which is what you actually saw in this demo version, which all of us brings to amazing land of joy and love called interop. So I need to be fair here. I actually, when we started with it, I expected interop to be way more harder than it is in these days, and truly is quite good now. However, there has been some scary things to do, and I just want to, I want to warn you, there can be dragons. So for example, working with F# option is now pretty easy. You define record. So some properties, for example, here, my name is optional. So this is okay, and you want to send this record to front end. So you just let the implicit conversion do the magic. Easy, like no problems here, even for C sharpers. However, if you do the same thing with, for example, F# lists, you cannot easily convert it. Again, to be fair, C# array and F# list are completely different types of collections, so it makes sense. But if you look at from the C# perspective, when we try to tell them, look, dear C#, don't be afraid of F#, it looks scary, but it's not, you will love it. They can get crazy, that compiler is killing them, that they need to fill those crazy functional values, and it's a little bit of pain. So like be aware, it may happen. Again, for then C# guys, you need to somehow help them. So you need to let them know that there is some list module of sec method, which can let you convert C# like from F# collection to C# collection and back. So I'm not saying it's a problem. I just wanted to like say that if you are C# developer and someone tells you like, hey, let's use F#, you need to provide these people some kind of guidance and help them understand what they are dealing with. But otherwise, I would say it's okay. Except there's one thing: unions. In F# we love them. There are amazing F# discriminated unions are the best seller of language itself. I love it, and I still love it. I'll be probably love it till last day. It's amazing stuff. But we F# developers somehow may forgotten how painful it can be. So please, if you want to exchange discriminated unions between C# and F#, there's my guidance. Sit with your team, explain the reason, also discuss how to consume them, which approach of pattern matching to use, and make some kind of team-wide arrangement, because specifically in this case, they are great on backend, they are great on frontend, they are great everywhere except using them and filling them and working with them from C#. So really, this is where you need to be super careful about some kind of team-wide agreement. So maybe you are thinking like, why didn't just send the JSON data, right? Like this is again getting us back to our intention to use strongly typed definition as much as possible. So in this case, instead of sending JSON and having serializers, deserializers on both sides, on front end and back end, we say, okay, let's use strongly type approach, and we use signal R to do the communication, and using those two nice unions. One is for messaging from server to client, second one from client to server, and it worked really great. And also it led for us to understand how the communication flows. So this is why we rather use this F# library on shared basis, and let the signal R do the transition between the JSON or the format that's going over wire to the backend and frontend and the back. And in the end, it worked really great. So just to summarize quickly, the F# C# interop and our lessons learned here. If you want to go the same path, definitely be my guest. It's a great way how to do it. However, keep few things in mind, especially it's great, and overall it's getting better every year, but still can be tricky, requires some kind of open-minded approach. And first of all, you need to do is sit with your team together, discuss and go through all those definitions and why are you using them. Then it won't hurt you so much. I promise. Okay. So where we are, I showed you some DSLs. You saw some cool features and some not so cool interrupt. And the final boss here for today is Fable compiler. I don't know who said it. I think it was maybe Christoph Cislak or maybe Don Simon himself, who said that Fable compiler is the best thing that has happened to F# since F# itself. It's pretty cool stuff, and I love it still. It's a .NET tool. It's able to compile your F# code into JavaScript, to TypeScript, to Dart, Python, Rust, and even there's some crazy stuff with PHP. So you just write F# everywhere, and the rest is compiled to your fancy output. One thing I honestly really love about Fable is that it's not enemy of anyone. It plays extremely well with existing front-end ecosystem. So if you already have some favorite library, like LeftPath or whatever, you can just grab it and use it in F#. So for example, those like cool F# libraries it's called Fellis ecosystem. It starts with Fellis the namespace on NuGet. They're just tiny functional wrappers over existing libraries. They don't really reinvent anything. Like, do you need maps? Cool, use this F# library based on Pigeon Maps or Leaflet.js. Do you need graphs? Cool, take this wrapper over Plotly.js or create your own wrapper of D3.js. Beauty of all of it is that it stands on the shoulders of giants. It's reusing millions of packages already existing. It's not like fighting with JavaScript developers. It's actually reusing their work in really nice way. And talking about reusing thing, I need to point out one thing, which I'm really like grateful to Fable and F# community. It's Elmish, because if you are into front end, which probably as a .NET developers you are not so much, but there's a library called Elm, has been with us for, I don't know, 5-6 years, something like that, maybe longer. And what Elm brought us is amazing way how to think about application and about application state and about handling the different changes and flowing the messages and all the way how to combine logic and view and domain, and together is just amazing way how to do it. And F# and Fable community, they took it, of course, because we are like stealing from each other, right? This is what the community is about, and created something which is called Elmish, or use Elmish, because you can also use this as a hook to React, and it will let you fully separate view parts from the business logic in extremely simple, powerful way. And if I will get to demo quickly, I'll look at my watch. I will show you quickly how it works. It's amazing. So if you are tempted, like, okay, this is great, I want to start it, I want to try it, go and start with SafeStack, which is on this address, which is .NET template for full stack development. You just create .NET new save, and you're safe, and everything will be created for you, like backend, front end, Vue.js or Webpack. Everything will be prepared. You will just start, and everything is running smoothly, and you can start playing with F# on both sides, on backend, on front end, on shared library, which is for that strongly typed communication between these two sides. So it's really amazing. If you want to start with F# on let's say full stack manner, this is the way you should go. So before my final wrap up, I will just quickly show you what I was talking about when I was talking about the Elmish. So here's typical application or typical example application when I do like increase, decrease, and I'm just clicking on button and increasing or reducing number. And if I will go to my example here, Elmish, you see again, we need to read it from the bottom to top, that I have here like two ways how to write it. I have use state, which is typical React, like weird logic stuff. So I have use state, and on click, I just set +1, and I call the setter, and it's working. It's typical React stuff. If you're into React, you know what hooks are. If you are not, it's pretty easy to jump in. And by the way, you can see here I'm using custom DSL in F# for writing HTML. But this is not the cool stuff I want to show you here. Cool stuff here is this elmesh. When I say, okay, instead of use state, I will use elmesh, which means that I have two functions. First function is init, which just returns the initial state, let's say, or model, whatever you like it. And there's function called update, which is working with the current state and the messaging coming to this function. So for example, here I say, okay, whenever I get the request for to be increased, then if its count is higher than 15, I will reset it. Otherwise, I will keep counting +1. And here I just define this, what's the type of the state, or again, model, depends on your how you like it. And these are the messages that are floating from the application. So if I look as this use elmesh powered, whenever I click on increase, I send message increase. I will dispatch it to this function, which will somehow bubble into update. And this logic will apply based on another amazing stuff, which is called pattern matching. So in here, if I will go over 15, it will reset it. So it works. Probably the last thing is in the fable is, for example, here is the QR code generator. The thing I really love, you see, it's 28 lines only because of I cannot write it even shorter because I'm using some fancy classes here from Tailwind. But here again, if I want, for example, use React QR code, which is library, which is already existing from React, is a library that lets you create QR code based on your input. What I can do, I can either create my own in F# ecosystem and play the fool, or I can just like use this address, go to my browser, look for this. Oh, here is React QR code. Nice. What should I do? Oh, okay. This is the name of the library. Nice. And this is how I'll use it. So I will actually just send here the QR code, and I will send here some kind of value. So I edit this as an npm package. I just say, okay, let's import thing called QR code from this package, and I want to provide this, which is anonymous record, and I'll just set their value, which is code, which is coming here from this QR code, QR code function, which is I just wrap it into React component, and based on this, I will close it. I can now generate codes pretty easily. I didn't reinvent anything, so this is I would say like pretty neat stuff. And overall communication, as I said, between the client and the server is over this API, which is just sending the shared communication. So I'm going back to the second example of how it's when you sending data from client from backend to front end. This is how the definition is defined in shared library. Everything is still strongly typed. So definitely, I will send you link to this code example so you can play with it. It's pretty easy. Okay, so let's get back to like time for wrap up, right? So if you end up in the situation of need some custom DSLs and you have F# available, definitely try to model it with F# computation expressions. They are powerful, they are easy to consume, and they are fun to write because it will let you also, as a nice side effect, even if we don't like side effects, but this is a nice one, to understand the domain. So like computation expression is a great way in F# where to go. If you end up in a situation where using this, you need also some kind of C# and some kind of interrupt, be super careful and super open-minded. There are still dragons, and don't forget, we don't want to scare C# people. We are like one platform anyway. We are all friends, so let's keep it like that. And second thing, if you ever thinking about writing single page application in .NET, in F#, definitely at least give it a try to Fable compiler, download the safe stack template, create your first own project, start it, and you will see that this is probably the best thing you can do in overall F#. If you enjoyed this quick overview of all what we did, you can check my talk 2 years back when I was talking about reducing the environmental footprint in nautical transport, where we, again, used F#, we used serverless, and also in the end of the talk, you will probably note that we also use Fable compiler to create UI application to configure this whole service. So again, we are doing it, and we are keeping doing it for years. So definitely, it's already tested. So thank you very much. Thank you for having me. And right now, I would say I will stop sharing my screen, and this is the right time for any kind of question if you have.
Great talk.
Really cool talk. Yeah.
I think the first I should say you could have asked me for an authentic picture from my accident yesterday. No problem at all. But that was you probably didn't see it, but I was like, oh my god, this is so relevant today. And I just wonder who was ha-haing at me. But it might be Martin.
We were definitely laughing in the background. Yes.
That's good. That's great. All
Okay,
right.
we have a couple of questions beside that one. Martin, you want to start?
Yeah, absolutely. I'm always impressed with F# and seeing F#, and each time I see it, I make this resolution to start experimenting with it and play with it, and then I end up not doing it. So it's kind of like New Year's resolutions. But computation expressions are really cool, especially for building DSLs and so on. And I actually had a potentially detailed question there, but in the first example you were showing, you were using the let keywords. Is there any way in computation expressions to sort of prevent users of your DSL from breaking out of the DSL, like using F# syntax or calling into methods in there or things like that? Or is that by default?
There are some pre-built keywords like let bank, yield, and other, or return is actually a keyword inside the computation expression, but you can still like bring your own. I'm not aware if you can like protect people from using some kind of stuff with it. There's still F# code anyway, but you can definitely like wrap it into like providing them different keywords and let them use it in the way you want to use it.
Cool. Yeah, I'm again gonna say I have to try this out, but we all know how this is gonna work out. But I should.
Once you feel good in a place, then you tend to stay there unless there are big reasons to switch, and some people are more adventurous about that, I guess. I think it's worthwhile. I remember there's a book, seven languages in 7 weeks or something. I only went half through, but it's cool just looking at other languages, and I guess also the compiler teams do that. I mean, I know all the big leaders, they talk to each other. If you look at Kotlin or C# and F#, those I mean, probably also the teams behind that, but also people like Matthias, for instance, is discussing with people from other languages. Martin, should I ask the next question?
Yeah, go for it.
Yeah, because I need to make a little disclaimer. So I had DSLs as part of my master thesis. And what was interesting, I'm not sure if you pointed it out during your talk, but rather little known fact is that there's this distinction between internal and external DSL. And you were mainly talking about the internal ones, which means they're embedded. So there's this other option where you could build your whole new language where F# or C# is not the foundation. And that's also what I want to add here. You mentioned it's very well approachable. You have good support in IDEs like code completion, etc. but I think also for people, and you kind of went into this later on in the talk, which was great to see. But what's also great is that you get all the benefits of the language, like for instance, also refactorings. Yeah, and it doesn't have to be for the people who are using it in the end, but just having this way to extend it in such a way, like also you were integrating React into that, is just amazing to see. Yeah, that was pure joy. And yeah, I guess that was much less of a question, I just realized.
Where's the question?
Okay.
Where's the question?
It's okay.
But I was super amazed to see those benefits again, just in a different area. Yeah. Have you also? Do you also have experience with? Let's maybe make it an actual question. Do you also have experience with external DSLs where there's not a foundation of F# or C# or something?
For me, not really. I was slightly playing with your MPS. I was just curious, but not really. I'm not into the. Actually, I'm not into DSLs as much as you, as it part of your thesis. So I was just like wandering around internet to get some more information about it, so we will not make any stupid mistakes. But here, really, our intention was, let's stay within the same tech stack, reuse, as you said. Let's people also opportunity to, if they realize that they can be creative within the DSL, let's have language provided to them. But also, if they feel like, oh, I just need to write integer into the slot for integer, let's have language for them on this matter.
Yeah, it's interesting. We have kind of the same history in regards to that, but since you mentioned MPS, so for those that don't know about it, it's our meta programming system. I believe there's also a full IDE behind that, so for creating your own domain specific languages. But I guess that's more in the direction of the external DSLs, where you have, I guess, no real foundation, no conventional programming language foundation. But yeah, Martin, do you remember what the predecessor project was? Nemerle or something?
There was Nemerle and there was another one, but I forgot the name.
Naming
I know which one you are hinting at. Yeah.
Yeah.
Okay.
Well, meanwhile, I actually have a question regarding the end users or the users of the DSL that you have there. I think in your talk you mentioned that they were using standard tooling to compose the UI and so on with the DSL that you've built. Have you found that it was easy for them to adopt that way of working, or do you think that it would still be more beneficial if the development team would just take over the building of the UI and UX and how it looks like?
From my experience, it's always good to have someone to call, especially it takes time to understand that F#, it's still F#, it's white space syntax, so they need to be careful with the spaces and tabs and all those other stuff.
Is F# as bad as YAML?
Yeah, I would say it's not as bad as YAML. Like, I think nothing is as bad as YAML, but it took them some time. And also we started with some predefined templates they could fill in. So it wasn't that they started writing from scratch. It was some, let's say, good to go template. You can duplicate it and play with it, and yeah, it wasn't so hard in the end.
It's really cool. Also, my kid is very loud downstairs, so pardon me if that ends up on the stream.
I can take over with another question then. Also, kind of personally motivated from my experience. So you also mentioned Pharma, right? I completely agree. It's a great project and improves a lot over those ARM templates. Again, the same argument which I just mentioned with the refactorings and stuff. That's just pure gold. And I think even Bicep cannot reach that level. There's one slight drawback, let's say, is that sometimes these APIs tend to get outdated, and I just probably also not. Yeah, question probably also if you discovered that and how you solved it. I don't know, maybe not to generate too much of a wrapper, let's say, because in some sense it's also a wrapper, right? Yeah, have you touched that area already?
Yeah, I actually contributed to Farmer at the time when I was trying to sneak in with Azure Functions DSL for it. So I also help Isaac to create some of those. So exactly as you said, I experienced with API changing all the way. Actually, I had to like download the traditional ARM and backtrack what was changing. It's painful. I think the reason, answer to this is, let's say, immutable approach with good somewhere behind. So really you need to set that for this version, these are the versions that are used on background. Unfortunately, they are not changing in a way that if you use the API version suffix on the API, it should remain the same. They're only creating new one. But yeah, you're right. The more typically, the more wrapper you create around anything which is not that, you need to take care of what's inside and how does it evolve and adapt to it. It's typical whenever you do any kind of integration, let's say whatever you call it, integration between two systems, you need to be aware of life cycle of both, and sometimes it's quite hard to realize good versioning approach, because even if you fulfill the somewhere approach, there's no guarantee that people writing those two systems you're integrating with are doing the same. So you must be probably the judge to say, okay, this is even now breaking change. No, this is just a minor fix. So yeah, but it's harder.
In the end, it's like writing any kind of abstraction, right? The underlying system might change, and maybe your abstraction also has to evolve to accommodate for that.
Exactly.
Can we pick one more question from the chat? I think.
I think we can definitely do it. It's actually, maybe a question that you may not know the answer to, maybe yes. But one of the people in the chat is seeing a lot of mentions about sutil, and they're wondering whether that is based on Fable, how it relates, whether you've experienced or played with it, and
I think Sutil is a library for Fable, which is in the Svelte world, because right now many libraries are around. Actually, you're writing in F#, it's compiled, but it takes whole React with you, all the stuff. So like you are writing components and you are aware of hooks and stuff like that. I think Sutil is for going into the Svelte world, but still having a Fable compiler on the top of it. This is as far as I hope I'm not completely wrong on this, but I believe so. This is the case for Sutil.
Yeah, so probably more lightweight than Fable and so on.
Yeah.
I guess there's one more question. I think someone in the chat also answered it, but never hurts to ask again. And that is, if you have custom React components in Fable and so on, how do you DSL those into F#? How do you use them? How do you import them?
You can. This is really nice stuff, and I will now also point our attendees to Google, which is called Fable JavaScript Library on Medium. It's on Medium. It's written by Zaid Ajash, and it's describing how you can generate from Fable TypeScript and use it as a part of TypeScript or JavaScript, or how you can write JavaScript and use it in F#, and how to do like both sides of bindings of bringing JavaScript to F# and F# to JavaScript in both way. And it's really comprehensive and it describes a lot. So it's definitely doable both sides. You can easily have smaller team writing everything in F#, generating TypeScript, and this TypeScript will be used by another people in different teams as a library. Definitely, that's doable. So yeah, I would say this interop is actually way easier, because if you fit in F# types in JavaScript, you can do actually what you like. So it's there are also some hacks typically around. If you go into the internals of Fable, still you need to deal with JavaScript, but yeah, it's possible both ways, and it's
cool.
easy.
Thank you very much. Yeah. I guess, I mean, I guess there's more questions that we can ask and so on, but I do guess that it's time for our next speaker. So, Roman, thank you for joining us today.
Thank
Fantastic talk. And let's bring
Thanks,
in
Roman.
Konstantin.
Hi, folks.
Hey, Konstantin.
Hi, Cecil.
Hey, how are you?
Yeah, I'm
let's
feeling
maybe
good. Yeah.
Great. Let's maybe not waste too much time doing introductions and so on. I guess you can handle that yourself and just give the stage to you, get your slides up, and you're good to go. Good luck.
Okay, thank you.
Pushing away to the limits. Good luck.
Thanks. Okay, so hi everyone. I'm Konstantin Saltuk, and today we are going to talk about async await and what, let's say, unexpected things we can achieve with it using just a little bit of creativity. So, but to proceed, we first need to start by understanding what's the C#'s async await is and what it does actually. So, and in the context of this presentation, we will look at async await as a special compiler infrastructure that allows us to write asynchronous code in a straightforward manner. In general, it frees our code from ugly callbacks and makes the syntax of our methods more sequential and readable. Let's look at these two examples. Suppose we already have an asynchronous API that returns a task. Without async await, as shown in the first example, we will have to pass callbacks to define what happens once the task is completed. But async await solves this problem by simplifying the syntax and making the structure of our method clear and linear. So, and next, I want to talk about what cannot be achieved with async await, and specifically it's data parallelism. Let's say we have some array of data and we want to process it in parallel. The first option is using parallel for each, and here we need to pass a callback to define what should be done for each element of the array. Another option is to simply iterate through the array using a standard for each or for loop and use the task run and then wait all tasks in the end. Or we can also use parallel extensions and as parallel and for all methods. But one thing that's similar for all these approaches is that we have to break our beautiful linear structure of method and create some lambdas to define the parallel execution logic. But it doesn't have to be like that. Let's take a quick look at C++. Here, with help of OpenMP, developer can add the pragma OMP parallel for, and a standard for loop will run in parallel. No special constructs, no separate methods or lambdas. You just use standard language construct and ask it to run in parallel. And I find this approach simpler and, most important, more natural. So, and the goal of my presentation is to show that something similar can be done in C#. Since async await solved the callbacks problem for asynchronous programming, why don't use it here? So actually, we can achieve this using the next C# mechanisms, the async enumerable with await for each operator, async methods, but with custom task-like types, and good old extension methods. So we will combine all these mechanisms together and make them work together, actually. So how do we make it? There are the main milestones. First, we will understand how async await works under the hood. Then we will define our own task-like type and implement fork join model using the async operations. And at the end, we will write an extension method that puts everything together. So let's break down how async await works under the hood. Let's take a look at simple method with await operators and see to which low-level C# code it actually compiles into. One note here, I've changed the names of some generated classes and fields so they're easily readable. And we can see in compiled code, firstly, it creates an instance of the state machine class. This class is generated by the compiler for each async method, and its moveNext method contains all the parts of our original method. Then an instance of method builder class is created. And this method builder class, in this case, async task method builder, is the class associated with the task type itself. Then code initialize the state flag to -1 state counter. And then it calls the start method on this method builder. So, and the method itself is, it just simply returns a task created by this method builder. So, and now let's dive into the key part, the state machine itself. The compiler splits our original method into steps representing the code between the await operators. And we can also see that for each await operator, there is a corresponding field in the state machine that stores the relevant awaitor. So, and let's look at the moveNext method itself. And it consists of these steps corresponding to each part of original method. And first, each step executes all non-asynchronous operations as expected, like in the usual way. And at the end, when the awaitor needs to be awaited, generated code updates the state counter, and then it checks if the awaitor isn't complete using the isCompleted property. And if it's not, state machine calls a special method awaitOnCompleted on the method builder, passing the awaitor and the state machine itself. And it actually can be awaitUnsafeOnCompleted or awaitOnCompleted, depending on the implemented interfaces, but for now it's not very important. So, and then the method just returns. So, and once the awaitor finishes, it triggers the execution of moveNext method one more time, allowing next step to get result from this awaitor and continue the execution. So, and basically it's then repeated for every next step. So, and now let's look closely at this awaitUnsafeOnCompleted method from the method builder class. So, and generally, this method schedules the next step of state machine using the awaitor. The standard implementation has some optimizations to reduce allocations, but generally there is some delegate that calls the moveNext method, and this delegate is passed to the awaitor. So the moveNext is invoked when the awaitor completes and invokes its continuation. So, and the best part about async method builders is that their behavior can be customized. And one way to do this is by declaring your own task-like type. Let's call it parallel task. And this class needs to have a method called getAwaitor, and the returned awaitor must also implement the necessary methods for the await operator to work. But notice that there is an async method builder attribute, and here we specify the type of the method builder class. So what's the method builder? And it actually must contain a certain members, in particular a static create method. It must also have a task property containing the resulting task. But the most important methods for us in the context of this presentation are start and awaitOnCompleted. As we have seen before, start method is invoked at the beginning, and the awaitOnCompleted method is invoked when await occurs and the awaitor is not yet completed. And the important detail is we can introduce any custom logic here to specify how and when the next moveNext invocation will happen on the state machine. So what logic should we actually put here? And first step for achieving our goal is to implement a fork join model. Let's recall what the fork join model is. And in general, it's a parallel programming paradigm where the execution flow splits into several parallel execution paths. And the code then is executed across these multiple, let's say, threads. And it's what's called fork operation. And after that, when the parallel operations are completed, the join operation usually happens where the execution joins back. So, and let's try to implement the fork method by putting some unusual logic inside await on completed. And instead of simply scheduling the execution of move next method, we will attempt something different. We will launch multiple task run executions that will each invoke the move next method. In case the awaiter is of our custom type, forking awaiter, for example. And the second thing we can do is to ensure that this forking awaiter always returns is completed as false. So the state machine is guaranteed to call await on completed instead of just proceeding the execution. So, and let's see what we get from this approach. If we define a fork method that returns a task with this forking awaiter, we can see in the debugger that breakpoint after fork is hit twice from two different threads, forked thread 2 and 1 in this example. And it kind of works, but it works only partially, and it doesn't always function as expected because there is an important issue in the implementation. We can't just invoke move next multiple times. So let's take a look at state machine one more time. And what we can see here is that the state machine holds mutable state. First, of course, it's this state counter. And additionally, state machine stores all the awaiters and actually even local variables of a method when the lifetime of these variables crosses the boundaries of await operators. So, and the issue here is that, of course, we don't want multiple threads to execute move next concurrently and modify this shared state because, of course, it would lead to race conditions. And even in the simple example I showed you on the previous slides, things can sometimes go wrong because the state flag will be changed unexpectedly and the state machine will be not able to proceed to its final state. So, but actually this problem can be solved and the solution is quite simple. Each thread must operate on its own copy of the state machine. And this can easily be achieved by copying the state machine. So we'll fork the world and each copy of the state machine will execute this move next method. So how do we copy the state machines then? And we need to understand that state machine is just a plain C# object, and we can just perform a shallow copy of its data. And of course, one way to do this is by reflection using the protected method member-wise clone. While this would work, it would be quite slow. And yes, we can optimize this by compiling expressions, but here is better news. And it's that in release mode, the compiler generates the state machine as a structure, not a class. And since they are value types, copying the structure costs almost nothing. We can simply assign it to a local variable and the result will be the same. So, and with this approach, a fork works consistently, and we can see that it actually works. But if we want to do something useful and not just hit the breakpoint twice, we need to be able to identify at which one of the forked threads we are running on. And this is a good moment to talk about the execution context. Basically, execution context is a set of information associated with the execution process. And in asynchronous operations, we actually have to preserve the execution context and then restore it when switching tasks. However, it's not just a burden, and we can actually benefit from it. Specifically, by preserving execution context, we can now use the async local variable. And async local uses the internal API of execution context to provide a way to store and read the custom data. And we can create an entity, let's call it parallel context, where we store async local variable. And in this variable, we can save, let's say, an ID for each thread before invoking this move next method. And user code can later access this data at any moment it wants and proceed with any business logic. So in the example, I pinned the parallel context ID in the riders debugger, and we can see that after the await fork, there are two threads. One of them has a parallel context ID of 0, and another one has it as 1. So yeah, it works. And from here, we can proceed with any business logic, let's say, process a chunk of the array based on our ID. Yeah, but before we rush into implementing the parallel for each, we need to implement the join method. And we need all threads except one to stop executing. This is actually quite simple to implement. We will just not call the move next method. And using our parallel context, we can detect the thread with ID of 0 and allow it only that thread to proceed. And for all other threads, we can simply exit the await on completed method and do nothing. So the continuation will not be invoked, and all other forked states of state machine will not proceed the execution. And actually, it's important to note that the join operation typically means that the main thread should wait for all other threads to finish before proceeding. And in reality, there are some additional synchronization here, but for the sake of simplicity of this demonstration, it's enough for now. And finally, let's look at this piece of code. What if we call a method where a fork happens, but we don't perform a join before exiting the method? So what would happen from the test method point of view? And to answer this question, we need to begin with looking at the final stage of the state machine. At the end, it sets the state to -2 and calls the set result on the method builder. And it passes the return result. The standard task method builder, it handles this by attempting to set the result on task. And of course, task can only have one result. And if result is already set, invalid operation will be thrown. So in our case, on the second fork of the state machine, on the set result, we will get an exception. And this is, of course, not what we want. But since we can customize the set result method, we can implement behavior in our parallel task that allows set result to be called multiple times. And we need to ensure that if multiple threads call this set result, the continuation that is scheduled in the task's awaiter will also be executed multiple times and provide return values for all of them. There are a few non-obvious points in the implementation, especially what to do if the continuation hasn't been set yet, and while some threads already reached this set result method. So for this reason, I will not go into full implementation details here. However, it's fairly straightforward. And for those who are interested, you can check out the implementation in the repository, which I will provide a link at the end of the presentation. But with the correct implementation, we can observe this beautiful behavior that makes the fork and join operations basically composable with each other and with other methods. So, and now we have all building blocks we need to implement the parallel for each using the async await. Let's take a look at which low-level C# async await compiles into. And as we can see, in async enumerable, instead of move next, there is move next async, which is called and awaited in a loop. Instead of dispose async is called and awaited. And at the beginning, instead of get enumerator, the get async enumerator method is invoked. However, get async enumerator method itself is not awaitable. It's not async. So we have a clear point where we can perform the join in the dispose async method, but we don't have a simple point at the beginning to perform the fork, since get async enumerator is not async. But this isn't a big of a problem, since we will likely want to use the await for each on regular lists and arrays. We will need an extension method to convert this collection into async enumerable. So let's call this method as parallel async, and we will make it actually async. This method will handle the forking and return the enumerable that iterates over a needed chunk for this forked thread. And there will be nothing special in the move next async, just a regular enumerator advance. And at the end, we will just perform a join inside dispose async. So, and the implementation of this method is fairly straightforward. We simply perform an await fork, and after that, we create a chunk enumerable for the appropriate segment of the collection. And the chunk enumerable is a class that implements async enumerable behavior. And the only thing that stands out is that in its enumerator, in dispose async, we perform the await join. So, and let's see that it works. And in this example, we first print processing element, and then after small delay, we print finish processing element. And as you can see from the output, the elements indeed are processed in parallel. However, this isn't exactly what I promised at the beginning. And the difference lies here in this additional await. So we have await for each var item in await. Twice the await. It's not what I promised. So let's try to get rid of that. And if we take another look at the low-level code and try to remove this additional await, we will be left with just two awaits, one in move next async and another one in dispose async. So if we want to perform forking in this situation, we have no other choices except to make it in move next async. So it has to fork on the first invocation, and then invocations in the next invocations forking should not be performed, and instead we will just advance the enumerator as usual. And in the end, we will perform dispose async as normal. So, but how to implement such enumerator? The simple part is that we perform the fork operation in the beginning and find the chunk for our thread, and then perform the actual move next for this chunk. But the second part is that we need to somehow save this chunk enumerator and ensure that in the following move next invocation, we could use this saved data instead of forking again. So, but how to store and read this data in the enumerator? And unfortunately, storing it in the state of the enumerator itself is not a solution, because if you make enumerator a class, the field holding the data will be shared across all threads, since the enumerator was created before forking, and each thread will have the same reference for this enumerator, so the same field will be accessed. Another option is to make the enumerator a structure, so each thread would have its own local copy on stack of this structure, and the changes would persist. However, it's where we start being limited by the async await implementation. For structs, async methods are always invoked on a struct copy in the generated state machine. So asynchronous method in structs can never actually modify the struct state. I mean, of course they can, but the change will be lost from the caller's point of view. So, and for the quite similar reason, we cannot use the async local to store the data, because the execution context will be restored to its original state after exiting the move next async method. However, we can create a data store using our parallel context. We can, let's say, allocate a dictionary, a concurrent dictionary, at the moment of forking, and store it alongside the ID. And then create some entity like async local, but it would store the data inside this parallel context dictionary. And with this approach, we will need to manually clear the data, of course, so this dictionary will not just grow and grow. But here we can easily perform it in dispose async. So, and this way we can store data in parallel local and implement move next method correctly. And with this, we basically achieved our goal and eliminated this additional await. And of course, this approach introduced a bit more overhead, since we will need to access this parallel local on each iteration of the loop. However, this overhead should be negligible, especially when dealing with heavy operations that we actually want to parallel. And just for fun, I decided to compare parallelization methods using JetBrains AI Assistant in Rider. First, I used the AI Assistant to generate a program that iterates over a list using parallel for and regular for each, and measures the time. Then here I asked the AI Assistant to add more options with a prompt, add another parallelization methods using extensions from list parallel extensions. And list parallel extensions is a file where I kept both implemented methods, one called sParallelAsync and second one called sParallelAsync2. And AI Assistant made it, and generated code actually runs. And we can see that sParallelAsync with additional await works even faster than the standard parallel for each, while sParallelAsync without the extra await performs slightly slower. And of course, it's not a proper benchmark, but it gives us a general idea of the performance, like it's not drastically slow. And more detailed benchmarks can actually be found also in the repository if you are interested. So, and yeah, let's look at the AI Assistant working one more time. So, and it's where I originally wanted to conclude the presentation. However, while I was working on the preparation, another idea came to mind. So I've added a few more slides, but I promise it will take just a minute. So let's look one last time at this low-level code. One more opportunity we have here is the fact that compiler does not require this getAsyncEnumerator method to be an instance member. So instead of creating parallel enumerable that only returns this lazily forking enumerator, we can actually define the getAsyncEnumerator method itself as the extension for collections and directly return the enumerator here. So now we can just add an await before for each over a regular collection, and the body of the loop executes concurrently. Here, writer even suggests to add a using directive in case this invisible extension method is not imported yet, and the resulting code looks even cleaner. However, from my point of view, this approach is more of an evil. Yeah, I mean, this looks cool and clean, but it makes the intention less obvious, and there is nothing that clearly indicates parallelism. While in the previous approach, we had an explicit indication of this fact with the method name. So, and I'm not sure how big of a problem this really is. So let's vote. We are going to run a poll on YouTube. So please answer. If you had to choose one of these options, would you prefer the first, cleaner one, or the second, more explicit one? And while you are voting, I would like to highlight one thing I hope you will take away with you today. And it's that the unexpected possibilities and room for improvements can exist even within well-established systems like async await in our example. So don't limit yourself to what's already known and push the boundaries. So, and now that's it. Thank you for your attention. And this is a QR code that leads to GitHub repository with this library.
Really nice talk. I was watching it, and when I saw the code example, even before this talk, I was thinking this is exactly spot on, the right balance between crazy and elegance. I love this stuff.
Yeah.
I actually have a question looking through everything, and that didn't came up when I was looking through the code base as well. But did you have to do anything special to make things like cancellation tokens and so on work nicely with this?
Yeah, so for now, it's easy. Cancellation is just not supported. I mean, you can support it, but you will need manually on the each iteration of the loop check this cancellation token. But I assume we could add some checks in the enumerator itself, for example, and support it. Yeah. So, but for in this case, we will anyway need to use the extension method. So like as parallel async with cancellation token, for example, and yeah, it would work then.
Yeah, and then I guess it's possible to do like a graceful shutdown of all of the threads that have been forked and all of that.
Yeah, of course.
Yeah. Cool. I'm looking forward to the commits of that one.
Okay.
Matthias, do you have any other questions?
Actually, yeah. So, and to clarify the things, for now, it's not a like library that is production ready. Of course, it's more like an experiments that I'm performing, but I'm planning to finish some things and publish it as a NUKE. Yeah.
Yeah, one other question. How does this relate to testing, or how does it feel with testing in mind when you test that?
Yeah, so this library itself is not very easy. I mean, it's always not easy to test the parallel libraries, but here especially when it's combining the async behavior with the parallelisms. But in general, if we are talking about user code that uses this library and we want to test it, it's just the same as if user code uses parallel for each, but with a neat syntax. So I don't see any difference here.
By the way, the poll has finished on YouTube, and it looks like people are very much in favor of the more explicit version with as parallel async.
Yeah, and
so not everyone is evil.
Yeah, of course. So yeah, and it's kind of expected because when it's just a normal collection and you just add an await before for each, yeah, you could expect that it's like a normal async iteration over a collection, and for example, you could put the results in a normal dictionary that is defined somewhere before, but it will break in this case. So yeah, as parallel async extension method is the way to go.
Very cool. You also opened up the talk with the fact that a lot of the parallelization options that are in .NET are sometimes incompatible and so on. Do you foresee any issues if you combine this approach, for example, with system.threading.channels?
Yeah, so if you combine it with any synchronization primitive or with channels, it will work fine. Once again, it will work just like in the normal parallel for each, for example, but the things that is actually interesting to consider when combining is the normal async methods. So let's say we have this our special method with parallel tasks, and we iterating over a collection in parallel. And in the body of this method, we can actually await regular methods. So in one of examples I showed, I showed it was await task delay, for example. And actually, it composes quite well. So it actually brings more compatibility between language constructs. But there is another issue, and it's what happens if a regular async method awaits our parallel async method. And actually, it will work fine unless you perform, for example, this case where I show that we await a method that forks, and then it doesn't join. So the calling method is also forked. Yeah, and I supported this behavior in parallel task methods, but if you try to do the same from a regular async method, you will get actually an exception, but it's a good exception. That's like I added a special validation that if you wait a parallel task method from the regular async method, it checks that this awaited method doesn't perform additional forks and etc. So yeah, it's what about the compatibility.
Very cool. Again, one of those things I have to play with because it's like I said, it's beautiful and crazy. It's perfect.
Yeah. Okay, so are there any questions from the audience or?
Yes, actually, yes. That was the next one, and it could have been me, actually. The original question was, could you recommend any book to extend knowledge about async parallel programming approaches in C#?
Yeah, so I can't recommend any books on this just because, especially this, like, no, it's kind of new approach when we can change the method builders, like, but it's maybe, I don't know, few years old, maybe 5 years old. But there are really good talks about this async await and how it works, and they are available on, I believe, even on the JetBrains events. It was some talk from sorry, I don't remember. Maybe. So basically, he told about how async await works under the hood, but without touching the async method builders, and but it's where I get some inspiration from. Let me try.
I was quickly looking for the talk. If I find it, I will definitely post it in the chat. Yeah. Cool. Mm-hmm. All right. Konstantin, thank you for your talk. This was great to see.
Thank you.
I think it's time to say goodbye, not only to you. Yeah. Not only to you, but also to myself, because I will be signing off and bringing in Matt. Let's bring in Matt. Hey, man.
Oh, still muted, sorry. Hi, folks. Nice to see everybody. Fantastic session so far, and I'm now waiting to see Martin say goodbye to himself.
I'm gonna say bye to myself. Bye,
Show
Martin.
yourself out.
Bye.
Yeah, close the
Bye.
door on your way out. This is good.
See you, folks.
See you later. Fantastic sessions we've had so far, Matthias. Although I think I'm going to have to watch Konstantin's again to really grasp that one.
Probably, yeah, me too. I think for people who seen the first talk as well, I was much more involved with the first one because I also kind of have the experience with that. That one from Costa, I would definitely have to look up again. And like I said, this question about resources for async await, it's I don't need that so frequently, but I always feel like I should know more about it. Yeah. I mean, the basic building blocks are okay, but this is next level for me at least.
Yeah, I just feel like so I mean it was great and I followed on along with everything that was going on there. I just want to read it again to kind of really absorb it. Sorry, watch it again so I can really absorb it. But fantastic stuff. I think Martin summed it up there. It's just the right mix of elegant and crazy, which is right up my street. Is my kind of thing.
Right up your street. Right up your street is also the next talk, right?
So enough, I can segue into anything.
For those who haven't noticed it, we kind of had to find some replacements because one of our speakers, how to say,
it was just unable to make it, unfortunately.
Unable to make it, yeah. So Matt and I will present 2 lightning talks. Matt's will be the first. So editing text with ReSharper. You want to start?
Yes.
Right away?
Yeah, let's get straight in there. There we go.
Screen?
Yeah, so I mean, this kind of it's all kind of kicked off after yesterday's session for Andrei Karpov, where we're talking about editing in ReSharper and some of the features that are available and some of the cool things. And it very kindly pointed to a tips and tricks session I did a week or 2 ago, and as part of that, I did a bunch of preparation for it, obviously, and one of the key things that I find there is that I kind of remembered that all the cool things that ReSharper has got for editing text. So not just working with refactorings and inspections. I mean, like here we are, we've got ReSharper on the screen right now, and we've got an inspection there. What's it saying? Okay, parameter roots is never used and it's hiding the name of a variable, and we all know we can do Alt-Enter to give us useful things there. I can rename it, I can discard it, and so on. You kind of get very much into the routine, I think, of working with that, of working with a rename refactoring or Alt-Enter and inspections and things. And it's sometimes easy to forget that ReSharper has got a whole load of brilliant advanced editing features. And so I thought, now would be a great time, especially after what we were talking about with Andrei yesterday, that to go over some of the features that ReSharper has got and to actually highlight some of the cool things that there is there. So I'm going to show a number of tips and tricks around actually editing. Before I do that, though, I have to do it. It's basically a duty. Every time you give a demo in ReSharper, you have to remind everybody of 2 keyboard shortcuts. The first one is go to everything, search everywhere. That's usually Control-T if you're using a Visual Studio key map. If you like to keep it old school and use the IntelliJ keyboard shortcuts like me, that's Control-N. But Control-T allows you to search everywhere. You can just start typing. What should we type? What should we look for? We'll search for shell scope, and you can just start typing. We've indexed everything. We can find things very quickly. If we wanted to go to this one down here, shells configuration sources extension, SCSE, we can then very quickly navigate around. So there's lots of great ways of being able to get to your code from this search everywhere. You can search for types, files, symbols, and so on. And then the other one is, of course, Alt-Enter to be able to do anything. Those are all the context actions. Those are the 2 keyboard shortcuts you need to know. And from that, you can find everything else. And the key way you can find everything else really is this. Let's try and just scroll that up a bit. So that's better. It was upside down before. Yeah, if we look at the Alt-Enter menu, we've got the search icon there. We can just click that, and then we can now start search for actions. So if you can't remember what the keyboard shortcut is for the action, you can just hit Alt-Enter and then start typing. Oops, rename. I don't know. Let's see if it's going to be. Can I introduce a field or something? So you can introduce field, and you can find the features that you want, and it'll give you the keyboard shortcuts. And the more you do that, then the more you'll pick up the actual keyboard shortcuts. So that's the law, basically. Have to teach you everybody to use search everywhere and Alt-Enter. If you do that, you're going to get a huge amount of functionality out of ReSharper. I'm now going to show you a few other things which are not necessarily related to those, but you can always find it from Alt-Enter if you can't remember the keyboard shortcut, because there's going to be a few keyboard shortcuts in this. But first, I'm going to start with things like some typing assistance. So ReSharper is very good at being able to fill things in for you, help you with some of the syntax there. So for example, here, if we do async startup, oh no, I'm just going to copy this code down here actually. So if I just go here, async startup.configure async, you can see it's already put the brackets in there for me. If I delete those and if I type them there, then it gives me the brackets automatically. So it'll also close the bracket when I just type the opening brackets. We've got a number of these typing assists and they're all available for you. You know, if you open a bracket, it'll automatically close it. If I open a quote, it'll automatically close that as well. And quite nicely, if I delete just one, it'll delete both of them as well. So it's sort of keeps the code a little bit cleaner and just helps you keep your code nicely sort of bracketed. So you get your start and your stop things there. And in fact, one of the, weirdly enough, one of the most important bits of advice I remember from one of my professors back at university was learning Pascal. He says, whenever you write Pascal, you always put your begin, always put your end straight away so you don't mess things up. So it's always about sort of bracketing things and finishing that. And now ReSharper does all that for me, which is very nice indeed. Typing Assistance does a number of other cool things as well. So startups here that's going to be an ordered enumerable. Let's start with a list. Let's have a new list of string. Here you go. Quick tip right now. If the cursor's here, so let's just say I've created a new list. I type string. I can hit my enter. The cursor is still inside the template, that's C++, the angle brackets for the generics. I want to hit to get to the end of the line to add the semicolon. I can just type semicolon. ReSharper will figure it out for me. ReSharper understands that if I'm typing semicolon, it needs to be at the end of the expression, and it'll move the cursor for me, and so it'll put it in the right place, which is pretty nifty. And in fact, a useful thing at the end of this as well, if I wanted to do something with that new list, I could just hit the dot, and it's actually now moved that dot inside the semicolon as well. So I don't have to kind of worry too much about getting in exactly the right place, because ReSharper will sort of help me out with that. The thing I wanted to show you with the list, in fact, let's just let's call that one list, and then we'll have an array equals a new string array of one. That's fine. If I want to get the count of something, so I could do var count equals list dot count. Okay, if I wanted to do the count of the array, it's not count, it's length. But you got to remember now whether it's a list or a count, and ReSharper will just fix that up for you. It's a lovely little quality of life type thing. If I wanted to do the try and use length on the list, it'll automatically fix that up for me as well. So it's just trying to help you with your typing. You just kind of automatically complete it, and we'll fix those up. Really nice little typing assistance methods going on there. Another nice one as well, very simple. If I'm creating a method, so if I do void, again, let's do it something, and I want it to be a generic method, I can just do T as my parameter name there. And as part of the actual code completion, it actually gives me a template. You can see this little icon we've got here is our live templates icon there. And that means it's going to run something, it's going to do something when I hit that. So if I just do T, it'll automatically create that there. And if let's just say that was going to be a key, and I can now have my key. Ooh. And so it'll automatically kind of create that for you, because this sort of solves a nice thing there. Otherwise, I'd have to do something like this, T, and I've already got that. So it's something to, and I have to create T and then come in here and T there. And it's a whole lot of extra typing, whereas ReSharper can do that for me. Now, once I've created my parameter here, I now need to add on the the parentheses, not parentheses, the braces. And so I could just go to the end of the method, and I can then start typing and do that. Or I could let ReSharper complete the statement for me. So if I just get back here, and so if I'm doing T key and do key, and what I can actually do is I can use Control, Shift, and Enter to complete the statement. And ReSharper will complete it all for me, which again is a really nice way of being able to not worry too much about the syntax and let ReSharper finish things off for me. And you can see it's added in the braces here, and it's put me in the right place. But it also added the closing bracket there, or closing parenthesis. So we can be here. Nope, get out of the way. So if I'm here, I can see there's no closing parenthesis here. I can just hit Control-Shift-Enter, and it will complete those for me. I can do a similar sort of thing with this if, I don't know, key doesn't equal null. And I can do, again, Control-Shift-Enter, and it'll fill those values there. If I'm doing something like console.writeLine, you can see it's already completed the things for me, but I could just do that. Hello world. If I do Control-Shift and Enter here, then, in fact, let's get rid of all of that syntax. If I do that now, it'll finish the string literal for me. It'll close the bracket, and it'll also add the semicolon. So Control-Shift-Enter is a great way to finish your current statement. And in fact, if I wanted to change that to be something like equals null, I can use Control-Shift-Enter there. The code is already completed, but it'll put me in the right place to carry on. So again, it's a very nice way of being able to jump to the right place and work with it. Other useful features were things that we were talking about with Andrii yesterday, actually, was the structural navigation. And the nice thing with this one is just hitting tab. So I can hit tab and it'll select a current statement. And so if I just wanted to delete this whole if statement, I've selected it, and now I can just delete it. Nice and easy. I don't need to worry about getting to the right place, starting at the start of the line, highlighting the lines, making sure I've got exactly the right number of lines, especially if it's a very long if statement, which is spanning the screen. I'd have to make sure that I'm in the right place, I've got the things matched up, and then delete it. And it's always a bit dangerous. So I can actually just use tab to do that as well. So tab will select it for me. We've got a similar feature, which is extend selection. And so we can do that by repeatedly hitting the extend selection thing. If we want to know what the keyboard shortcut is for that, we can just start typing here, extend selection. And you can see in my key map here, it's Control W. And so I can just repeatedly use this to extend the selection, and it'll just grow bigger and bigger with the scope, which is a great way, again, of being able to say, well, I want to delete the if statement, so I can just do that. And I can delete that. I can delete it safely and structurally. I can do it like a semantic selection rather than just selecting lines, which is much safer working with my code. And I can also sort of expand out, and then I can use Shift in the keyboard shortcut and expand back in again. So it's a nice way of being able to extend your selection and work with the proper sort of semantic block of code. Where this is kind of really nice as well, it's a similar sort of thing with the structural navigation. If I hit tab, it selects everything, but then I can repeatedly hit tab and sort of go inside that block and select the scopes and the semantic objects inside there. So again, here I select the whole if statement. If I hit it again, I select just the condition. And here I can do something different. So if I had another parameter here, let's say, I don't know, what have I got going on in here? This dot, I don't know. Oh, if only there was a useful method there. But I can very quickly change the condition on my if statement using the structural selection there. And I can do a similar thing here. Let's just select, if I'm there, I can hit tab and I can just select it again, delete it, and put key doesn't equal null there. But in fact, if I don't want to type key doesn't equal null, I can use postfix templates. So I can do key dot, and then you can see down the bottom here, we've got more template sort of completions. I've got dot null and dot not null. And if I do dot not null, it'll generate that if statement for me. Postfix templates are a fantastic way of concentrating on the data you're working with, the variables, the parameters, and so on, and not worrying so much about the syntax. You can let ReSharper kind of do the syntax for you and fill in the blanks. So you can do, key dot null, and it'll check those for you. And it's a great way of working. You could even do, I think, if I remember rightly, key doesn't equal null dot if, and I can do that, and it'll sort of wrap that whole expression. So if you want to write a more interesting expression, you can do that. Let's just change the return type here to be T key. And I could do something like key dot return, and it can give me a return value there as well. That's usually more useful when you've kind of, again, sort of got a variable that you want to sort of concentrate on and work with. And so you don't have to think too much about the syntax. You can let ReSharper do that for you. And if we just go into the options, and let's just do a quick search for postfix. Go on, wake up. There it is. Then you can see we've got a whole load of different postfix templates that you can use to be able to work with things. Things like .cast to be able to cast something, which is very useful. It puts brackets around your current expression, but then also gives you the cast method itself. And there's other ones as well. .var is one which I use quite a lot to actually create a variable. So just type the name of the variable, .var, and it'll create the variable for you. You don't need to sort of worry about the syntax. Same with .throw, .return, and so on. Have a look at those options that are available to you there in the settings, and you can see some cool stuff. And I just want to finish then, because we've only got a few minutes on this one, with the one which I like the most, which is moving statements as well, being able to rearrange code. So let's just go, in fact, let's go over to this one here, because I've got a whole bunch of if statements going on here. And you can say we're doing them all as a set of things, a set of sequential steps. And if I wanted to move things around, here I'd have to, let's just fix that bit of formatting there. Here I'd have to do something like, Control X there and then paste it around. But I'm just saying previously, we don't want to do that. That's dangerous to having to select things by line and move things around manually with cut and paste. We can do things better than that. What we can do is we can hold down all the modifier keys, Control, Shift, and Alt. We highlight things there, and then I can use up and down to move things around. We can even do more interesting things here, and I can use left and right and push them. Oops. All right, push it into the scope of the if statement there. So I can move the whole section of things there into an if statement. So I can actually rewrite my code in very different ways there. Another example would be here. So you see we've got a number of different nested items. I could take this try remove, and I can actually move it outside the if statement, up and down, or push it in to the if statement as well. If I wanted to move this around, I can very quickly move the whole statement around and make it very useful. If I can find a quick method with multiple parameters. Yeah, let's see if I can swap those around here. So we can see I've got a tuple here with 2 values, and I wanted to swap them. I can just select all of the items there and move them around as well. I can actually rearrange the code and move it there. One of the nice things you can see is, let me just put that back to normal, is if I do this and move it, then you can see, oh, it's just gone there. We get this, let's do something which isn't a tuple. Let's do this one here. If I move this one around, you can see when it finishes there, I've got a dotted line around everything. That's because I've just changed the signature of a method here, and I've broken my code. You can see I've got lots of red code there. I can use Alt-Enter, apply signature, refactoring there, and then just get ReSharper to fix up the code. So it should then fix up all of my broken code there. So if you use all of the modifiers, and you can move up and down, left and right to push things into methods and so on. And the last thing to show is you can also use that on the closing brace as well. So if you realize that this for each statement should actually reach a little bit further down, I've got 2 options really. I could grab this if statement and move it up, and move it in, and then move it down. Or I could just grab this closing parenthesis and move that down, and it sort of extends the scope of everything. So move statement is really, really useful. The extend selection is fantastic, and also the structural navigation are brilliant. Those are the kind of 3 key features that I wanted to show, which I think we've kind of pretty much run out of time. I could talk about these kind of tools all day. ReSharper and in fact Rider have got some fantastic tools just for editing text, not just for navigation, for quick fixes and so on. And there's a lot of really cool things to see. If you want a little bit more help, just go into the edit menu and have a look and see what's going on here. You can see, extend selection, shrink selection. We should have the move items around there. Rearrange code allows you to move statements up, down, left, and right. And you can learn the keyboard shortcuts there as well. And there's a few more interesting things with some of the completions as well, different completion types and so on. But I think we'll leave that there for now. Matthias, you still there?
Great stuff. Yeah, I'm still there. And you had my
Fantastic.
favorite. You had my favorites in there: expand, shrink, selection, and postfix templates. And you know, it's a good talk if even I learned something. So the generic type parameters for that method with that T asterisk, nice.
It's nice. I just really like it. I like being able to rearrange code. Is just so nice. It's great.
Because that in
you can mix
particular
the
is
two
very
as well. So select something and then rearrange inside an if statement. Lots of fun. How about we raffle a license since we're talking about ReSharper?
Let's do that.
Let's do that. All right. So a quick question to the chat. It'll be the first person who answers. Let me just see the chat there. First person who answers. ReSharper has just celebrated a big birthday. So therefore, what year was ReSharper released? Let's see who can reply first and get a license. And hopefully people have been paying attention. We were talking about it yesterday. I'm not sure we've mentioned it today. Oh, there we go. Mark Oliver's straight in there. So Mark, if you drop us an email, you can drop me an email at matt at, yeah, there we go, 20 years. So ReSharper has 20 years birthday just now, 21st of July, I think it was the announcement for ReSharper 1.0. Mark, if you drop me an email at matt@jetbrains.com, we can sort you out a license. So Matthias, I think you've got something to show us now as well.
Now I take over with the second lightning talk, right?
Yes, please.
Matt, I will remove you. Okay. Hi everyone. Again, also for my talk now, I'm going to talk about build automation with NUKE. That's my personal project I do in my own spare time. And I kind of tried to shrink this down from a full talk, so please don't be mad at me if I skip a couple of slides, but let's just dive in. So first statement I want to say is that we're kind of spoiled, and that is because of great language progression with Roslyn, etc., but also with in regards to tooling. So of course my heart is beating for Rider, but people have a lot of other options, including VS Code and Visual Studio, of course. But yeah, also we're not spoiled everywhere. And that, in my opinion, is particularly with build pipelines. So whatever service or tool you're using, for many of those, you have to deal with some kind of YAML. Yeah. And I will just pick YAML as one of the examples. So it can also be something different. I know Kotlin also has Kotlin DSL, which is quite nice, actually. But YAML in particular, I know a lot of people share this certain sentiment here. So if you don't hate YAML, you might not hate YAML yet. Yeah. If you're good using YAML, I'm not here to judge. Yeah, absolutely fine still. But this shows in a couple of areas. Like for instance, you've probably seen one of those images where people constantly push to their repository to trigger CI. You can make fun of YAML also in other regards, like with tools like these. Yeah, very, very modern development tool with this ruler on there. And I also certainly like memes from Bruno with the YAML issue sitting in the kennel, in the Suez kennel. And yeah, it can be a pain. At least it was a pain for me. And yeah, so summarizing that, I didn't go into each of those in particular, but YAML has certain problems. You cannot execute locally. You have limited tooling, sometimes also hidden requirements. Vendor lock-in is very strong here. Security concerns, especially if you're using, custom GitHub Actions, for instance, where you don't know where who's the author originally, or you're actually not checking what has changed in that action. So there can be some slight problems. Introducing or more motivating my presentation is I like this phrase from System of a Down very much. Revolution is the only solution. And for me, that was NUKE. So meanwhile, I started in 2017 with that project. But what I want to make clear here is what it's not. And first of all, the bullet points don't show up. So I kind of have to just say that it's not a MS Build replacement. It's also not a replacement for the compiler itself, but also not a YAML replacement. Yeah, that leads to the question: what is NUKE actually? And also motivated from what I just said about the tooling, etc. We're spoiled with writing just regular C# or F# like we had today already. NUKE is for people that like to use a make tool, but for people who are like you and me, who appreciate good tooling, while developing their CI pipelines. And there are a couple of projects, if you want, who are already using that, or meanwhile already, okay. A couple of things about the basics. So there's a global tool which you have to install. Not everyone, but at least the person who sets up the build for the CI pipeline. And this is roughly like how the setup looks like. And the special thing about NUKE and after the setup is that you have a full repository, project inside your solution. So you see this build project up there, and this just integrates nicely with your already existing solution. NUKE will take care of installing or doing a SDK bootstrapping. So even if your CI provider doesn't have the SDK installed, it will take care of that. And besides, it's really just a console project. And everyone knows how to deal with console projects. So that's a big win, I think, compared to YAML or some other options you might know or checked out. How does it look? How you're actually writing your build steps? So the real meat that you're gonna implement. It looks roughly like this on the side here. So like I said, console application. So it has a static in main method where it basically just spins up the process. And inside here, I have exactly just one target, which is called compiled. And inside that, the part with the executes, that lambda, that is what actually is happening when you execute that. A couple of benefits here. You see that the target is actually a symbol, so it's no longer magic strings or something that if you ever done something with MS Build can be a pain, because you usually use just find and replace. If you want to rename one of those, you can also see that this has a breakpoint inside, so you can actually stop there if you like. Not like YAML, for instance, which even if you could execute it locally, there's not really a way to say, okay, I want to stop at this particular point in time and check out what has already happened. Also, you can do renamings, like in this case, since it's a symbol. And if we just execute that, then since compile in this case was the main method, then NUKE does its job, executes that build step, and also shows you a summary. A short comparison to YAML, you have quick feedback because you can run this immediately on your local machine. It also runs everywhere, not just on your local machine, but also at your colleagues, even if, like I said, they don't have the SDK installed, but also on the CI server, of course. It's self-contained. I would also say it's very approachable because if you're having a C# solution, then surely you know how to write C#, how to debug, etc., how to do refactorings. And native integration. We had this at the other talk already. Native integration is a great thing to have for tools like that because you get the benefits of all the existing tooling. Talking a little bit about the target model. So targets are basically the build steps. And this is roughly a build graph that you could potentially face. You know, we're kind of starting with compile on the left, but maybe we also want to execute clean. Before that, we have tests followed by Pact in parallel, and there's also a publish, which can trigger an announcement that a new package has arrived. And to kind of formulate those dependencies between each other, there is this target model, and it's very much like a DSL, I would say. We had this too already. In this example on the right, you can see how an execution dependency can be added to the tests. So in this case, tests, the collective target, let's call it, for unit tests and integration tests is just dependent on unit tests in this case. In regards to that plan, something that is quite nice is that you can also get an interactive build plan for how your build currently looks like. So once you hover, you can see what is actually being executed. And that very much depends on what kind of dependency you're using. So there are execution dependencies, ordering dependencies, and also trigger dependencies. Yeah. And I kind of find this funny, where someone was having, I believe, 150 targets or something. So you might want to flip that over. Yeah, interesting thing to see something like that in the wild. Another short topic I want to touch on are input parameters. So how do you get parameters into your build? And I just want to show you this short example of that was part of the Roslyn repository, at least at some point. And this is in the same file, but the left-hand side is at the top of the file, and the right-hand side with those right hosts, etc., only comes later on. And I see one problem here. It kind of violates this locality principle, because you have duplication on different at different spots in your code at different places. And a much better way, I think, is to write something like this with attributes. So we have simple fields, could also be a property, but attributed with the parameter attribute. And that allows us to call the build again and just pass values like this. Yeah, you don't necessarily have to use the command line. It also resolves from environment variables or other sources. There's also a possibility for a configuration file. But generally, this is much nicer, I think. And the resolution of such values supports a wide range of different types, including custom ones, including arrays of those. And something that is very nice is that with NUKE --help, you also get the output of all available parameters. If you look closely at the bottom, you can also see that this would support code completion. So whenever I write comp and hit tab, it completes to something that it knows. And if there are multiple, you get the selection, of course. So this is can be very smart as well. And this is particularly interesting if you're having a very long target name that is easy to make a typo with. You just write the first couple letters, hit tab, and you're good to go, and there won't be any errors. Another interesting thing is the difference between absolute and relative paths. And I've read this book from Jess Humble and David Farley about continuous delivery, and they make a note that the most common mistake in a build is to use absolute paths by default. And I'm sitting here and telling you, you should use absolute paths, and you might look like this, you know. But just getting to the real problem here, if this was an absolute path, what is the real issue here? The real issue is probably the part until the root of the repository. So until NUKE. Docker file sits in the sorry. The Docker file sits in the root of the repository, but the problematic part is users/mat/koch/code/NUKE. Yeah. So why not just simply replace that? And NUKE has a property for that, which is called root directory. And from there, you can just divide it with Dockerfile. Yes, right, divide it. This is the way how you actually write that, but it's of course not the division that is done here, but it's an overloaded operator. Which kind of mimics the path separation. Yeah, and the nice side product of that is that on Windows versus Linux systems, it will decide whether to use / or /. Another byproduct, and also since I'm quite lucky to work at JetBrains and be able to write plugins, is if you look here closely, then you can see that once I type the /, it will complete to actually writing the division operator again. So we can provide some additional nice tooling here. Same also here. In this case, I have a variable with 2 times the same part, let's say, of a path. And Writer, when I extract that, automatically recommends to replace two occurrences. So we keep the code much cleaner than we would do in regular, more like file-based or text-based environments, like with YAML, for instance. It's harder to refactor something like that in YAML. This type, I mean, absolute path and relative path, they're both types. They support a wide range of operations like creating a directory, reading, serialization, also just a lot. Everything that you might want from a build system. Further with tool invocations. So first of all, NUKE supports a wide range of existing tools that people often use inside their CI pipelines. There's one way where you can just use string interpolation. I think this reads very nicely. String interpolation is great. You know, if I remember how you do concatenation in PowerShell, for instance, I remember how hard it was at first because concatenation is slightly different than in C#, and PowerShell is not my daily language to use. What this does is a couple of things. So it resolves tool paths for those tools. You can pass environment variables, arguments, working directory, etc. But there's one case where yeah, you might hit a wall when you even just use string interpolation, and that is, who knows or who remembers what /nr true and /m means? Yeah, if you know, you know, but many times it's not obvious, and that is when NUKE also provides a fluent API. So this example is slightly different, but you manipulate or you create your invocation of a CLI tool using a builder pattern. Similar to the F# talk that we had earlier. Each line is representing a new parameter, and you're just fluently creating your invocation with the help of code completion, documentation also, and you can do funny things like even creating invocations that are conditional in regards to certain parameters. Like in this case, it will only say enable deterministic when it's a server build. So not locally, but only when it's executed on your build server. Nice little thing also here, something that I was kind of proud to implement. NuGet push accepts an API key, but it's actually a secret. And you know, sometimes you just want to make things work, and you may put your secret directly into the source code. This right here will warn you. It creates an error because it knows this is a secret. You should not commit that. Yeah, it kind of makes you aware once you go through your code again, and hopefully to keep you safe. I will skip this one slide. CI integration, some things to say about that. Of course, it has nice logging, so nice colorization, also collapsing, expanding of targets in the middle, what you see there. But also NUKE can generate YAML files for you. So you just put a small attribute on your build class, and that leads to generated YAML. Like I said, we not we all, but I dislike YAML. I'm glad if it gets generated for me, and it's in sync also with the code that you're writing inside your C# implementation. I think I will also skip the partitioning stuff. I want to show you a couple of things about work in progress. Just give me a moment. I just want to check the time until 50. Okay. Yeah. Some last things. I'm getting ready.
I know. I'm just telling you to wind it up. This is good.
Okay. Thanks. So some things work in progress, and I just think those are really motivating in regards to how far we can still go with CI development. And the first one is this little image here. What you can see on the left is that it runs a GitHub action, and we are stopping on the right inside Rider. So in this example, Rider is connected to the GitHub CI build runner, and we can, you see on the lower right there, use the immediate window to execute commands. So this hello from Rider on the left is actually from my local machine on the right inside Rider. We can inspect what modules are loaded. We can even attach a terminal and see what files are currently on that build runner. So a very nice thing, you know this feeling or this situation when you say, oh, something is only happening on CI, and how good would it be to just debug the CI runner? A second one, something that I haven't pursued very much lately, but those are live notifications, which are also updating as the build proceeds inside Slack. So the build will continuously update you with how far it went. There is also the possibility to show an ETA for how long it will run. And the last one is live diagrams inside your IDE. Again, a hard thing to implement, but I was kind of making that partially working. So as you add targets at the top, it will add them in this diagram on the bottom, just live. And this was during development. Yeah. So yeah, I just closed with that slide because my part is over now. I think we want to switch over to the next presenter. If you have questions, just drop them in the chat. I will observe them.
And if you missed this slide as well, don't forget you can always pause the stream, rewind a little bit, and get the links there as well. So thanks, Matthias. That's really cool. I'm liking the work in progress stuff. I hadn't seen that before. That's looking pretty nifty. Debugging GitHub Actions. That's what so need that kind of thing.
That is something that can save your day. I think.
Absolutely. So yeah, you're right, and it's time to bring on the next presenter as well. So shall we bring on Rachel? Oh, there we go.
Yeah,
hey,
I'm
Rachel.
here. So who's up next?
Well, first of all, we're going to say goodbye to Matthias. We're going to do another quick handover. So see you later, Matthias. And we're going to introduce our next speaker. Very easily there, we will bring on Andrii. And
hey,
there
folks.
we go, Andrii.
Yeah.
Hey there, how's it going?
I'm fine. How are you?
Very good, thank you. So yeah, Andrei's a developer at JetBrains. He's got a fantastic talk now on debugging WASM, which is going to be a bit of a deep dive, I feel there. So without further ado, I think we'll just let you get straight onto it. If we can bring your slides on there, and Rachel and I will leave you to it. And good luck and enjoy yourself.
Yeah, thank you, folks. My name is Andrii Rublov. I'm a software developer at JetBrains, and I'm working at the Rider development team. During today's talk, I want to perform a deep dive into the hot reload functionality that we made in Rider, like about the functionality in general and about the Blazor WebAssembly specifics in particular. In addition, I want to show you the way how we actually implemented it in Rider. So a little bit about me. At JetBrains, I'm involved in the support and improvement of the Blazor app execution infrastructure, including debugging and hot reload. Also in the anti-framework core tooling, NUKE package management, and some specific run configurations. In addition, among other projects, I'm the author of anti-framework core and monogame plugins for Rider. By following the link provided on the QR code, you can reach me at any time via different social networks. So let's start from the very beginning. Let's understand what hot reload is and why actually we need it. The idea of hot reload sounds quite simple. You want to change code and see the changes immediately without restarting, without rebuilding, and nowadays is quite a common functionality in various web front-end frameworks. But it's not a new approach to .NET either. It has been used for different types of applications for quite a long time. Let's consider a typical approach to application development. A developer starts an application, validates its behavior in some way, then stops it, changes its logic, builds, and starts it again. And so on from time to time. Even with incremental compilation, such a cycle of work with code takes considerable time, especially if you need to make small changes and immediately validate the result visually. And this is quite a common task for programs that include UI development. For example, mobile applications, desktop applications, as well as web frontend. There are more rare cases, for example, when a program that you need to run should be firstly deployed to a device, for example, and not only for a simple device, but for maybe for industrial machine or something like that, and or the chip on a portable device, and then you need to do it again and again, and it takes some time. Now let's change it and think about how it could be, how this feedback loop could be done on using the hot reload mechanism. Basically, instead of stopping program each time, we now can continuously add changes and immediately see the result. For large, long, and complex changes, it's not very useful because it's hard to apply large changes at once. But to see how color of the button changes and how margins or paddings on different UI elements are changing and how they affect the look of the UI, it's very important. And this is a solution close to ideal because you don't need to do all this stuff if stopping and running again. And this approach greatly speeds up UI development and saves prototyping time when you just want to look at something new and prototype something, and you don't want to have to deal with all these restarts again and again. Now that we talked through the concept, let's take a bird's eye view of the state of implementation of hot reload infrastructure in .NET general, without being tied to a specific framework. Currently, there are about 5 different implementations of hot reload functionality in .NET, depending on the platform, its capabilities, and user needs. The classic and most working approach is implemented in Core CLR runtime. It covers not only the console applications, but also ASP.NET Core and some other rare UI frameworks. Its implementation varies depending on whether the application is run in debug mode or not, as the change delivery mechanism in such cases is different. There is also a hot reload for XAML markup for different platforms. This is beyond the scope of today's talk, as it's very specific to the MAUI and other frameworks, and also the XAML hot reload for VPF and UEP are not currently implemented in Rider, but they will be in some future. Finally, the Blazor Wasm Hot Reload is our hero today. It actually combines 2 types of hot reload at once, but more on that later. Now let's take a closer look at each of these 3 remaining implementations. Let's start with the Core CLR without a debugger. To say to runtime, hey, replace this CLI seal instructions with this, you must first understand where the changes have occurred. In modern .NET, the task of incremental code changes is handled well by the Roslyn compiler infrastructure. It has a mechanism that is expressed in the workspace abstraction. It allows you to create a certain environment around some set of C# files. It could be MS build project or just a folder. It depends on different implementations that you use. And then calculates the changes that we need based on the changes in the source code. The workspace storage itself and the calculation of changes in the Rider implementation is done in a separate process called Roslyn Worker. Once we have a set of changes computed through Roslyn, we can start applying them. It happens through named pipes mechanism, the receiver for which is launched together with the user's application, called actually .NET Delta Applier. Noteworthy is the way in which the required infrastructure gets into the application domain. The mechanism is called startup hooks. With this, Rider injects the .NET Delta Applier, a library that has direct access to the runtime and can apply changes coming in via the named pipe. We'll come back to this beautiful and useful mechanism for embedding into .NET application later. In the slide, you can roughly see a simplified diagram of how such a pipeline for delivering changes to the runtime works. Let's consider a similar Core CLR scenario, but with the debugger added to it. In general, the approach of calculating changes for the subsequent application remains actually unchanged. So let's go straight to the application of the changes to runtime. the debugger worker involved in this scenario in a as a sidecar process of the main user application, and it's starting together with the application, and it implements the logic of working with the particular debugger API depending on the platform, on the runtime type, and other things. From a rider front-end perspective, debugger worker is kind of a facet that has almost direct access to the runtime. It is mainly used for debugging, but in case of hot reload, it also used as a change delivery mechanism, particularly through the COM interface. On the slide, you can notice the annotated diagram where debugger worker actually replaces the named pipe from this previous slide. Now it's worth pausing for a moment to look at what the changes applied to runtime consist of. First and foremost, of course, are changes to the intermediate language code or the specific methods themselves. Also, on most hot reload platforms, if a currently executable method is affected, its current execution will be completed with the old code, and all subsequent runs, next runs actually, future runs, will be executed with updated code. In addition to the intermediate language code, the build metadata is also changed. Debugging symbols are also changed. This is necessary so that during debugging, breakpoints should point to the correct position in the code, and for example, current execution context should correctly calculate values, variables, watches, and so on. And finally, the list of updated types. This information is needed by the runtime to limit the pool of affected types and speed up the hot reload itself. Fortunately for us, IDE developers, all the necessary components stated here are provided by Roslyn from the modified workspace. Although in theory, hot reload sounds like a near ideal solution, it's actually not, because of the complexity of applying some changes to a running runtime, and they may not be available. Such changes are called root changes, and here is the list of a few important constraints in a form of changes that cannot be applied. For example, adding modified dynamic objects, deleting types, modifying interfaces, making abstract methods non-abstract, adding abstract virtual or override methods, modifying the type parameter, base type, delegate type, add destructor for an existing type. You can see the full constantly updated list of by the following QR code. This and other links will be also available at the end of the presentation. If a change is considered root, Roslyn will return diagnostics about what went wrong at the time the change was occurred. Both .NET Watch and Rider support displaying such diagnostics before applying them. And Rider also usually displays the problematic code in the editor. Sometimes, such as in the case of Blazor applications, the pre-applied diagnostics don't always catch potential problems. This leads to runtime refusing to apply similarly valid changes and returning an error. This is due to specifics of the Blazor runtime, which we'll be discussing in the next chapter. With the basic features and functionality of hot reloading in .NET sorted out, let's look at what the additional challenges are in supporting hot reload for Blazor Wasm applications. It should be understood that each open tab with Blazor Wasm application is a separate runtime. Accordingly, having a common code base with the server, both the server and all running clients should receive changes more or less synchronously, or at least in some predictable order. Unlike the ASP.NET Core server that hosts our client application, the Blazor Wasm client itself runs on a specially built mscripton mono runtime. Mscripton, for folks who don't know about it, is a toolkit and a compiler that allows you to turn programs written in low-level languages such as C, C++, and other ones into JavaScript and WebAssembly modules. Mon runtime was much easier to port to a browser than CoreCLR. That's because which at the time of Blazor creation was not yet ready for such porting. So that's why we have Mono for Blazor. As we discussed earlier, CoreCLR receives changes via the named pipes or COM interop. In case of Blazor Wasm, things get more complicated as we need also to have indirect access to the isolated browser environment and to the runtime, Mono runtime itself. The runtime can be accessed using the JavaScript API from the JavaScript wrapper over the runtime itself called .NET.js, and communication with the page itself is performing through the WebSockets. Since each new page Blazor Wasm application creates a new separate runtime, just updating existing clients by adding new changes to them is not enough, because you also need to have a mechanism that aggregates and sends out the changes made before new pages was loaded, because they are not available in newly opened pages, of course. And by the way, updating, refreshing a page also causes the past runtime to stop and create a new runtime of the same page. So this is true. And also, but for example, if you navigate inside the Blazor app to the other component or page in your app, runtime persists the same, because you don't do a real navigation. You just do it inside the client side. So it's not a navigation actually. So the runtime stays the same. In addition to changes to the source code that the standard hot reload mechanism in .NET covers, in the case of frontend in general and Blazor Wasm in particular, mechanism for updating static files such as JavaScript and CSS must also be provided. Currently, the hot reload infrastructure only supports updating the CSS files, including scoped CSS for specific Blazor Wasm components. The HTML code update logic must work both for specific elements with links to CSS files and for all available style tags in order for the update to occur correctly. Caching always creates new problems for developers, although it's considered a very useful approach in production. You have to use special tricks to ignore the cache when updating static files, the same CSS on an existing page. So let's summarize the Blazor Wasm specific items that should have been considered during the implementation. First of all, changes should be applied for both server and all connected clients. Different applying mechanism for different runtime types, because we have CoreCLR, we have Mono. Delta aggregation and distribution is mandatory for both new clients and refreshing ones. So we need to keep all clients in sync with all changes, actually. Static files should be handled in completely different from .NET Core manner. And of course, HTTP caching should be bypassed, as we talked about that a second ago. Having dealt with the theory, let's move to practice. Let's analyze the implementation of hot reload infrastructure for Blazor Wasm in Rider. So it's worth stating with an overview of the architecture we have implemented. Some of the elements are covered by the fog of war, but it's worthwhile to understand what is going on so that we can go to each element separately in the future. I should note right away that there is no demonstration of hot reload on this scheme, the demonstration of the hot reload for ASP.NET Core server code. And here and below, as it has no differences from the usual CoreCLR hot reload that we touched on in the first section. Here we have only client's hot reload mechanism. So Rider frontend in the core Rider is the core Rider process with the UI interface, where the user writes interface. Roasting worker we are already familiar with, and here comes the browser fetch host. it's a special process that is responsible for communicating with the Blazor Wasm runtimes in the browser. One of the two key elements of this architecture of the hot reload infrastructure. Communication with it from rider takes place via the RD protocol. It's internal rider protocol that is used for almost all inter-process communication in the rider ecosystem. Also worth mentioning is the browser refresh library at the right side. It's a library that is amped in the application server-side code in a special way, thus affecting the client infrastructure that is returned from the server using the HTTP. So now let's go directly to the sequence of generating and applying these changes. Firstly, rider starts the browser refresh host that we talked before, WebSocket server that distributes changes across all connected clients. Then rider starts the apps server with injected middleware through the browser refresh host, just browser refresh. When browser opens the apps page, HTTP request loads modified HTML with injected Blazor Hot Reload and Aspen Core browser refresh scripts. Then the scripts asks server for already applied changes from the past instances, applies them if needed. Then the script establishes the WebSocket connection to the browser refresh host. And when user changes source code, rider asks roasting worker to calculate data. Yeah, so brace yourselves. There's more. A rider sends calculated data to the browser refresh host using the RT protocol. Then browser refresh hosts distributes the changes to all connected clients. Then Aspen Core browser refresh script applies new changes to the client, to each client actually, and also sends a post Blazor Hot Reload request to the browser refresh middleware to aggregate newly applied changes to the future clients. And that's actually it. It's a really high-level overview. It's okay that is something could be unclear. It's okay at this stage. Client-side hot reload is finished at that moment, and after that, the user can observe the changed interface and behavior if no errors occurred at any stage of this process. And this is possible as the runtime may not be able to complete some specific changes that work well in core CLR, for example. Now let's look at each component separately to better understand how they work and why they are needed. Browser refresh host is a separate process that is a WebSocket server, actually. Also, in addition to WebSocket connections, it has a direct communication channel to the rider frontend, from where it receives the request to apply changes. Its responsibilities include polling connected clients for available features, which may differ from version to version. So it's actually each running application through this browser refresh host. They have a set of hot reload features, and they are incremented from each release from one release to another. And that's why we should also count this, keeping in mind that some clients can have different features, and they are not always have a one-to-one mapping from the SDK version to the runtime version. So also, one of the responsibilities is receiving the comments from the rider frontend through the RD protocol and validating and actually relaying these comments to the connected clients, broadcast these comments to the connected clients via the WebSockets. We can say that browser refresh host is kind of facet over the connected clients and a kind of hub for them. The clients in turn return almost no information except for possible diagnostics in case of change application error, for example. And you may wonder why it was necessary to create a separate .NET process to implement this functionality. Why not just to do it in rider frontend? The point is that browser refresh host reuses logic from a library called browser refresh agent which is a component or a part of open source .NET Watch application. Since the rider frontend is written in the Java stack using Kotlin and Java, in order to not to rewrite the whole thing from scratch, it was decided to put the logic in a separate process, which also simplifies support when updating the .NET SDK version. Also, this browser refresh host actually lives no longer than the application, so we don't need to have it running all the time while rider is running. So that's why also it's simpler to just kill it, having the separate process with the implementation borrowed from the .NET Watch in some cases. Now let's move to the browser refresh library. This is also an almost unchanged version of the library that .NET Watch uses when calling .NET Watch run, for example. It has several functions or responsibilities, all of which are implemented as native ASP.NET Core HTTP middleware. I would like to focus on how we add these changes to the user's application, because we host it together in the same application that user. We don't spawn anything else here, as this can be extremely useful outside of the hot reload context as well. We use two mechanisms to do this, startup hooks and host and startup assemblies. Startup hooks allow external code to run in the same domain as the main.NET Core application. This gives room for implementing different features, such as, for example, adding environment-specific security logic for loading assemblies. Imagine you have some production environment, you have deployed application, and you want to enforce some rules, for example, for loading assemblies. And you could do it for via the startup hooks quite easily. Host and startup assemblies are similar to startup hooks, but they allow you to configure the application on the ASP.NET Core infrastructure level. For example, to configure the host builder. This is where the middleware we need is added, actually. What do these middlewares add? First of all, they provide additional endpoints for client code. Framework Blazor Hot Reload with post method submits applied changes from the client, get the same endpoint, but with get method, it returns all previously applied changes to on fresh client. So fresh client requests it, as you will see in future slides. Framework clear Wasm browser cache actually clears the local browser caches by responding to the user with the clear site data response header. Currently, it's used only for static files like CSS and nothing else. Also, they get ASP.NET Core Browser Refresh JS and Blazor Hot Reload JS. They respond with they just host additional static files that are used later in the client Hot Reload process. Let's focus on the client-side infrastructure now. Besides adding new endpoints, Browser Refresh library modifies the index.html file in a special way. It adds or injects the ASP.NET Core Browser Refresh JS script, which is the client part of the Browser Refresh host, to the end of the body tag, actually. By the way, because of the way this logic works in the .NET SDK, we've seen bug reports from users where this mechanism didn't work because they had response compression enabled. It's actually quite simple to enable and quite hard to diagnose, and which in turn removed the ability to edit the response clearly from you can't edit the response in as a clear text, just a text, because it is compressed. And because our startup hook and starting hosting assemblies are added below the actual user's code, we can't just to inject the stuff before the compression. That's actually the problem. Also, compression at the level of hashing, additional hashing, and even if we could modify this text, we will fail the hash checks. So that's also we need to keep in mind in implementation, implementing this stuff. But there's nothing actually we can do with that right now, because the .NET team has some plans of changing this behavior, but not for now, actually. Let's move now directly to the scripts that work with runtime and accept changes from browser refresh host. Let's start with the Esmet core one. It sets up the connection to the browser refresh host WebSocket server and handles messages from it, applies changes on request, provides server with supports and hot reload capabilities. It's some sort of versioning, yeah, and shows nice check mark at the end. What is Blazor Hot Reload actually? It's a special additional quite tiny script that is used only to fetch the changes that we applied previously on previous instances, previous pages. And it is loaded by the Blazor WebAssembly script on startup. Actually, that's a little bit of typo here. It is loaded not by the script, but by the .NET interop, as we will see in further slides. And also applies this delta previously aggregated on the server. Finally, let's go to the code. The logic in the script will execute as soon as the script is loaded. So in this script and the further down the slides, the code is a bit simplified and cleaned up from additional checks, validations, and so on. The full code can be found on the .NET Watch source code links at the end of the presentation. Near the number 1, the variables where the real WebSocket endpoint and the server K will go are highlighted in green. So they will be replaced by the string manipulation on the response side. So they are delivered to the user client side with the actual strings here, because after a browser refresh host starts, it hosts occupies some ports for the WebSocket and generate the key that is after that used by this infrastructure. How it's passed actually. When we start browser refresh host, we gather the information about port and key. And then when we start actual application, we provide some additional environment variables that are read from this actually from browser refresh middleware. And then they are used. So this is done by environment variables actually. And the most interesting comments that come with the browser refresh host are highlighted near the number 2. The full list may vary from version to version, but we will focus on these two, actually. And let's go directly to the application of changes to static CSS files. First of all, we reset the browser cache, solving the problem of future loading of old styles, because without that, we may load old styles even with the other mechanisms applied for clearing the caches. Next, near number 2, the most interesting part starts. To reset an old style, we create a copy of the style tag, then changes the reference, the link in it, so that it contains the current timestamp, which ensures that the browser will make a new request to fresh CSS file. That trick is used in a lot of different hot reload mechanisms across the web frontend, for example, in React or something like that. Once the new file is downloaded, the old style tag is replaced with the new one, and the old one is deleted. So actually, we fully replace the script tag, and this also forces browser to refresh styles in different elements. That's the kind of uncomplicated magic that goes into updating these CSS static files. Then let's move on to applying .NET changes. It's pretty straightforward here on this stage, because JS client-side performance applying consists of 2 parts. First, we call .NET apply changes via the JS to .NET interop. Then we notify the server that the changes have been applied on the current client, and this is to ensure that future clients also get the changes on their startup. Now, a tiny script. This is the whole content of it, actually. The second script is just to get the actual applied hot reload changes from the server at the start of a new instance of the Blazor application. That's what we put them in there in the previous slide. Then we go back to the .NET from JS again by calling the same apply hot reload as we had actually here on the first highlighted line. And that's actually it. And then let's look at how this .NET client-side interop looks from the .NET side. We've seen how it's called, but how it's actually look. In the Blazor core source code base, there's a special WebAssembly hot reload class that configures the interop and is essentially a layer between the JS code and the mono runtime. Near number 1, you can see the call to apply old changes from previous clients. Near number 2, you can see the import of JS function actually to do that. Then near number 3, you can see the methods that we export and use on previous slides. It in turn calls the hot reload agent apply changes method. And the hot reload agent code, it's also bundled with the SDK. Actually, it's quite complex, but it boils down to calling the metadata updater apply update, a method from the system reflection metadata namespace. Internally, this method, depending on the implementation of the runtime, applies the changes already at the level, at the really low level for each runtime. For example, in Mono 1 or CLR 1, this is where implementation differs. The mechanism for storing changes for future runtimes is quite simple. After notifying the server of the applied change, it stores them in a thread-safe collection in a strictly ordered manner. These changes are similar to Git commits in concept, so they need to be applied in the correct order because next changes could depend on previous changes. That's quite often, for example, when you change UI consequently and you have one change of the button, for example, another button, and they need to be one after another. Then when a new runtime is started, the changes collected on the server will be returned as a response and immediately applied. Theoretically, if the hot reload session is long enough, launching a new runtime after many iterations and a lot of different instances can be much slower because of the N1+ problem. We have a lot of changes to apply. They are not aggregated in terms of, they are not collapsed into one single change. They're just stored as a couple of changes, as a set of changes. And however, in practice, hot reload sessions are really rarely long because it's actually, and changes are quite small. So each application of the change is quite easy operation to perform. Knowing what we know now, let's trace the journey of change from the beginning to the final recipients. First of all, Roslyn calculates changes on request from the IDE. Then changes are applied to the ASP.NET Core server level. That's what is out of scope of this talk, but it is actually done prior to making them on the client side, because we, for example, need to provide newer style CSS files, newer other stuff. So we need just to do it before. Then actually IDE sends changes to the browser refresh host via the RZ protocol. Browser refresh host after that broadcasts the changes to each connected client page with the ASP.NET Core browser refresh script using the WebSockets. And ASP.NET Core browser refresh calls the managed wrapper apply hot reload delta using the JS to .NET interop. Apply hot reload calls the actually metadata updater apply update and passes changes there. So that's what we saw right before. And after successful apply, ASP.NET Core browser refresh sends the changes to the ASP.NET Core server for future clients. Now finally, let's summarize the entire thing, what we talked today. Hot reload is really crucial for the UI development. as it's really speeds up the development and simplifies the feedback loop for doing such small and consequent changes. Blazor Wasm Hot Reload consists of 2 stages: server hot reload and client hot reload. And we need to apply on both of them, and that's also need to consider the way of rolling back the changes when, for example, something went wrong, but unfortunately there is no rolling back mechanism. So we need to just to ask user to restart, for example, the application in case Cecil successfully applied the changes, but Mono didn't. Runtimes on new and refreshed pages will receive changes from previous pages runtimes. This is really important, and that's why I am repeating this again and again for the whole the presentation, because it needs to be persisted in such a way that future clients should receive also the changes that we done to have a consistent application state. Then static files are made differently from regular .NET Core updates, because we need to do it in completely separate hot reload, but this is done entirely on the JS side. Server-side hot reload infrastructure is injected into app server using startup hooks and hosting startup assemblies technique. So this is about modifying the client-side scripts and so on. And the client-side hot reload infrastructure is injected directly into index.html and represented in several JS files with interop calls to .NET side. That's there are a lot of interop coming from firstly from .NET to JS, then again to .NET. So there are a lot of layers of reality coming here. So it's sometimes hard to debug and to traverse, but that's quite interesting. And messaging and data applying between IDE and Blazor client is done indirectly using WebSockets and RD protocol through the Blazor browser refresh host, actually. And that's pretty much it. I hope that the talk was not only a brain bowling, but an interesting deep dive into the magical functionality of Blazor Wasm. And thanks you for your attention. You can find the slides and links from today's talks by following this the link or from using the QR code here.
Hi, Andrii. That was a fantastic session. Thank you very much for that. I had no idea quite how many moving parts there were to this.
Yeah,
it's quite a complicated scenario.
Yes, that's it, because it has a lot of actors acting in this scene. So yeah, it's quite tough, and it's not straightforward to see the why it's so a lot of things going together.
Yeah, just call it the Atom Smasher, because it feels like that. There is a lot to it. So there was a lot of questions too. Well, I'll start. So somebody toward the end mentioned in the larger projects, Hot Reload isn't working for them. Is it just that you can make some minor changes, and I'll add this on top for myself. How far can I abuse this? Like if I make a change, run it, can I then write like half the app while it's running? Because I'm going to try to pull that kind of crap. So can I?
Yeah, actually, according to the large projects, we have some reports and limitations and problems with that, because when in theory it comes quite easy. You modify one assembly, you modify one static file, and everything goes quite well. But when it comes to real application, when it comes to different proxies applied, when it comes to different assemblies embedded in the for example, if you have Razor components libraries, or when you have some different injections of complex things in real applications, of course, hot reload could hang up and doesn't work as it intended to work. But in such cases, each case is quite unique, and we need to test it and reproduce to actually have it properly made work with our infrastructure. We are quite limited in things that we can do because the half of all the stuff is done not only on our side but on the runtime side. And if runtime has limitation on that thing, a particular thing, and that means that we can't actually do it properly. And to test it, actually, that is a problem with runtime. It's always an option to run the app through the .NET Watch Run, and to see if it works there. If it works there, actually we can support it also. But if not, it's nearly impossible from our side to have it done without having the pull request merged into the .NET runtime.
Wow, and that raises an interesting question as well. How do you test this? I know Ride and ReSharper, we've got thousands and thousands of automated tests, but there are so many moving parts here, so many pieces. How
Yes.
do you, have you got an infrastructure to kind of spin up everything and make it to test it?
Actually, we use, we are on the way of writing the proper test, because previously, a couple of years, it was small amount of tests for Blazor itself and for the debugger and Hot Reload, and Hot Reload landed into Rider just in the beginning of this year. So it's a bit a new feature, but we are on the way of writing proper tests for that. How it will be done actually is that we will have a complete integration test. So we will launch the Rider in the headless mode. We will launch the Chromium browser also in headless mode, like we had in the debugger test, for example. And all this infrastructure we will have up and running, that the whole thing that we have here, almost without any mocks and stubs, and it will just work. Of course, it will also introduce some flagness and all the stuff, but we'll, I think, manage it out.
Mm-hmm. Yeah, so I know our QA department are very busy with all of these things and doing lots of good things with the testing there. But yeah, automated testing would be fantastic. Although I can imagine, yeah, flaky tests this one could be a bit tricky to get right there. Another sort of question, really, you kind of mentioned, Hot Reload has only really come in with this year. Right at the start of your presentation, you were saying that there's lots of different implementations of Hot Reload. I kind of really never thought of it like that, but it makes sense. You got Mono, you got Core CLI, you got all this kind of thing. Do we have are the processes for Hot Reload common and shared, or are we actually having to do custom support for every single different type of Hot Reload, and therefore takes time?
Yeah, actually, if it comes to, for example, regular hot reload, that is when we hot reload, for example, changes in core cellular runtime or in mono runtime, the mechanism of applying the changes inside the app domain. So when we have changes somehow made their way to the runtime, and the application from the code perspective is similar. So we just call metadata updater from the system reflection metadata package, and that's it. But the difference is in the transporting the changes from the IDE to the runtime mostly, and also XAML Hot Reload, for example, works in an absolutely different way. They inject some different stuff in the app startup, and they do completely different work on that. But the Core Cellular Hot Reload and Blazor Wasm Hot Reload, Mono Hot Reload in this case, are quite similar on applying changes, but are completely different on transporting the changes from the IDE. So some things, I would say, some things that could be shared, but a lot of changes, a lot of differences we can't share. We need to implement it again and again. From the rider perspective, for example, when user changes something and then see that the bar that apply changes and so on, this is actually quite similar to all different code reloads we have. So from this side, we only the one missing part we didn't implement yet is that when you, for example, when I showed on the slide, when we have supporting root changes, it is not supported in Razor files right now, but it is supported in C# files, and we will also support it in the future.
So is that a limitation? If it's not supported in Razor, is that a limitation from the Rider implementation side or from the .NET runtime side?
This is the limitation of Rider. So we just did implement that, but we will do in the future. Yeah.
Mm-hmm. It is hard to know. I mean, from your talk as well, it's a little hard to know quite what is Rider's responsibility and what is the runtime's responsibility. You know, so I don't know, you know, how much have we built? Well, not me, not we. Yes, I mean, look, I'm taking credit for this. How much have you built versus how much is being provided by the runtime?
Yeah, I would say it's 50-50. So we have from like as you said, we have like Hot Reload have two parts from this perspective: the runtime side and the tooling side. And the tooling side should be almost entirely implemented by us, but we also reuse the logic from .NET Watch because we don't want to implement it on our own, because, you know, when changes come into the .NET Watch, we also need to port them to our own implementation. Of course, if it's in a different language, it's really hard to do. So it need to be done manually. And but we are trying to base our changes on really already made changes in .NET Watch. So I would say 50-50, yeah.
That's crazy. Again, I had no idea of all the moving parts that were associated with this and how much effort has to go in to get it supported, and that each different type of hot reload has to be implemented separately and stuff. It's crazy things.
Let's add more to it because why not? So Rider has remote development. Does the model change for this? Does it get worse? Do you need to adjust infrastructure? Does SSH tunneling take care of this, or no? How does that work?
Wow, that's great that you mentioned remote development, because that's the feature that I'm working on right now on the actually for Blazor. Actually, it has a lot. It adds additional layer of complexity because you have done all this port forwarding, a lot of stuff additionally to work this out. But I'm planning to add this to work like that. So we will have only browser running on the client, and all other stuff, including all other infrastructure that I mentioned today, will be on the backend. And this adds the complexity of having the forwarding of WebSockets, forwarding the other stuff. But actually, it will work like that because, for example, there is also a debugging that is was out of scope of this talk, but also there is some difficulties when you have to apply the changes and changing the symbols and all the stuff in the debugger side. And but that it will work like that, I believe. So only the browser will be running on the client, and all other stuff will be done on the backend.
Yes, so, I mean, just to back up a little bit in case people aren't aware of what the remote development is there, that the whole idea of that is running Rider with your source code and all the toolchain and everything on a remote host, and then you connect to it from a local machine, and your local machine has essentially a cut down version of the IDE of Rider itself without any kind of language processing going on there. It doesn't download any files or anything, or everything runs on the remote host, and you can connect to it and get the same sort of experience. And so what you're saying here is then in this scenario, the ASP.NET server would run on the remote host, the browser stuff runs locally, and does that mean it brings down the Wasm stuff as well locally? So all of your WebAssembly runtime runs locally?
Yes, that's right. Because they are running in the under the browser pages, and if browser running on the client, the runtime also will run on the client. But of course, we need to have a communication from the backend to the client, to have all this working stuff like breakpoints and other communication with the debugging side, applying changes. All this will be done via the port forwarding and other techniques. But you're absolutely right with this. Yeah,
that does add an extra layer of complexity to everything.
Yes. Yes.
Yeah. Well done for suggesting that one, Rachel. Yeah, just to try and make it even more complicated.
I actually now forget how many layers there are. There's so many.
Yeah.
All right.
I
How
think we're
about
gonna-
a softer one?
Mhm.
Also, it could be a bit of an interview question. What feature are you still working on that you think will have a big improvement? It's from the chat.
So as I mentioned, the remote development for Blazor, this is my first priority for the Blazor subsystem, actually. And what I'm working also in the future, we have some gaps, for example, to the debugging support. Right now, for example, we have the best debugging support for Blazor across all IDEs and editors, because we implemented in new debugger implementation from this year has another a layer of complexity and implementation that currently in the other IDEs and editors. And but it still lacks some features like Smart Step Into for the Blazor files. Some other things related to Razor.
Is that debugging Razor files? Is that debugging?
Yes. So Smart Step Into, Smart Step Into inside the Razor files, Razor component files, because Smart Step Into works perfectly in Blazor for C# files, but unfortunately it's still unsupported in the Razor files. That's pretty much it for the plans, from nearest plans to accomplish.
Yeah, sounds great. Good luck with those. That's tricky.
Thank you.
I think we've got another couple of questions from the chat as well. I think it was going back to sort of some of the diagrams you were showing there. Does Rider deliver the hot reload deltas to all of the connected clients?
Yes.
So if you've got a browser, if you've got multiple browsers, multiple tabs, multiple iframes, and they're each running a runtime instance, if you hit something in Rider, it pushes out to everybody.
Yes, that's right. Okay. Can you show my slides again? I will just I will show this specific.
Yeah, I'll do that just now. Hang on a sec. There we go.
Let me show the actual architecture stuff here. Yeah. So as you can see here, we have a browser refresh host, and this is the entry point for changes coming from the IDE, and then each page, regardless of the browser when it's open, it connects to this browser refresh host via this special injected JS script, and then it become acknowledged by the browser refresh host, and after the change coming here, it broadcasts to the all connected clients. So more on that. When new page is opened in the browser after some changes were applied in the previous client, this new client will also receive these changes as I showed here. So each change is tracked on the server side, and when new page is opened, it also borrows all these changes came from the previous runs or previous pages. So that's it. Yeah.
Yeah, so the broadcast, I've forgotten the browser host. That basically tells the clients to get the deltas from the server. So it doesn't. The browser host doesn't. Let me rephrase that. Does the browser host push the deltas itself, or does it tell the clients to go get the deltas?
If it's a change that is happening right now, it goes through the let me show you, from the browser refresh host by itself from the Rider, but the change that is aggregated on the server for the further clients, it's coming from the client side. So when client applies changes on, let me show the code. When client applies changes here, as you can see, after that we push these changes to the server using the Blazor Hot Reload endpoint, and that means that further clients will download these changes and apply them by this logic done in Blazor Hot Reload. So it downloads and then apply by one coming from the server. Yeah, but browser refresh host doesn't send changes to the server. It is done by the client because these changes should be preserved only after client fully acknowledge that and applied them. That's why we can't just throw it to the server from the browser refresh host.
Yeah, that makes sense. Thank you. Thanks for going over that one. Rachel, have you got a question ready?
Yeah, how about if this is another one of those interview kind of questions. Shall we hire Andrii? Let's see. If you were to design Hot Reload in .NET from scratch, what would this look like? Would it look the same, even close to the same? Would it need the same infrastructure? What do you see that's right off the top that might be more efficient?
Yeah, so if you're talking about making this whole stuff from scratch, that's a tough one. It's like the .NET team had a perfect job of perfect work on this stuff, and they implemented it's quite great. And what can be done better? I think that some tiny parts of this whole mechanism, for example, the let's say the injection, the injection of actually. Let me jump. Yeah. So, for example, injection of this script could be done better. And for example, it's because it adds the problem of having the response compression, as I mentioned. So, and this is done very rough. So this script is added just by the string replacement of the body tag. So they just find the closing body tag and then just replace them with this script, and it could be done better. But it is nothing related to performance. Maybe also it is a great idea to aggregate all these changes in some snapshots or something like that, to apply them not one by one for user clients, but as one major change. It's of course creates some problems, for example, when different clients have different set of changes applied already, and we need to somehow find the difference and apply only the part of the change that needed, but that could improve the performance, I believe. So it will look like a real event sourcing mechanism here. So it's really similar to event sourcing. So some mechanism that involve event sourcing, they also have the snapshots and some sort of aggregated data stored in one event, for example, and so on. So yeah.
Very cool. That's a great question as well. But it's from the way you've described everything, it kind of feels like this has to be the solution mostly. You know, it's like you've got these problems.
And one thing I also want to mention in terms of what could be done better is the diagnostics, because when it comes to applying changes, runtime is very silent if something went wrong. And that's a problem because debugging the Wasm runtime itself, not the code, but the runtime itself, it's quite a complex task. And because it includes not only JS side debugging, but unmanaged debugging inside the browser, so it's quite tough, and it's the Microsoft, the .NET team actually that works on that. They have a great article of how doing this debugging. It's hidden in somewhere in the sources of the .NET runtime, but actually it helps with that. But it's really great to maybe see in future to have better diagnostics, and that's what I would done better maybe if I would implement that from scratch. That's diagnostics are very important in finding why the changes were not applied. For example, what specific thing was wrong on apply. So we have great diagnostics from the Roslyn. Why we can so as I presented one of the slides. So the diagnostics coming from Roslyn on before applying, they are great actually, but this is not. They are validated on the delta calculation, this is not diagnostics on apply. So and on apply, some things could went wrong. So that's why better diagnostics is a key for better hot reload.
Yeah, speaking of the unsupported changes, I like the phrase rude changes. Speaking of the rude changes, is the list of what is and is not supported changing as the runtime, with different versions? So are we going to get to the point where we can replace more and more types of code?
Yes, I think so, because the .NET team, from one version to another, they improved the hot reload mechanism, especially for Blazor, for example, because, as I said, the Blazor is another type of runtime, and that's why the features should be implemented twice, one time for core CLR and second time for non-runtime. That's actually true for any feature of the runtime supports, and not only the hot reload, but they doing great of reducing the number of unsupported changes. But some changes, I believe, maybe will never be handled, because they involve really a lot of runtime modification from things like I don't know, I don't have an example, but I think that some things that will never be handled correctly, but majority of them will be, I believe, done in the future. If there will be like a request from users on that, because so I believe that they will implement.
Yeah, because that kind of plays into another question we had from the chat, which was asking if hot reload will ever be as efficient as other stacks like JS and PHP, because it can, it can be really frustrating when it comes to the stack, because you lose time rebuilding the solution. So I guess the more things that can be supported here, the better that would be, I guess.
I think that it depends on the specific features that the user means, because I really also think that in web front-end frameworks, the hot reload works better. It is simpler to implement in web frameworks, because in majority of cases, of course, we have TypeScript that we need to preprocess, but actually, the idea of JavaScript is dynamic stuff, and in .NET we have complex runtime side of the question and the compilation side of the question. And so, of course, somewhere in the future it will be as efficient, I believe, as the front-end one, but not now. I really think that it's a great technique, but it still lacks some features that will make it feature parity with the other frameworks like React or Angular or something like that. So yeah, that's it.
Cool. And just to follow on as well, what you were saying with the unsupported changes, you're having to do it twice, once for core CLR, once for mono. Do you know if there's a timeline for replacing mono with core CLR in WebAssembly?
Unfortunately, I don't know.
Is that going to make your life easier or harder?
It will make my life harder, because I need to re-implement all this stuff. Even with the shared code, it will still have a lot of things done. By the way, I don't know what is the state of WebAssembly threads in the .NET 9, but right now debugging with it doesn't work in any of IDEs and editors. I don't know what's going on, but yeah, we will investigate in the future. But actually, that's about the things that will make my life harder, because thread support. Right now, debugging Blazor Wasm apps, it's just debugging one thread, managed thread. And in future, it will have a lot of threads, and that maybe will have another thing to accomplish.
Well, it seems that you like complexity, so this is good. We have faith that you can make it work.
Yeah, that's true.
Rachel, do you have any other questions?
Yeah, there's one more here. From the chat, someone asked if there's any capabilities for Blazor Wasm, the app itself, to acknowledge that the hot reload happened. And I will ask, because of that question, looking back yesterday at Konstantin's talk, he explored, elegant and crazy, and also the question I posed before about abusing things. Like, so is there a capability for the app itself to acknowledge this? And then can we abuse that and patch apps on the fly?
Yeah, so that's a great question, actually. I don't know. I don't know at the moment. So I didn't think about that in that manner, about having the client side know about the hot reload happened. Because we, as for example, in the debugger, we have such event. We can actually react on the event from the mono runtime about the edit and continue happened. But actually on client side, there is no such API, I believe.
So a nice try at being evil there, Rachel, but you've been foiled this time.
At least 50% of my attempts get through.
Well, that's still a very high percentage. I think that might be all the questions we've got there. I think
bonus
is that right,
is
Rachel?
tied to that, right?
Sorry?
Bonus is tied to that percentage, right? Or do I have the wrong metric?
The evil percentage, yeah.
Yeah.
Well, mine's on bringing that down. Yours is raising it up. So we've got some tension here. Anyway, yeah, I think that's all the questions we've got. Andrii, that was a fantastic session.
Yeah.
Really interesting deep dive into all these moving parts, all of these spinning plates that you keep going. I'm amazed really at how complicated it is and how well it can work with all those different moving parts. So once again, thank you very much for that.
Thank you very much, folks.
Thanks.
And we'll say goodbye to you. And I think it's going to be time to bring in our next host.
Yeah, I see the complexity, not just here, like in our software, but in a lot of software. And then I sometimes just, you get on an airplane or other, modern advances, and I think, how does anything work at all?
It is a miracle.
Right?
It's a total miracle.
I try my best not to think about that when I get on an airplane, gotta say.
Yes, but yeah, definitely there's a lot of moving parts. Yeah.
Yeah, but fascinating how that works. It really is. It
is. That's crazy.
And throwing remote development in there as well. There's just
And then those people who want to abuse things.
Yeah, Matt, you're gonna leave me alone with Rachel? Oh my god, I'm terrified.
I'm doing a runner. It's like I'm gonna check my airplanes are safe.
Oh geez. So, but yeah, I think now, Matt, I'm gonna force you out. No, I want to thank you for hosting and doing such an excellent job. So
I think the nicest things.
Yeah, you are my boss. All my financial security is tied to your ego, so I need to make sure.
Are you making your evil metrics?
This is good. Yes, keep it coming. This is fine.
Oh, Matt is the best. And I'm not just saying that because he has absolute power over me, but he is the best.
All right.
So.
All right. Shush. Wrap it up. Let's get to the story. Say goodbye.
All right. On that note, Matt, we want to thank you. Chat thanks you. I think you did a fantastic job. And we'll let you go now. So thank you so much.
I'll be back later, so I'll see you all later.
Yeah.
See you.
Bye.
All right, Rachel.
Next? Laila, I think.
Yeah, we do. So the next talk is really interesting. It's really about the concepts around distributed programming. And our next guest is really, for me, a superstar in the .NET community. She's really well informed. Has a great educational, conversational presentation style. So I'm excited to watch this. And selfishly, I'm going to learn a lot from this talk, Rachel. So
absolutely.
Let's introduce her. Go ahead, Rachel.
And here we go. Laila. Hello.
Hi, how are you doing?
I'm good. How are you?
Pretty good, pretty good. It's still early here, so I'm still drinking coffee, trying to shake off the
cobweb. You're going to need a lot of that. You may want to stock up.
It's afternoon here. I'm still drinking coffee.
Words, by the way.
Mostly because Martin won't let me drink in here, so there's that.
Oh, geez, please don't leave me alone with Rachel, please.
You're stuck, man. It's too late.
You just need a coffee infusion, and that will fix all of your problems.
Oh yeah, absolutely. You're right. And speaking of right, we're gonna give you the stage. So let's share your screen here.
Yep.
And if you need anything from us, we'll be available. And chat, if you're watching, there's going to be a lot of good content in this talk. So please get your questions ready, and we'll ask them after the talk. So good luck. I'm sure this is going to be great. So good luck, and we'll leave now. Bye.
Bye-bye. So yeah, thank you for that amazing introduction. No pressure at all. But yeah, my name's Laila. I'm not going to repeat that. But if you want to find me online, this is where you can find me, basically. Now, 10 years ago. Oh my God, time's run so fast. It's overwhelming. So years ago, I will just keep it at years ago. We bought this sort of small but beautiful house, and I really loved it because you know what? It was very easy to clean. I could just take care of it in a jiffy, and I was a happy person because of that, okay? But the thing is that as we started to grow our family, we started to outgrow it. And you could really see that because basically the amount of spring cleanings that I needed to keep up with how messy the house was started to increase, but the amount of stuff that I was able to get rid of, that just shrunk and shrunk and shrunk. So I felt like, this is not working. And at some point, we really had to admit that we outgrew it. So that's when we started to look for a new home. And we had this beautiful vision of getting a big house with especially a very, very big garden. And the kids would play outside and we would have family over and my husband would be, cooking at the barbecue and I would make my summer paella, completely forgetting the fact that we don't get summers in Belgium. Anyway, apart from that, at the time we were young and naive, so we did move forward with this dream. And at some point, we found exactly what we were looking for, which means that we also had to get a mortgage. Now, one of the things that my parents really instilled in me is comparison in everything. You don't just go out and buy something. First, you're going to compare and see if you can get exactly the same thing somewhere else and cheaper, right? And you want to do this especially with a mortgage because at first sight, you might say, it's just a few, like a decimal or so point difference, so it's not that big a deal. But when you consider the amount of years that we end up paying these things off, it has a massive impact, right? So what we ended up doing is basically go to a lot of different banks and go back with the same story. And this is the house that we want to buy, and this is how much we would like to loan and all of that. And that takes a lot of effort, right? It takes a lot of your time and it just takes a lot of energy to go through that to get the best rate. But another option is that you could basically use a loan broker, which is a service that will do all of that cumbersome work for you. So I started to think about how such a system could be designed. Now, what basically happens is a customer comes in and they present the terms that they're looking for, right? I want to loan 500,000 euros. I want to be able to pay it back in 25 years. And I would like a rate that is actually fixed because I don't want to be susceptible to market changes, especially in these times. But before the loan broker does anything, they're going to make us pay for that service because otherwise, why would they even bother? Of course. Now, once we've paid them, they will actually calculate our credit score to check for solvability. This also helps with filtering the banks that we actually want to reach out for when we try to get eligible banks. Now, why is that credit scoring important? Because there are banks that only want to work with entrepreneurs or only work with sort of premium customers. So that's something to also keep into account because every call is also going to cost us money, of course. Now, once we have an idea of which are the banks that we want to contact, we can basically ask each of them for a loan offer based on the terms that the customer presented to us. Now, some of those banks will give us an offer and some of them won't. But one of the things that we'll always have to do is a translation effort because, of course, each and every of those banks has their own API format, their own contract that they're using to communicate with external parties. So we'll have to do some translation effort to make sense of that data in a way that we can understand inside our own system boundary. Now, once we did that translation effort, we can start ranking those results so that we can present the best offer to our customer, right? Now, given that there's sufficient complexity involved in this type of a system, I decided to leverage the power of a microservices architecture. Now, of course, I went this way because microservices are comprehensible and they are easy to maintain and they help you build resilient systems, and they enable decoupling, right? And they're flexible and scalable and comprehensible and autonomous and all of these things. If I forgot any of the magic words, please let me know. Now, the thing is that when you think about these microservices, you could sort of compare them with these little dots that appear on your screen right now, right? Is that in essence, they are small. You can read them probably in an hour or a couple of hours, and you can make sense of what is happening inside of that. So it becomes easier to understand, easier to change, and therefore you might conclude that actually that makes your architecture more simple and more easy to understand. But there's a dark side that many people forget about when we start to look at these types of architectures, because even though each individual component is now simple and concise and easy to comprehend, we haven't really just made the complexity disappear. We have just moved it. And where has it moved to? Well, basically to that inter-service communication. We have all these little microservices that are very easy to understand, but how they communicate together, that's where we have our complexity. It basically moves that complexity into the lines between all of these components, right? All those little inter-service communications, request response here, an event published there, and so forth. Now, if we agree that all of that complexity is now in the lines, then we also need to pay more attention to them, because the reality, again, of this microservice-based architecture is that an individual microservice doesn't provide any meaningful customer value, any business value. It's only when we combine them that we present that business and customer value to our users. So we need to pay more attention to that part, to how we draw those lines. And that is especially important once we start building more complex workflows, right? That sometimes may cross multiple services and may even require some type of coordination. Now, as you might expect, if you're in this session, we're going to talk about two different coordination mechanisms today, and that is orchestration and choreography. Now, in an orchestrated approach, we get a more sort of command-driven approach, where there's one component that's directing the flow, that is the owner, if you will, of that process flow. It's going to decide what has to happen. Now, it also will keep any relevant state around and store that in order to be able to make decisions and pause the work and then continue at a later point. So it will keep around any relevant state that is applicable to that specific process flow that we're handling there, so that it enables it to basically make decisions about what you have to do and when you have to do that, and so forth. Now, the way it goes around that is basically to send commands to individual services that will then, contain some instruction of what it is that they need to do. It's important to understand that the orchestrator is not necessarily telling other components how they should do certain things, but just instructing them to do something. Now, when we look at its counterpart, the choreographed approach, it's more of an event-driven approach, not command-driven. We also don't have a central component anymore that is deciding the flow. Instead, what happens is that flow kind of emerges from all of those events and individual components that are reacting to that. It also means that the state of the workflow, well, that's now scattered across multiple services, right? Because each individual service will only keep track of the state that is relevant to its own service boundary. Now, individual services will then make the decision of what it is that I need to do. And the way that they do it is by subscribing to a business meaningful event, and based on that, decide what is useful to do within that service boundary for their logic, and then publish events if needed as a result of that. That's about the only theory we're going to see this hour, because I think it can be a lot more useful to actually consider real-life examples from business domains, and that's what brings me back to our loan broker example. Now, let's assume, for starters, right, that we're going to solve this with orchestration. Now, if we would look at this flow, we basically have a user comes in with a request, and that's what kicks off the orchestrator. At that point, we will collect the payment. That's the first thing we do. We don't care about anything else, right, at that point. If we got the payment, then we will instruct the quoting service, the credit scoring service to give us that credit scoring. And based on that result, we can give that to our quoting service so it can get us the eligible banks. And from there on, get us all of those quotes from all of those different banks. Once we've done all of our translation effort, then the orchestrator will say, okay, we are ready to rank now, and it will send a command to the ranking service to start doing that. Now, at first sight, this is great, right? Because it's easy to understand the flow. We have a single component that now owns and directs the process flow. That's the orchestrator, right? That also will manage all of the state of our flow, and it will be centralized in that single place, which means that we can query it, which means that there's a single place we can go to understand what is happening, what's the current state, and what will probably happen next. But as you might expect, there are also downsides to this approach. Now, the first downside is that this approach requires all of those downstream services to be available. But what happens when one of them is actually down? Well, now the orchestrator has to start caring about resilience patterns like retries and back-off mechanisms and things like that. But what if the service is down for a prolonged amount of time? Well, maybe now we're going to need some kind of a backup service to deal with credit scoring and things like that. So the responsibilities inside the orchestrator grow in that regard. Another thing that stands out to me in this picture is that there is a high amount of coupling between the orchestrator component and all of those downstream individual services that are participating in this workflow, okay? Now, the thing is that it can also sort of be tempting to just add more steps in here because, well, you already have access to all of these services, so just adding one more, well, that's fine. But that means that it also lends itself to being a bit more monolithic, and that's definitely something that we need to be careful about. And we also always need to keep in mind, like, how much coupling do we actually have to those downstream services? Now, another thing to consider is that there can actually be a high amount of contention on that orchestrator. Why? Well, because all of that communication is basically going through the orchestrator, and that's how it should be. It has to be the single point of truth. It has to keep all of the relevant state around to be able to make decisions, right? It means it kind of has to know everything about that specific process flow in order to do that. But that can be a lot for the orchestrator to handle. And that's when you might start to think, well, we need to scale this thing out. Okay, but that's actually not that easy because usually you want all of the sort of things that need to happen for a specific process instance to be handled by the same orchestrator instance all the time. So you need to start thinking about load balancing. And it can become overwhelming, and there are so many things that can go wrong that this tends to sort of aid in the thought process that the orchestrator is therefore this single point of failure. Because if that stops working, well, your process flow is stuck. Like, there is no moving around in any direction at that point, right? Let's consider what even would need to happen if we want to add a step to our process flow. Let's say that, we want to give our customers an invoice, given that they paid us money. So what we're going to do is we're going to introduce an invoicing component. Why? Because there's sufficient complexity involved that would make sense. Now, that's not enough, because now we have to go to our orchestrating component, and that has to change to now take into consideration that it has to call invoicing to generate that invoice, right? To send it a command when it's appropriate within that process flow. So you're not just introducing a single component. No, you're also changing the orchestration component to be able to deal with that. So that's also, from a deployment perspective, something to consider as well. Holy bananas. I mean, that's a lot. Honestly, that's a lot to consider. There's a lot of challenges to think about. So let's maybe just try choreography, and maybe that will magically solve all of our problems. And if we tend to look at that, it's the same flow, but it still looks very different when you start to draw it. And that's mostly because Now, instead of commands, we're communicating based on events, things that have already happened, right? So now there will be a payment completed event that's published, to which our credit scoring will subscribe, which will publish that the credit scoring is complete. Quoting will take it from there. And when it has all of the quotes ready in a format that we can understand, it will publish it, and ranking will take it on from there to bring you the best rate. Now, if you look at this example, then you will actually see how it solves many of the downsides that we earlier saw in the orchestrated approach, because we don't have that strong coupling anymore. If a single component is down, fine. Well, then the events will be there safely stored on the event bus, and when the component is back live, it can just continue where it left off, because now our communication moved from being synchronous to asynchronous. And that means we got rid of temporal coupling. Now, another thing is that now we don't have that central component anymore that is directing other services what to do. There's no control coupling, if you will. Each individual service is therefore truly autonomous and just reacting to things that are happening outside in the system. And if we need to scale, well, easy peasy. You just look at the services that are suffering, that need a little bit more juice, you give that to them, and it's fine. You have that granular scalability that you can use there. And finally, if you want to add one more step here, well, then you could just introduce a new invoicing component, and all you need to do is have that component subscribe to the relevant events, in this case, when we got a payment, to then generate an invoice. And that's done. There's no additional component that needs to be changed and deployed and all of that. Now, when you look at all of the advantages that choreography gives you, for me, there's one thing that always sort of stands out. And that's this idea that, there's less coupling. The coupling is gone, right? Now, the thing is that coupling is not really a thing that we want to get rid of, because a system that is truly decoupled is not really a system, because there's nothing working together, right? Instead, coupling is something that we want to balance, we want to manage it, we want to make it work for us and not against us, right? So that we can avoid that sort of pitfall of the distributed ball of mud. Instead, we want just the right amount of coupling to have a system that is able to collaborative in a peaceful and beautiful way. And if we start to think about the coupling that each coordination mechanism introduces, then you might quickly come to the conclusion that orchestration has a high amount of coupling and may lead to these messes, whereas choreography doesn't really introduce any coupling at all, and therefore, solves that problem. But there's one big flaw in this assumption, and that's that we really haven't talked about the types of coupling. Now, I really like to use this image of pasta because I have a very dear Italian friend, and if I would go over to him and say, look at all of these spoons, it's just a combination of water and eggs and flours, so it's all therefore the same. Well, if I would say that, probably we wouldn't be friends anymore, so I won't show him this recording. But the thing is that we have to have the same attitude towards coupling. Just like all of these different types of pasta serve different types of meals, right? We have different types of coupling to consider in systems that introduce different types of friction that have different types of side effects and concerns that we should be thinking about. So let's start with afferent and efferent coupling. Now, I don't know who's heard of that before. Leave a comment in the chat if you have or you haven't. But this was basically first introduced with object-oriented programming to describe the coupling in terms of class interactions. But we can basically take those same two concepts and then apply them to services to sort of describe how much coupling we have in between services. Now, afferent, or the incoming coupling, basically refers to all of the services that call and therefore depend on you, right? They expect you to be around and to do something. Whereas efferent, or outgoing coupling, refers to all of the outgoing connections, so all of the services that you depend on in order to do your own work. Now, if we would connect this back to our coordination approaches, then we will see a lot more afferent coupling in a choreographed approach. Why? Well, because you have all of those subscribers that are now waiting on that event for you to publish. So there's many services that depend on you. Whereas with orchestration, you will see a lot more outgoing or efferent coupling, because that orchestrator has a lot of connections to those downstream services telling them what to do. So the orchestrator depends on all of those services. What's important for me, or what I really want you to take away from this part, is that there is still coupling independent of the coordination mechanism. Because what we've really just done is we have inversed the direction of the coupling, where first we had the orchestrator coupled to downstream services. Now downstream services are taking an incoming dependency by subscribing to something, right? So when you draw this, there's still an arrow. It's just going into the different direction. Therefore, there's still coupling. Now, many people tend to make this argument that no, there is no coupling because the communication is asynchronous and we're only relying on a broker, and therefore these components are not coupled together. But that's not really true, right? Because if a service would never really emit any event, well, then the other services can't do what they're supposed to do. Or where it becomes more visible, if a service would completely change the event that it publishes, it's going to affect other services, right? So there is coupling, there is a dependency there. Now, there is some truth to this argument, but it is only true in the form of temporal coupling. Because the thing is that when we move from synchronous communication to asynchronous communication, what we get rid of is that requirement that the service is live and there and able to take on our requests as they are coming in. That's what's called temporal coupling. And that's what asynchronous communication gets rid of, right? Because now if the component is down, fine, message safely stored on the broker, right? And when it's available, it can come back and start to process all of those messages. But this is then where I see another misconception that surfaces regularly. And that's this expectation that if you're using orchestration, by definition, you're using synchronous communication. Now, in synchronous communication, we have a sender, and there's a direct connection to the receiver, and we wait until that receiver is able to process our request and sends us a reply. We're basically blocking the operation. But when we do that based on asynchronous communication, there's a message being sent. We don't know when that will be handled, but when it is, we get a different message that will be handled out of band on another thread at another moment in time, right? So the time component is gone. But there's absolutely no reason for us not to use an orchestrated approach based on asynchronous communication. I mean, you could, in essence, even use choreography with synchronous communication. And actually, if you want to have a more in-depth read on that, I would suggest that you read this book, where it goes into all of the different possible scenarios and what the benefits and the drawbacks are from each. But what I want you to take away from this is that we need to clearly distinguish the type of communication, which can be synchronous or asynchronous, from the coordination mechanism, which can be orchestration or choreography, right? And a very valid combination is actually to use asynchronous communication while still orchestrating. So let's take a look at how that would look like. Now, in this case, the flow is exactly the same as what I showed you in the beginning, but you will immediately notice that there's a lot more stuff moving on your screen. And that's basically because the command and the response to that command are now separate arrows. There's no blocking operation, right? Those are different messages, and that's represented in these arrows. Now, all that communication is now happening through the message broker, which means that we get that temporal decoupling, okay? What we still have, though, is we have that high contention in the orchestrator, because it still has to handle all of those messages coming from all of those individual services to still be able to be that single point of decision-making power or truth, if you will, right? When it comes to the idea of the orchestrator being a single point of failure, I think we've alleviated a lot of those concerns by introducing a message broker, because if the orchestrator can't keep up, well, we will just collect all of the messages in a queue. And when the orchestrator is able to, come back up, it can continue where it left off, just the same as any of those individual components. One more thing that I would like you to consider here is the color of the arrows. Now, I hope there's not too many people watching this on your phone, because it might be actually harder to see this. But if you see, there's blue arrows for commands and there's white arrows for replies to those commands, which is basically like a message routed back to the originator, right? Just a message in the opposite direction. And I didn't just suffer creating this in PowerPoint for no good reason. There's an intent behind this that I wanted to clarify, because there's another design decision that you can make here. Do you want to reply, or do you want to instead publish an event? Let's consider, for example, that we would actually like to keep track of all those credit scorings that we do, because we've seen that people tend to come back with different requests now for 500,000 euros, but we found a more beautiful house, so now we'd like to see what 700,000 euros would get us, right? Now, we don't necessarily have to do that credit scoring again, so we want to keep track of it somewhere. And at that point, you could say, well, okay, instead of actually just sending a reply back to the orchestrator, we want to publish an event to enable the rest of the system to keep track of some of that information, for example, right? Or, for example, with our payment, it might be useful to publish an event when something is paid, because maybe an accounting service might be interested in that. And finally, we may also want to publish our rankings if we, for example, want to create insight into the banks that tend to give us the best rates. Now, my point is that this decision about, do you just reply to the orchestrator or do you publish an event, that will be driven by your business requirements. But it will also be driven by your service boundaries, because what you send or reply, for example, to the orchestrator can be more information when that orchestrator is part of the same service boundary, because then that data can be shared, and it's fine if you share a lot of information. But when you publish an event, well, you want to condense that information. You don't want to just give everything out to the outside world, because once data is public, you can't make it private again. We all know that from posting pictures on Facebook, okay? So the same is really true for your systems. So you have to really make a decision there. And in some cases, you will find yourself replying to the orchestrator with a lot of data and publishing an event that's a lot more condensed and suitable to be made visible to the outside system. Now, sometimes I explain this to people and they're like, wait, you told me that orchestration is a command-driven approach, and now you're using commands and events. Like, this is confusing. But one of the things that you need to focus on is not the fact that you've also used events, but rather, do you have that central component that is managing that workflow? Yes. Does it keep all of that state? Yes, it does. Is it enabling the decision-making on what to do and commanding on their services? Yes. And therefore, even though we're using events and asynchronous communication, it is still most definitely an orchestrated approach. Now, let's recap. At this point, we basically see that with an asynchronous orchestrated approach, we got rid of temporal coupling. We regained some flexibility in terms of scaling. We still have that contract coupling, right? Those messages that we're sending back and forth, that is basically contract coupling. We also still have control coupling, because we're telling other services what to do. But the good part of this is that it visualizes our process flow. We can see what happens in what order and which service next. And finally, we still have our state centralized, but that's what gives us visibility into the state of individual workflows. But again, we really haven't answered this question of which one is now better. And the thing is, I haven't enabled any one of us to do that, because we haven't really considered any of the challenges that a choreographed approach would introduce in such a scenario. Now, to discuss that, I would like to consider a different flow in the loans domain. Let's say that, okay, I've taken a moment, taken a sip, I've thought about it, and I'm like, okay, I'm ready to put this strand around our necks and actually get this loan. I want to get this house. So you know what? Let's do this. We've chosen the best rate, and we go to that bank and we're like, we're ready for this. Now, at this point, there's a whole other flow that kicks off inside the bank's domain. And having worked at a Belgian bank for almost 5 years on this specific domain, there's a couple of things I can tell you about how that looks like. Now, what would happen is first we accept the offer, right? At that point, the bank will still say, wait, I'm going to do an ID check again, and I'm going to do a credit check again. Yes, sure, we trust a loan broker, but we will verify as well to make sure that nothing falls through the cracks. When that's done, we will then give you all of these documents that you're going to be signing for at least half an hour until you can't feel your wrist anymore, because that's how it looks like to get a mortgage, right? Apart from that, we will also create an account for you if you're a new customer, and not only create an account. No, as a bank, I'm going to make sure that you've actually rerouted your salary to that account so that we have some certainty that there's money, there's like a sort of stream of income coming into that account, so we have some certainty that we will get our money every month. Only then can we actually create the loan and everything that encompasses that. And one of the things that we will have to do, for example, is calculate interest provisions. Now, without getting too technical, that amount that you pay every month, part of that is a capital repayment of the money that you loaned, and a part of that is interest, right? What banks do with that interest is they will keep a part of that amount aside to deal with bad assets, people who don't pay back their mortgages, but they will also immediately reinvest part of that money. That's how they lend people money to other people, or to put it into other assets, right? That's basically the bank's income. And having that calculated up front provides them some visibility into how they can also manage their own assets. Apart from that, we also want to link that repayment account, probably to the account that we created. Why? That means that there will be a standing sort of payment order on that account, the standard debit coming off your account every month to collect that payment. And when that's done, then we will say, okay, when do we need to pay out this money? Because that's not going to your account, that's going to a notary. Now, I don't know who's watching and how that works in every country in the world, but in Belgium, when you buy a house, there's absolutely no way in hell you will see that money on your account ever, not even for a split second, because it will be basically sent to the notary, which acts as an intermediate party to take care of that sale or acquisition, depending on how you look at it, right? And only when you go to the notary and again sign documents as if it's the end of your life, that's basically you signing away your rights to actually keep your house if you don't pay back that money every month. Only then will the notary say, okay, I have all the documents, now we can move forward. I will give all of this money to the people who sold the house, and I'm giving you all of these documents to give back to your bank, and then we can finally finalize everything and the loan will start running. Now, let's assume we want to do this with a choreographed approach. Now, that could look something like this, right? We have our quoting service that will say, hey, I have a quote and it's signed and I'm ready to go. We'll do the ID check, the credit scoring check, and that's when loan says, okay, now I'm ready to actually create the loan. I will also make sure once the documents are signed to publish that so that payments can move on and make that notary payment ready and do the provisioning calculation, linking the repayment account, all that jazz. But let's consider the downsides of an approach like this. And the first one I want to bring up is the concept of business failures. Now, I specifically said business failures and not technical failures, because technical failures should be handled with resilience mechanisms, right? So like retries or back-off mechanisms or something like that. Whereas business failures are more like sort of alternate flows that happen when things don't really go as we initially planned. Now, let's say that I'm super excited. We're going to buy this house. We go to the notary and we arrive there and they're like, yeah, the sellers changed their mind. They realize that they're still too much in love with the house and they don't want to move forward. Well, the thing is that at that point, we have a problem in our system. right? Because that sale didn't go through, but who has the money? Well, the notary has it. And now the notary has to refund that money back to the bank. And when we get that in the bank, we now have to undo all of that interest provisioning that we did. We have to unlink the repayment account so that there's no money coming off your account while you didn't even get the house, right? And maybe it could be that our quoting service is interested in that because it wants to keep track of it as well. Now, what's important to note here is to start looking at how many arrows that we introduce that are moving in the opposite direction, because that basically reflects bidirectional coupling. Let's take a look in our sort of event flow, if you will. Now, what would need to happen to implement this is that now our payment service will publish an event to say, I got the money back, right? And loans will subscribe to that. But this is exactly what I mean with bidirectional coupling, because before loans, payments already was subscribed to an event that was coming from loans, and now we're doing the opposite, right? We have loans subscribing to an event that's coming from payments. We have that bidirectional coupling. Now, at that point, loans might say, okay, we're going to cancel this loan. And it's actually pretty good in this flow because provisioning will just subscribe to that, undo all of their work, and banking will subscribe to that to unlink the repayment account and cancel the debit order every month, and the same for quoting. But it's really important to keep track of how many hops back do you need to do and how many arrows are you introducing in the opposite direction, because if that ends up being 5 services, 6 services that are now coupled in a bidirectional way, that's probably a lot more complexity than what you intended to begin with. Now, I tend to really like to sort of compare these compensating flows with knitting, which is one of my favorite hobbies. Because the thing is that sometimes I make a mistake, right? But that doesn't necessarily mean that I have to undo everything. But usually I will have to undo certain actions that I did before. Sometimes it can be as easy as picking up a stitch and then I can just continue. And sometimes the mistake is so bad that I will have to unravel part of the work. But I never really go back to the beginning unless if I just started, right? But that's what I want you to remember is these compensating flows, they don't usually mean returning to the initial state. It doesn't mean that we need to undo every step we made until we got here. Now, what's really important is that usually to compensate certain things, it involves the same services to interact with as the ones that got us here to begin with, right? Especially if there's some adjustments that need to be done in all of those services back. That's really something to keep in mind because sometimes when we draw the happy flow, we don't really see as much coupling, and choreography can make a lot of sense. And only when we start to see all of these sort of side scenarios that we start to see how coupling tends to creep back in. But there are even more downsides, like passive-aggressive publishers. Now, I always like to explain this with a sort of home example, because my husband is the one who tends to cook at home, and I really appreciate him for doing that every day. But so our agreement is basically that he cooks and I will clean up the kitchen. Only fair, right? But I swear there are some of those days that I enter the kitchen and it's like, what the bananas? Like, seriously, did you use every freaking pot and pan that we had in the kitchen and even in the basement? It's like a bomb exploded. Now, at that point, as a publisher, I might publish an event to state that the kitchen is messy. And you could argue that that's perfectly valid, right? Because I'm stating a fact, a state that the system has arrived to. The problem is in my expectations. Because as a publisher, I expect my husband to listen to me. That's number one. And second of all, I even expect him to get up from the couch and come and help me clean up the mess of the kitchen. Now, I think we can all agree that that type of communication is not really healthy for your relationships. And guess what? It's not really healthy for your systems either. But this type of communication can sometimes creep in when you're using a choreographed approach. Let's take a look at this example, right? We basically now have banking that is subscribed to that document signed event And what it will then do is link the repayment account. However, from a loans perspective, that is passive-aggressive communication, right? Because the loan service actually needs that repayment account to be linked, because otherwise we will never get the money back and I'm stuck. I can't progress anything within the loan service boundary. So when you find a situation like that, you should be asking yourself two different questions. First of all, if I'm loans and I need this to happen, then isn't it my responsibility to deal with that? And if you're like, no, this is really something that belongs to banking for whatever reason, because we always have reasons, right? Well, fine. But then at least use command-driven communication. Send a command, because loans will depend on that being done correctly. And if you want to be able to deal with scenarios when that hasn't happened, well, you need to send a command so that you can trust that you will get a reply or act accordingly. But when you publish, you don't really have that, because you're even unaware of the fact of whether you have subscribers or not. But that's not even all. Let's consider that we get a regulation change, right? Let's say that apart from checking the person's identification of who's requesting this loan or getting this loan and doing the credit scoring, the government now requires us to also do a background check to avoid that we give out money to criminals, for example, right? Well, easy peasy, right? We've introduced this background check service. It can just subscribe to the credit scoring event and then do the background check and we're done. But not really. Because our problem is that loans was subscribed to the credit scoring event. And now it has to undo that subscription and subscribe to the background check event, right? Now, the problem is to change it in that way, you're already touching two services, because you're introducing the background check and now you're changing loans as well. Sounds like orchestration now, right? But it gets even worse than that, because what we have just done is actually expect an order in which these things are processed, while there is zero business requirements that would actually lead us to create that order to begin with. Like, the only prerequisite we have is to do the ID check first, and then the credit scoring and the background check. But whether we do credit scoring first or background check first, or we do them at the same time, doesn't matter, right? Well, okay, we can solve that by saying, you know what we'll basically do is we'll have loans also subscribe to that background check completed event, but also keep the subscription to the credit scoring event. Okay, but now it has to keep track of when both events have been received, which means that it will have to keep around a little bit of state to understand when that prerequisite is complete and enable it to move forward, right? Which is a complex prerequisite that usually lends its way very well in an orchestrated approach. Doesn't mean that you have to change the entire thing from being choreographed, but maybe you could introduce a smaller orchestrator inside that loan service that takes care of that more complex prerequisite, and that would unblock this type of a scenario. Now, the thing is with choreography that it can be incredibly appealing because it makes us fast, because we can just add a subscription and we can deal with the event that's coming in and we are ready. But once we get more complex requirements and more complex prerequisites, it can become actually really, really hard to change. And it can start to affect multiple services when we need to implement these changes. And the reason is that there's no single place where we have that flow. Rather, that behavior is sort of emerging as it executes. So one of the ways that you can mitigate that is by asking yourself whether there are areas that are very prone to change, right? And one of the ways that I personally like to go about that is by practicing finding anti-requirements, which basically means that you will engage with your stakeholders and ask them silly questions sometimes about what things might possibly change. And you have to be a little bit creative here and go outside of the things that may seem plausible. Why? Because sometimes you will have an idea that maybe doesn't make any sense to business stakeholders, which is great because that means that you found something that is stable. But that might actually make them think of another scenario that they haven't told you about. So by having these conversations, we can find which areas are more likely to change and require additional steps or changed parts in the workflow or more complex prerequisites so that we can understand them. And then what we can do is evaluate the impact of actually implementing a change scenario like that. Now, if you see that there are multiple changes that could happen, I'm not saying that therefore you should never choose choreography. What I really want you, the way I want to enable you is to become aware of the trade-offs that you are making earlier on and not just be watching things as the ground shifts underneath your feet, right? Because that's sometimes how we feel. But a lot of that is also in our camp, in sort of surfaces in asking the right questions at the right time. I hope everyone's still with me. I have a couple more challenges. Now, we have versioning. Now, versioning a workflow is challenging using any coordination mechanism, to be honest. It's just a very tricky thing to do in distributed systems altogether. But if you're using a choreographed approach, it becomes so much harder because there is no workflow, right? There is no single component that has a workflow and decides what's going to happen. Instead, that is that emerging behavior that is just happening. It emerges from all of those event chains that are happening in the system. But we have to ask ourselves, like, okay, if we have workflows that tend to take a bit of time, because that's reality, right? Sometimes workflows take days, they can take hours, they can take months or even years. And if we then have a change in the workflow, how does that affect a new version? How does that affect any in-flight workflows? Does that mean that now those changes impact all of the existing ones as well, or only the new ones, or only from a certain date? And the thing that you might see in a choreographed approach is that that problem starts to affect multiple services. And that's when sometimes you start to see that these sort of concerns start to leak into different services that don't really or shouldn't really care about things that are happening because a background service check was introduced. So it's really one of the challenges of not having a workflow in a single place. But there's one more challenge to consider in a choreographed approach, and that is the lack of overview. Because as the system grows and evolves, it becomes harder to really explain how the system works, how to even understand just what it is doing, because there is no single service that explains that to you. Instead, you have to analyze and understand all of the services that participate in the workflow to be able to answer that question. You have to understand what subscribes to what events results from that, and who subscribes then to that, and it becomes like an intertangled mess. I'm going to use that term one more time, emerging behavior. And I will tell you what I really think about that term, because it sounds incredibly sophisticated. But to me, it sounds like I don't really know what the system does. Let me execute it, see what it does, and I will tell you. That's really how it feels. It's the same with this pack of cables, right? It's like, oh my God, like where do I even start? And in systems where this becomes a problem, they can start to feel like pinball architectures, where you basically publish an event and it's like ding, 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 ding across the system, messages flowing everywhere, and it's incredibly overwhelming. And it's incredibly hard to understand. And that usually leads to a couple of points of friction. First of all, when you need to understand the state of a workflow. Oh, you have a mortgage that is in progress, or an order that is maybe, I don't know, stuck in a workflow somewhere, and now you need to understand in which state it is. Okay, wait a second, let me try to figure out all of the services that are actually involved in this workflow, and then go and query each of their individual states, and then I will aggregate all of that data, and then I will try to reason about it, and I will tell you the state. That's how it can become, in the worst case scenario. Or when you need to troubleshoot issues in this workflow, right? You have to go through all of that exercise while there's a fire in production and an angry manager standing at your desk asking you when the bug will be finally fixed. Now, this is usually when you start to see that people sort of start to point fingers at each other. Oh no, our team just subscribed to that event from the other team. And in our service boundary, everything works right. Everything looks fine. And then the next team says the same thing. And the next team says the same thing. And when a manager walks into a scenario like that, guess what they do? Okay, well, if nobody's responsible for this mess, guess what? Everyone is now responsible. Nobody's going home, order some pizza, and I don't care how long it takes to fix this issue, right? Not a situation you want to be in. So to avoid a situation like that, you need an observability strategy. If you've seen some of my sessions at JetBrains.net Days Online in the previous years, then you will have seen some sessions about observability, and they're also recorded, so feel free to go and watch those. But that's really what you need to put in place, especially when you have a choreographed approach, although I would recommend it independent of the coordination mechanism. Now, at this point, you might feel like, oh my God, this is absolutely impossible. Like, you're just making me more insecure, Laila, stop it. Well, this is how I felt for years, okay? Because it is incredibly hard. These problems are not trivial. They are not easy to solve. That's why we keep trying with different technologies and different patterns and different practices, right? It is confusing. But the thing is that the answer to the orchestration versus choreography story is that there is no versus. There's only and. In a well-designed, well-architected system, you will find both coordination mechanisms. So the reality is that it depends. And I know that that's an absolutely useless answer to you if you're looking for answers. So one of the things I want to do is present to you a decision-making framework that I use when I'm trying to solve things like these. And it consists of 5 questions that I will ask myself to sort of push myself into the right direction and focus on the right things when I'm making a decision. The first question to ask yourself is, what type of communication is best suited here? Would it be synchronous communication or would it be asynchronous communication? Now, if it's synchronous communication, you will see that I have a spectrum between O, orchestration, and C, choreography, and that will push you towards synchronous communication. Whereas if you want to use asynchronous communication, well, you could use both orchestration or choreography, and you will have to dig a little bit deeper into the next questions to find the definitive answer. Now, one of the things to keep in mind is that the answer to this question should be driven by your business requirements, or mostly by your business requirements and some technical requirements like scaling and resilience and all that. But again, scaling and resilience, those are also driven by business requirements. That's why the focus should be, what does the business really, really need, okay? Next, what direction of coupling fits best? Because you will have coupling one way or the other. But does it make more sense to use command-based communication, or does it make more sense to use event-based communication? That command-based communication will send you more towards an orchestrated approach, and event-based fits more in a choreographed style. Do you have any complex prerequisites that require that control? Okay, then orchestration might be a better fit for you. Also take some time to really think about those more complex compensating flows, right? When things don't go as expected, all of those sort of side results that, oh, they don't happen a lot, but you're going to have to support them anyway, right? If you have a lot of those compensating flows and they end up sort of introducing a lot of bidirectional coupling, well, then you may be better off with an orchestrated approach, because the orchestrator will already be coupled to all of the services in which it has to undo something. So you usually don't introduce additional coupling to solve complex those compensating flows. And in a choreographed approach, you usually do. So that is then less suited when you have a lot of these complex sort of compensation flows. The fourth question to ask yourself is there a high probability of change? Like, are you working in a stable domain? How do those changing scenarios look like? How has change been in the past? Like, those changes that look probable right now, would they cause significant disruption to your existing process flow? Or would it just sort of perfectly fit in somehow? Can you just easily add things at the tail? How probable are these changes even in your context? Now, if you find that there's a high probability of change, or there's just a high sense of insecurity, maybe because you don't have access to business experts, well, then you may actually benefit from having more control and from directing things until you fully understand the business requirements and get to a situation in which things are more stable, and then you can switch. If you're saying, no, this is super stable, it's straightforward, well, okay, then choreography may be a really good fit. And the final question to ask yourself is like, is there someone responsible for this flow? Like, if this fails, how critical is it to the business? And who would you go to? Who would be responsible? If that's an important question for you and you need a single team, a single set of people to be able to go to give you all of the answers, well, then orchestration can sometimes be a better fit. That's why in many retail businesses, you will see that even though you can solve that in a choreographed approach, that they still end up introducing a dedicated order fulfillment service just to handle that orchestration, have the control and have the visibility. You don't need that? Well, fine, then a choreographed approach might actually work really well for you. Now, here's the final roundup of the questions, but I have them in my resources at the end as well. One more thing that is really important is that you need to guard the size of your workflows. Because the thing is that if you take these 5 questions and you apply that to a very large process flow, you will always end up with orchestration as an answer. So it's really important that you actively go and look and ask yourself, like, are there parts of the workflow that I can extract from this that are really not part of that, but that are just maybe sub-workflows that are independent, that shouldn't even be part of this? That's really a very important part of the equation if you want to be successful to finding the right coordination mechanism. And one of the things that I always do is I draw. Pencil and paper, people, it doesn't get more simple than that. I'm a very visual person, so that might not be the case for everyone. But one of the reasons that I find it so incredibly powerful is because you're drawing the arrows. This subscribes to that, and that sends that, and this commands that. And then you see the amount of arrows, the amount of coupling. So you could basically draw your happy flow in black, and then over that, draw compensation flow number 1 in yellow and compensation flow number 2 in red. And then you start to see how that coupling is affected by those types of things. So I really find it useful to end up drawing both coordination mechanisms and really see what are the pain points of each. And that can really help surface that. It can also help you to talk with peers and all of that. Really useful. Now, if you've read about these concepts before, you might be listening to me and thinking to yourself, she's making this way too complex. I mean, haven't you heard of the rule of thumb that you should orchestrate within a service boundary and then choreograph across service boundaries? Well, yes, I have heard of it. And although I would generally agree that this is a good guideline, not rule of thumb, but guideline, the thing is that what bothers me with this approach is people tend to take it literally. And that makes the assumptions on which this rule was based completely disappear. Because this is a good guideline when you got your service boundaries right, which after almost 2 decades in the software industry is usually what we get wrong to begin with, which is why we're struggling with coupling so much. So I'm not saying you shouldn't pay attention to your service boundaries. I'm actually saying the opposite. But what I'm saying is don't go with a black and white rule, but really get to the essence. Why are you choosing a specific coordination mechanism over the others? What are the individual points that led you there? And if you find that this brings you into a situation where you're orchestrating across multiple service boundaries, well, then you might want to take a moment to reflect on whether maybe you got one of those boundaries wrong, whether something is off there to begin with. And if that is the case, it might still be a good idea to do that orchestration. Why? Because changing your service boundaries is not something you can do in just a jiffy, right? It requires coordination across multiple teams. You need to plan this. You're going to have difficult conversations around that. So in the meantime, use the coordination mechanism that actually fits your current situation, your current restriction, right? So that you're not choosing something that will end up making your life even more difficult. And the thing is that as much as we try to pay attention to doing things the right way, sometimes things do end up changing in ways that we didn't expect. And it's important that when that happens, that we don't treat our design as our baby and we don't want to change it and we can't let go of it, because that just makes things worse, right? Instead, we need to accept that things have evolved. It's not a failure at that point. It's that our insights have progressed, right? We better understand the requirements now than we did a year before. Duh, that's true all the time, right? And when that happens, instead of fighting the change, you should accept that now you need to make certain changes to your design and architecture to account for that. And that brings me to the end. Now, to quickly recap, so that I can give some time for questions, there is really no right or wrong pattern, right? Both of them will be part of a well-designed and well-architected system. But it's important that you keep managing the size of your workflows, really important to identify which of the sub-workflows could be isolated away. And then you can use that 5-question framework to help you get to the right coordination mechanism in your specific scenario. Always make sure that you keep reevaluating your service boundary, and more importantly, that you understand the trade-offs that you're making and why you're choosing one approach over the other, and that you reevaluate your choices when your requirements change. Now, I hope we have some time for questions, but if not, you have a QR code that you can scan that will take you to additional resources that I have on my GitHub page, and you can also feel free to contact me if anything comes up later. So let's see if there are any questions in the chat that I could answer.
Yeah. By the way, I love the little comments you say, like "holy bananas."
Holy bananas! We love it.
Easy peasy. So good.
This really shows that I'm a mom, doesn't it?
Yeah, it's just hilarious.
I think you win most arrows on a PowerPoint slide. I think you win like a trophy for this one.
I know, I'm so courageous.
Yeah, I actually counted because you were so incensed by it. So I counted 34 arrows on that one slide. So
I didn't like when you talked about, you're like, oh, there's a lot of arrows. When you look at it, you draw it. I was like, yeah, did you see that slide?
I need to actually remember that number now that I know it.
Yeah. I will say, this is a comment just noticing you going through those 5 questions. I think those questions are fantastic.
Yes.
It would make a great tool for folks to go in and answer those questions themselves and see that kind of spectrum move, so that, like, for teams trying to make those decisions and asking those 5 questions, they can see in real time, like, okay, based on our answer.
That's exactly what's on my GitHub repo. Is I have an overview from all of those questions and all of the sub questions that could help you come to an answer. So you will find that again there.
Very awesome. Yeah, I posted that link in chat, so folks want to go to that, they can as well. So a big question that kind of came up throughout the talk in chat was really about migrations and workflow changes. So what do folks, and maybe what do you do from your experience, if there's still data and still incomplete workflows in your system, whether you're using orchestrators or you're using choreography, how do you deal with versioning when there's like a change? Is it something that, based on your experience, how do you deal with that?
Right. One of the questions that is very similar to this that comes up a lot is, I'm moving away from a monolith and I want to start to split things up. So sort of strangler fig approach. And the thing is that while things are uncertain and unstable, I find that using an orchestrated approach is better, even though you can already sort of see based on the requirements that the end game should be a choreographed approach. Because If you're still, dealing with an old system and data's over there and data's over there, you're going to need to coordinate between those multiple things to keep everything in a sort of consistent state. And if you need control, you need orchestration, even though that means that it is temporal, and you might want to end up removing that and actually changing to a choreographed approach as those things start to unlock. So it really comes back to how much control do you need? And sometimes that is not only driven by business requirements, but also by things like migrations and things like splitting up a monolith and things like that. So I hope that answers the question. When it comes to versioning, I mean, do you have a couple of hours?
We could have you back and do a specific live stream on that. But yeah, I'm sure it's a very complex topic. But like all things in tech, it could always be boiled down to it depends, right? Like I'm assuming that's the final answer, right?
I know it's a very sort of frustrating answer, but it does. That's why I also built this talk, is because there is no black and white answer, and there are so many things on which these decisions depend. And that's what we want to become aware of, so that we are enabled to make those decisions, right? But one of the things I could check is to see if we have some resources around versioning these types of things, and I can later share it with you, and you can maybe post it on the final YouTube video that's released.
Yeah, I'm sure the audience would really appreciate that. So thank you. Rachel, do you have another question?
Yeah, you talked about high-level orchestrators and choreographers, message brokers. Do you have specific technologies that you prefer or that you think works better with this, or that does a better job than others?
That's another long list. Okay, there's a reason I do a workshop around these things. But the thing is, there are actually many. And it depends on your communication style, because for certain synchronous approaches, there are certain tools that work, and for asynchronous approaches, other tools work. Now, you all know that I work at Particular, although I didn't introduce that maybe in the beginning, but we build a messaging framework. So ours is mostly asynchronous. And in that space, one of the things that you can use are sagas that help you sort of handle that orchestration sort of concern. And you could host a saga as a dedicated service, where it's like, that's the orchestrator, it's all it does, and that's a whole service on its own. Like order fulfillment sometimes is designed that way. Or it could become part of an individual service, and you could host it inside the service as well. But there are many tools out there. There's things like Camunda, which supports like synchronous and asynchronous type of scenarios. You could use logic apps. In essence, there's Netflix Conductor, although I'm not sure if that's still alive these days. There's Dapper. There are so many different tools. I have these again in resources that I could share as well. I can circle that back to you.
Okay. Yeah, speaking of like system infrastructure, you kind of hinted at it a little bit, and you professed your love for pencil and paper, but we talk to developers here, so they might reject your love of pencil and paper. When you're building these complex systems, how do you keep track of the state change of your overall system? Do you have diagrams, documentation? Are there technical tools to kind of find out this emergent infrastructure that you're building?
Right.
Yeah.
So, okay, if it comes to finding the emergent things, observability is the answer, right? Because that will be, you can literally run your system and go look at how it behaves. So even if you don't really care about observability, which I would strongly oppose to for other reasons,
Me
but
too, yeah.
let's say that you don't care about it, you could still sort of sample out 99% of the data, keep 1%, and it would give you an overview of what's happening. Because even though a lot of people are well-intentioned with diagrams in the beginning, how long do we keep that up? Honestly,
like 10 minutes, 15 if you're lucky, right? If you're on a high-functioning team.
Yeah. So observability is an answer to that. In our platform, we've also built observability tools where you can see the message flow, which is really, really cool. So I don't know which tools that you're using, but I would definitely see what they also support. And if they don't support anything that visualizes these things, then you like observability is the answer.
Yep. Rachel, any other questions?
No, I think we hit most of them. There was one about versioning, but I'm not sure if actually you might have answered this a little bit. Like, is it inherently slow? Does it make deployment slower? What do you do when you have to move quickly and introduce new complexity that's not managed?
That's not managed. So, okay, if you want to move really quickly, as I sort of touched on in the presentation,
could this be it?
Is easy.
Or maybe not moving so quickly?
Yes, if only
Also,
that were true in the real world, right? But the thing is that I've seen actually many teams use choreography because it enables that quick, just add and subscribe in this. But that's also how, when you leave that unmanaged, you will end up with a mess. So I always say that it also really depends on what you're building and how you're communicating with your upper management, because one of the conversations that I would like to be able to tell my younger self, this is what you need to tell the manager, is basically to say, okay, you want me to go quick? I can go quick, but this is going to be throwaway code 6, 7, 9 months from now.
I could see where this could rack up a lot of tech debt, where people go, we'll just do it this way this time, and like 10 more times, 10 more times after that. And then this is how this happens, right?
And that's how you get the pinball architecture. Right.
We're supposed to prepare for tech debt, but often it's just credit card debt. It's not the mortgage, right? I could see people getting out of hand with that. Similarly, with your slide,
it's really important to consider that angle of, do your managers really understand the implications of moving that fast?
Yep. That's the thing I got the most out of your talk. I know folks tune in for kind of the technical details, but the thing that really struck me, and I think the thing that most people should take away, is you're working on a team with human beings, and this is all really to facilitate communication with other human beings and to understand and build a shared reality. And once you understand that shared reality, you can act to change it and make it better. And I think that really comes across in your talk, and I really appreciate that message. So,
well, thank you. I'm happy to hear that, because it really is. Actually, the bank that I talked about, where I worked for 5 years, one of the things that made that such a successful project is that we had continuous access to business experts. Like, they moved them physically into the same space as we were. So if I had a question, I just turned around and I asked the question. And that's the reason it became successful. Not technology X or Y or Z or architecture, whatever. No, it's the fact that we had access to business experts whenever we needed it. And that enabled us to really understand the domain and make the right decisions as to how to model those things.
Yeah, I love that. It's like a shared responsibility. You're all one team. It's not us versus them. It's
very people-oriented, which is why you're building software in the first place, for other people, not for robots.
Yes.
At least in 2024. Maybe come back in 10 years. We'll find out.
Shh, Rachel, don't tell anyone I'm an AI. I can't know.
Oh, they might.
No. Well, thank you for helping us delve into this topic. For folks that don't know, delve is apparently a keyword that AI generates all the time.
It loves that word.
All the time.
So Laila, thank you so much. We love this talk. Chat was really excited about it as well. Folks, go check out that link. I'm sure there's a lot of great content in there. And follow Laila. She's great. She's awesome. So thank you, Laila. This is a good transition, Rachel, to our next speaker. We talked about communication. Laila kind of hinted at, events and choreography. And that's really the topic of our next speaker. So let's go ahead and introduce her. Go ahead, Rachel.
Yes, come on, Irina. How are you?
Hi, fine. How about you?
It's been a while since I've seen you, so hope you're doing well.
Thank you for joining us. This is actually a really interesting talk. I've never heard about this until this week, so I actually went and did my homework just so I kind of know what you're talking about. And it's a really, really interesting topic. I'm curious to see how it applies to the .NET ecosystem and kind of what you've learned and how you're going to do that. So chat, get your questions ready.
Yeah.
Irina,
Also,
yeah.
I'm interested in seeing if anybody is doing this already. Drop in those comments. I want to know who's doing this because I have not been
Idea
on
for
any.
a poll.
Yeah, I've not been any. This is the impromptu. I just started up 30 seconds ago, Paul.
Yeah.
Because I have not worked on any teams that did specifically like this. And to be fair, a lot of teams I was on did not do testing very well to start with. So there's that. We'll just leave it like that. So I am interested in what people have to say about this
You and me both.
how you can function with it, on a team like this.
So Rachel and I, we're going to fade into the background. We'll give you the stage. And if you need us, let us know. We'll be monitoring chat and we'll be back after the talk. So good luck.
Thank you. Okay, so I'm here to talk about contract testing, and I hope I'm going to make it easy. I learned the hard way back in the days that, well, the tests we were doing, if we are doing them, were not that easy to maintain. And not only that are not easy to maintain, they become a nightmare when it comes to deploying all the microservices and having confidence that your system is safe and sound to deploy in production, to see the light of day. So that's why I said I'm going to focus a bit around contract testing to see how this can maybe improve your project. So let's see. A bit about me. My name is Irina. I'm from Romania. I work at Particular Software. I'm a colleague with Laila. I blog from time to time, and I'm passionate about everything that moves around .NET space. But sometimes I'm focusing more about either microservices, either gRPC, or libraries like nService Bus and Transit. So I also written a book, which is interesting if you want to switch and learn APIs and do web development. So maybe you know someone that might find this useful. Okay, a short recap. We're talking about testing. And we're talking about testing in contexts where the teams are growing and where we have huge projects. The last project I worked on back in the days had 120 people, and it was an end user and consumer focused. It wasn't an internal project. And I noticed a lot of friction between teams that wasn't so nice to witness in terms of we had the microservice architecture. And we do microservices because all of those fancy terms that we hear. A microservice should be autonomous, should have its own database, yada, yada, yada. You know them already, right? So we realized that as soon as the teams started to add up and we started to develop more and more features, well, it wasn't so nice. We kept stumbling upon each other's toes, and we realized that from time to time, things happen in terms of deploying to production. A team releases a feature that is not compatible anymore with some other teams, or it consumes something from whatever team is developing, and we realized that what we wanted and what we got back when we call those other APIs didn't match anymore. So we had to find a way around it. So this is what I'm gonna try and preach today. So a short recap about unit testing. I'm just curious if you're doing unit tests and if you find them useful, because during the time I realized it's super nice to do unit tests and I advise you to do them, but it only focuses on business logic. Testing small chunks of apps in isolations. I like them that they are very fast, and this is what we want to have, fast tests, so we can run them whenever we want to, on local machine, on your colleague machine, and so on, right? So unit testing should be repeatable, consistent, and done in memory without touching other systems. So we're focusing on small chunks, we're looking at those, and we're testing it that, hey, do this sum, pass these parameters, and you should expect this as a result. And if everything is fine, the test is passing, and so on. So these should be not only repeatable, but fast. And how fast they are depends on how much business logic we have. Actually, when we talk about unit testing, we are checking on one single concern in the system. Only one. Not a majority, not how these systems work together or how we're calling different methods together. We're testing only one small chunk. So once we're done this, we said that, okay, we're interested in integration testing. We're interested that now that we have the business logic safe and sound, and we're able to reproduce the tests every single time we're deploying something or we push a change on GitHub, now we're interested to see more how our services work together. So if A calls service B, this will test the entire flow. It won't be an isolation. So we're answering basically the question how modules work together and if they work together. With integration testing, the system will call that one component will call other components that it needs. It will take answers from their responses, if we send messages and so on. Actually, this integration testing can test the entire flow. So let's say we have a service A, that's an ordering API that will call the product and will call inventorying and billing and so on. When you do an integration test to test that ordering API, we will have call HTTP requests usually across the entire dependency graph, okay? With integration testing, the deal is that we invest time and feelings in there, but it won't catch system-wide errors because we're testing over mocks. It requires to have visibility over the other code. So we do not get to have that high-level overview over the system. It will uncover errors that might occur when we integrate with individual modules by calling the code, but pretty much that's it. So when you do integration testing, you need to look in the code and to see what you're calling and what you need to mock and stub, okay? Further than that, if we really want to be thorough, we can have different kinds of testing. There are so many of them that you need to focus on each individual one because they are so specialized. System testing can test, for example, the ability of a system to recover from transient faults. System testing can focus over the security of a specific issue. We can do stress testing over that system, and we can also do performance testing. Well, I think you're seeing this in somewhere. This is a testing pyramid that is promoted in some books, and it's very important to see pretty much where we stand in terms of how stable and how mature is our testing approach in our system. So first, at the bottom of the pyramid, we have unit tests, and then we have integration or system tests. You'll see a different terminology depending on where you look. And on top of it, right at the top, is this that we call end-to-end testing. And when it comes to catching bugs and errors inside our systems, we're thinking about how fast we can catch them. So once we climb the pyramid, we're realizing that the tests are very slow. And once we get down, we realize that these are fast. But the actual amount of money that we can lose by not catching them is in reverse. So at the top of the pyramid, to catch bugs is very expensive. So once you have a bug in the UI, it's very expensive to fix. And on the other side, when you have unit test and a flow in your business logic and you have unit test, it's very easy and fast and cheap to catch. The idea is that there are a few challenges. Some people invest, or some teams invest very much in end-to-end tests. We use things like Selenium and Playwright and things like that to simulate the fact that this systems is used by a real user. We're simulating clicks, we're looking and digging by HTML IDs, we get values from there, and you pretty much test flows by simulating that there is an actual user there. But there are challenges there. So let's see, we have this specific system. We have an ordering component that will do an HTTP synchronous request to a catalog to get the product. And that catalog will do some other requests to, I don't know, external components. Basically, in this entire flow, we will depend on all those other components to be up and respond in a timely manner to us, right? So in the ordering system, if the last component in the call chain is down, what will happen? All the response will be down. So we try pretty much to prevent this by writing tests, end-to-end tests. And this brings us to a state where we have this system where we use a browser and we do an automation on top of it to make sure that, hey, there is someone there that tries and simulates that everything gets fine, it gets an answer back, and so on. This takes gazillion minutes to run, usually, and not only that, it becomes flaky and hard to maintain. So end-to-end testing, as the last resort, becomes very expensive to us to write and maintain. We will have long build times because basically the point of automating something in the system is to get confidence that we can deploy, okay? And if we have a lot of moving parts in microservices, we have to be confident that when we deploy the microservice A, we won't break any other component in the system, right? So we have to take care of the infrastructure. It's hard to debug. That happens with end-to-end testing. It's super hard to debug. Sometimes some end-to-end tests, not that they are written bad, but the system behaves like that because we're basically not testing what we should test. How do you manage those end-to-end tests? What is the team that owns them? As a microservice developing team, you should have autonomy over what you develop. But end-to-end tests, it doesn't fit your job description pretty much. And you end up throwing end-to-end tests somewhere to be maintained by I don't know whom. Basically, it's not my responsibility. I'm taking care of ordering API. I don't touch UI, yuck. So someone needs to be there to write those tests and maintain and update them. So there's usually dedicated teams, or we pass the ball from each other from our team to the other team and so on, just to make sure someone will maintain them, or we simply forget about them. Another thing with this test is that they're flaky. Flakiness is the thing that we are mocking and stubbing. We are not testing against real components. And in test, it works. But in production, with a different connection string, we might get the wrong endpoint. What happens is that we get a false positive, or that our test is not reliable. Because in production, we don't have the same connection strings, the same databases. The environment is different, basically, right? So I've seen a number of problems here. These tests become either free-for-all, all the team are granted access. Not all the teams have the competency of knowing what's in there. We run and we implemented and we adopted this architecture, microservices, because we wanted autonomy from other teams. We were now able to deploy independently, and we did the things ourselves. We didn't care about any other teams. We didn't want to communicate with others. We simply focused on what we have to deliver, and that's it. But when these tests break, everyone assumes that is someone else's problem. So they do not care, and they either disable this feature of testing this specific issue in product in the CI/CD pipelines, or that's it. Or how do we maintain mocks? Or as soon as the team is starting to grow, we get slow feedbacks. In a team that has 100 people split into different capabilities that commit things and they develop features and they commit code, and that code gets into the pipelines and it's tested, the test suite is run there. It's super, super slow to see what happened if a build failed. Who is the team that caused the build to fail? Why is the reason? What should we do to address that fail? And so on. So it basically raises the issue of team ownership. Who owns this? It's something that hangs out in there. We need them because we want to build trust. But when it comes about team ownership, things are not that nice. Okay. So with the end-to-end testing, we kind of lack this feature, independent testability. And indeed, they do help pick up semantic breakages. If the contract from a API that we're calling breaks, we will later than sooner, we will pick up that semantic breakages. Okay, but basically the larger the scope of deployment, the higher risk of failure, right? And there is a research summarized in a book called Accelerate, where these changes caused by end-to-end testing can be managed with a small number of services. But when this grows and the number of team grows, our ability to independently deploy a microservice as a team will require a test suite that is shared by several teams. Because even though autonomy, it is what we want to propagate, we won't get that. Because now our small chunk that goes in production, it's not going to be independent in production. It will talk, it will do requests with some other features that are developed by other teams. And they too need to be aware that something had changed. So they say that high-performing teams were most likely to do their testing on demand without necessarily requiring an integrated test environment. So what we're doing when we write such tests is that we're stitching back our microservices just for testing purposes. Exactly what we're doing. So in a microservice system, the capabilities we expose via user interfaces or APIs that are consumed are delivered by a number of microservices. That's why we have backend, front-end for backends, and so on, or backend for front-ends, pretty much. We have a front-end application that consumes several microservices, several APIs behind the scenes. Okay, so if we do not want to break things, we need to deploy microservices together, just to make sure that if we are in version 3 of a specific API, we must have sort of a snapshot of the entire system. But we don't want to do that because we're back to monoliths and we just run away from it to move to microservices. So basically, this naive approach of testing all together won't work. So what if we could have the fastness of an unit test, but test the integration points? So what if we could have a reduced scope? We could test in isolation, but still pick up semantic breakages. And I need to pause for a bit and explain what is semantic breakage. A semantic breakage you'll find in Sam Neuma's book, explained very well with almost an entire chapter there, is that if you, as a service, you are consuming another service, and at a point in time, you have this expectation. You expect this specific field to get back as a response, and that service you're calling changes and removes some fields or adds or changes data types, that will be a semantic breakage, okay? So basically, you need to catch them because in microservice architectures, pieces are moving. And when things are moving, they're most likely to change. And you need to capture those changes. And this is exactly what consumer, where CDC sits in the middle. Okay, so fast tests, they run super fast, and it will allow us to have exactly this build pipeline that is super slow changed. With now on build in CI/CD, we have unit tests, then we run integration tests, and then end-to-end takes a million years. Okay, we will change this approach. So with consumer-driven testing, we would prioritize the need of the consumer. So if I, as a service, I need to get data from another service, I would capture this specific need somewhere, and I would run tests against it. So basically, I would have expectations for how my provider should behave. So if I consume the other service will know what I need. So my priorities will be communicated pretty much. So what helps us to do is to catch accidental breaking changes early. And how early it is? During development time. So CDCs are basically expectation for how the consumer microservice should behave. So we would only need to run these tests and put it against the provider, and we'll see how those are looking like. So arguably, consumer-driven contracts are more about fostering lines of communication and collaboration between microservices and the teams that consume them. It handles breach of these contracts and catches bugs very earlier by, well, catching breaking changes, those semantic changes that I mentioned. So getting back to our schema, when we do end-to-end testing, we're basically interested in what happens if we click this button from the UI, let's say, all the flow that our request takes to get us favorable response or a response back. But what we're really interested in is the integration points that happen between these services, because we really want to deploy them independently. And we really want not to break the cold chain because we changed something. Okay? So actually, what happens with microservices and actually with entire teams is that you have a provider or a service, depending how we want to call it, and we would have consumers. Well, in some cases, we have only one consumer. We know who that consumer is. But in most of the cases, we have different consumers that we cannot control, and they have different expectations from us, the provider. So they call us to get responses with data, okay? So as soon as the provider changes or the feature set changes, where we want to introduce a new version, do another release, and so on, we will realize that this feature set grows, and some of our consumers might catch fire because we have a breach in the contract. So this is exactly what we're trying to prevent with consumer contracts. So let's rebalance the pyramid. Rebalancing the pyramid basically means that we have all these kinds of tests, and maybe we shouldn't invest so much time into writing them and maintaining them. So why write integration tests or end-to-end tests when we could do contract tests in between? So we end up with saving us some time to develop actual features because our pyramid now is smaller. And it is smaller because with introducing contract tests, we prevent bugs, and we do not want to maintain flaky end-to-end tests, okay? So how is this looking? Basically, we have a consumer and a provider. This is the terminology that we're using when it comes to consumer contract-driven testing. And we introduce something in between. The consumer would be a service, the provider would be another service in our case, if we're talking microservices. And in between, we're saying that we want to each part to honor its part of the contract. So in here, we would have our consumer saying, hey, I need this. And as soon as I need this, I have to publish this specification somewhere. I have a bunch of code to show you, so don't worry, you'll see it in practice. And then when you publish this contract by testing, on the other side, the provider will say, hey, consumer, what do you need from me? You need what's written in the contract. Okay, cool. And we run tests against it. And if we cannot honor the contract, our test will fail, and we will notice that we have a semantic breakage. Okay? So what is this contract basically? The contract is an agreed interaction at a specific point in time. So if I'm today and I need to respond with this, or I need to consume this is exactly what I'm going to write there. I'm going to say that I need to make a call to an orders API or to a products API, and I need these 4 fields back. I need a 200 OK as a response, and I need this JSON body to be present, and also maybe I need a custom header. I specify that on build and on test run. That will be generated as a JSON file by the consumer, but verified on the provider side. So now on the consumer side, we would have automated tests that test the interaction, but as a result, we will have this contract. And this contract will be the one telling the provider what it needs to give us. Okay? The provider part, on the right-hand side, we will see that we have this contract. We take this contract, we run tests against them. The contract can have several lines, can have several operations. And we would see that, hey, what's in here, I am able to honor. If I'm not, I'm going to fail the test. But this way, I catch semantic breakages. And I will see how the provider behaves. So if we were to think about RESTful APIs, RESTful APIs and consumers, those were supposed to be developed and to evolve independently. If you evolve these 2 entities independently, they might not be able to communicate with each other at a specific point. We introduce breaking changes. Okay, I expect 4 fields, and now you're sending me only 2. I cannot deal with it. So I might get an error when I call this API. So how do we test this? Well, we test this with something that is called Pact. Pact.io is a framework that has this library that we are able to use in order to test our APIs. So it allows our consumer to define its expected behavior from the provider. So you're telling it your needs, and the provider will test against your needs and see if it's able to respond or not. Okay, so consumer-driven testing tool. It was originally developed in-house by Real Estate in Australia. It's open source. Originally, it was for Ruby and focused only on HTTP protocols, but now it supports several languages and platforms, and also can be used for messaging, since the previous talk was about messaging. Okay, you have it here. Messaging interaction is very important to also test those, because the messages that are flowing in the system under the form of a command or an event, they carry data with fields, with things in there that can be changed. So there too, we can be interested in seeing these breakages. Using Pact. First, we're going to define the expectation of a producer, of the consumer. Then we're going to launch the Pact server, and we're going to test against this formal JSON specification that is there. We have language-specific SDKs. So if you're in JavaScript or you're mingling around with Node.js or so, you'll also be able to use this library Pact for that specific language. For C#, we have PactNet. And then we're able to use something that is closer to natural language to test. So let's see the code. I have here, you will have access to the code. So you'll be able to run it yourself. So do not worry. You have here, I'm going to show you the solution first. I try to split it more or less on the concepts that we're looking at. So we have the consumer side and the provider side. And in here, we're going to write things together. So on the consumer side, we have a simple console app that has absolutely nothing interesting. The consumer has a models folder, which mimics the models that we use with Web API or MVC. This is a product model. It has a few fields, decimal int string, nothing fancy. It's just to carry data. And then we have products API client that has some things already settled here. We're not going to use this. It's just here to show you that we can have different types of clients that we can use and write tests over them, those. API client is the same. It has an base URI, can call get all products. Basically, what I try to do here is to show you that you can either call something from your existing project, or you can create a test project where you can mock the client. So to have this specific test project, it's a small and easy XUnit test project, nothing fancy. I went there and I installed PactNet abstractions, and PactNet output XUnit. And anything that is here is just standard XUnit project, nothing fancy. Of course, I added a reference to the consumer project that supposedly it's the subject under test for our time being. And pretty much this is it. I also have here some plumbing that I had to do in order to allow us to write tests. So we have the client factory, which is an HTTP client factory that simply creates a client. And then we have the test setup, which is the interesting bit. So I'm going to try to explain it step by step, and then I'm going to try to show you how you can write tests. So we have this setup Pact is a test setup. It's a static class, nothing fancy. But basically what we have to do here is to say, hey, I have a Pact config where you have to store files. Remember that I told you that our consumers will say what are their expectations. And those expectations are outputted as JSON files. So what I'm doing here is to specify where are those pacts stored. And I did some fancy work. It's like how many levels up, and it's under this pacts folder, which you're going to find at the project level. You'll see here, pacts. Everything will be generated in here as soon as we write some tests. After that, we're going to see the log level that we're interested. It's something similar to log information, debug, and so on, but this is in relation to Pact. And then we're saying which version we're using. We're using version 3. And then we're saying which is the consumer, which is the provider, and we pass in the configuration. And then we're saying that we want to test with HTTP interaction. All this with HTTP interactions. We can also have here messaging. So I'm going to, using native backends and with message interactions. Basically, this is how you're telling that which is the kind of contract that you want. So I'm going to Control Z and let it here. And getting back to here, we have two types of tests. I have a consumer and I have a product. Okay, this products bit will call into our provider, which is a products API, nothing fancy. It has some dummy data in there. It's a create, read, update, delete over a product. So we have get products, we have product by ID, fancy stuff. I'm going to comment this out. We have these cases if we do not have a product, we return not found. And if we find the product, we transform into a model and then we return it as a response. The put we're not using today, the post we're not using today, but feel free to try and get the source code and write it yourself. It's fairly easy to do so. And under the consumer pact, we will write our tests against this provider endpoint. So I try to have two of them, one super simple and one with more closer to real life. So the provider will simply get a string and return different status codes depending on what we're passing here. So we're trying to pass a valid datetime. So we're going to look if what we're passing in there is null or empty. We're going to return this with a bad request. And if we're able to parse the datetime, then if we're not able, to parse the datetime, so the format is not correct, we're going to return this. And if, yay, we're able to parse it, we're going to return this test good and this specific parsed datetime. So we have only one method, only one endpoint, that's it. This is what we're going to try to test. Okay, so we're trying to say from the consumer's perspective that when I'm passing good data, I have to get back a specific status code and a specific response. So let's go ahead and do that. Okay, I'm going to close anything that is not related. Consumer pact, and we have this endpoint. Okay, this is what we're testing. This is what you're basically testing when you do end-to-end and integration tests. You have endpoints that you're trying to call somehow to make sure the entire flow works and you get back the response that you expect. Okay, so in order for me to progress faster here, I'm not gonna type it step by step, but I'm gonna show you what we should do. So it parses date correctly, consumer pact tests. I'm going to paste some code. I'm going to explain it to you. Okay. In the consumer pact test, I need a test output helper that will spit out under this folder the result of this running test. And then we said I have a pact, version 3 of the pact with the name consumer provider. This is my name as a consumer, and this is his name as the provider. And I'm interested to pass in the config with HTTP interactions. So you have examples pretty much with everything you would need. Okay, then since I'm using XUnit, this is annotated with fact, and it says it parses a date correctly. The expected string that I'm expecting is today date, right? And then we're gonna define what our expectations are. So we have this pact, and we're gonna say that upon receiving a valid GET request for date validation, this is your deal, this is your job to write whatever you see fit. Then you say, given that there is data passed with this specific request method, you can have either get or put or delete or verbs. It will call, I'm going to put the get back, the endpoint named API provider with the specific query string with this named valid datetime. And this is what I should expect back. And when this request is made, the provider will respond with the status code OK. It can be anything that you need to test, but now I'm testing the happy flow. It will also have the header of type content type with this value, application JSON char set UTF-8, and with this JSON body. This is very helpful if you want to, if you have, for example, custom headers that you're using, custom MIME times that you're passing. Let's say you serve several consumers, each one with its own MIME type. You can test those there. And this will be the range. The act bit will be to actually call pact, verify async the context, and then you actually do a call. And the call actually is by calling the API client static class, which you will find in the consumer bit, and you call a method from there. You pass the expected string and then look at the context, mock server URI to string, you assert that what you get is what you actually get. And you assert that date parse string, it's whatever you get from the response. Okay, if we open now the test explorer, you'll see that there is one single test here, named it parses a date correctly. You right click and run. And we, fingers crossed, it's green. And you'll see some funky things written here. Tokyo runtime worker, Pact mock server, blah, blah, blah. Says that compares strings pretty much API provider with the body test good valid datetime. And let's see what happens. In the folder called Pacts that we configured at first, you'll see now a JSON opened, written. It's called consumer provider dash provider, which is exactly the name that I added here. Where are you? Consumer provider provider. This is the consumer side. This is the provider side, and it added a dash between them. So if you open this up with Visual Studio Code, you'll see a JSON, nothing fancy, but this is a specification that Pact uses. For this consumer with the name consumer provider, very fancy name, it has this interaction. It has a provider state, which there is data. This is simply a string. You can add whatever you want there. It does a request with a get HTTP method to this provider path with this query and this data. And as a response, it expects back this specific body with this header, with the status code 200 OK. Nothing fancy here. We cannot do anything with it currently, but we can go ahead and write a provider test. So once we said, hey, provider, this is my expectation as a consumer, take your contract and test against it, we have to write some tests on the other side, on the provider side. So we open provider tests, and we would simply make a simple test. We annotate this too with the fact. We call it ensure APIs honors Pact with consumer. I'm going to pay some configuration things. Here too, you have to say this time that you have a Pact verifier configuration that has an output helper as an output, and it has a specific log level. I think I wrote this. Okay. And then you have to say which is the path where our verifier passing in a config will find. So this is pretty much hard-coded currently, but you can read them from app settings or pass it dynamically. It's up to you. But basically, this is the JSON that I will look at from the provider's perspective. And then once I point it out to the right path, so don't be scared about this path join. You can use a different manner if you want, as long as you point it to the specific right file. And then we can say that, you know what, we are the service provider. We have this name, we have this URI, and I want to verify with file source where I have this Pact file. You can also have different verification bits. For example, we can have SSL verification disabled if we want to ignore that. We can have a Pact broker. We will talk a bit about Pact brokers and so on. But what we're currently doing is to look at the specific file that we just generated. So we take this and we test against it. So as soon as we did this, we should be able to see it in our test explorer as a new test. I'm going to maximize this a bit. You'll see that we have products API tests, provider tests, ensure API honors Pact with consumer, nothing fancy. There is a catch though. You would have to have the products API running if you want to test against it, because what Pact will do is to do actual requests towards it. So we will go here in our project. I'm going to see where I am. CD contract testing, CD products API, and I'm going to have it running. So .NET run. I'm going to wait. it will check some things that that are in there, and now you'll see that it's listening on this specific port. If you want to browse to the code, you'll notice that under the products API test, you'll see something that is called test fixture, where this test fixtures has this provider URI, which is the specific point of our product API running port, and then a Pact broker URI. This is standard. If I have time, I can show you how you can run in Docker Pact broker, but this will be the standard port. So this is where you will find it. And pretty much that's it. Now, when you run our tests, click run, you'll see that it fails, and see why it fails. The following constructor parameter does not have active fixture data, text fixture. Let's see, providers test. What did we do? Fixture. It comes collection definition. This is very weird. Everything is in there. Let me put this. Apparently, I didn't pray to the demo gods. Let's see. I'm gonna stop this. Okay, output helper fixture. That fixture source comes from the collection definition. Why do you complain? Text fixture. This is this. Okay, let's test this again. Otherwise, I'm gonna show you on the project where apparently did not have a text fixture. That's weird. Okay, let's see. Where am I? Let's test demo gods, help. Close all tabs. Text fixture is here. This is here. Let me open the project. It's a good thing to have a backup project if things go sideways. And I'm going to open another tab. Browse to that. Okay, product API. Doesn't run. Okay, let's see. So this seems to be working. Waiting, it's there. View test explorer. Okay, we're here. Provider test run. And now you'll see that it's passing. And you'll get back a result like this, verifying a pact between consumer, provider, and provider. And you see things like this, a valid GET request for date validation, given there is data, will return a response. I cannot do this, but I can do it with Zoom. Has a status code of 200, this is okay, will include headers of this time, has a matching body, okay, and so on. Also, I did some tests around what happens if I pass empty string for that date parameter. I would get back an application problem.json and a matching body that I have in there. Here too. So this is how you basically test the things that integrate. You're saying, hey, I expect this, and I expect the provider to honor them. So if we look in our consumer text pact, you'll see random string as a parameter, how I did it. So I passed to the specific path. I said that I have a bad request. So this is what I'm expecting back, a bad request with content type, application JSON. And I'm verifying that if I'm passing a valid date to invalid date, I get the specific thing. And then what happens if I send an empty parameter, string empty, as a query parameter value, will respond with bad request and this content type and so on. If you want to expand that to match application problem plus JSON, you'll have to look at the JSON body too, and to see what is the actual format to test it. This is for the, let's say, simple things. For the more complicated things, we'll look at the product's consumer tests, where here too, we're saying which is the Pacts. We can specify things like serializers. Like we can say we want to have camel case serializer. If we want, we can have snake case. We can have any kind of serializers as long as we can specify in the contract what is the response that we're expecting. So if the API serializes data using snake case, of course, we should expect the response as snake case written, right? Okay, so let's see here. Should get all products. This is a scenario that we should look at. So get all products is a test that if we call using an HTTP GET this path from our products API, this will respond with the status code 200 of K, with the header having a content type application.json, and with a JSON that matches a list of a product model. Okay, so what we're doing is to say that we want to have a provider client factory that calls this, that has this mock server URI. We create a client. We act like we're calling the API products. We expect the response, and we deserialize the response, and then we assert some things. Of course, whatever you're doing in the verify async defines what you're actually testing. We're testing the status code, and we expect that that product list not to be empty. But of course, you could look at, I don't know, the number, any things that are suitable for you. And this is how you define it. If we look at what our products API is responding with in the products get all, simply we look at this. We expect a list of products. We mapped it, and that's it. Okay. Let's test it. View, test, explorer. Where does it hide? And this time, under consumer test part, we look at the products consumer test, and we said that we want all products to run. So we run it. You'll see pretty much not every single time. Most of the cases, all the tests from the consumer side are green because they are not tested against anything, but that's your input for verifying on the provider side. Again, funky things that uses strings, matching rules, paths, you see rule list, sends requests to a specific port, and so on. And now, since I'm going to stop this. If I'm trying to run the test to verify that my contract, by the way, since I'm changing the folders, I should be able to also show a second Pact file, which is product consumer with the products provider discussion. This is open, so you can see all the interaction that this consumer does. Get responds with this specific type. It has this specific MIME type as the body. It has a few matching rules, and so on. Again, we're here. When no matches are found, and so on. But this is basically what you define. So when I'm calling this, using this, I expect this back. So this is what it tests. So let's run the products test, run, and see how it fails. And it should fail because our API is not running. So you have here the source that failed, Pact verification failed. It says, okay, I have these 3 tests, given product ID with ID 1 exists. I send a request for this specific path. It's trying to connect, but well, for nothing because the API is down and I don't have any response to act upon it. Same happens for the other ones that sends a value that shouldn't be there, and for the get all. So now if we run our project to have the API up and running, you see a lot of things happen. When we redo our ensure products API is safe and sound, we get a green passing test. So we're testing that it responds with the 200 OK, it has these headers, has a matching body, and so on. In case of a product that is not there, a product with 100 as an ID, it's not in the database, so it has a 404. It will include headers, application problem.json, because this is how I built it to be. It has a matching body or no body, and so on. Let's test something like, I want here and get product to have this header. I add a random header called culture, ENUS. I add here, it's important to me because maybe in the consumer side, they want to look at it. So if I want to look at this header or look after this header too, I will go in my products consumer test and I'm going to say, hey, get all products is not what I look about, this one. Okay, so get product. I want to call this endpoint. I want to get a response of this type, and I want to look at what I get back. I want to look, for example, a camel case naming. If I want to ignore null, you can also specify things related to serializer, so can be set there. But I also want to look at the culture header, ENUS. So if from the consumer side, I'm expecting it, but on the provider side, I don't have it, guess what will happen with that test? It will fail. So get product, I'm going to run it. I'm going to stop the service because we have a build in progress. So run, get product should be able to be overridden there. And once we have this up and running again, okay, we would be able to run ensure products API. Okay, so we get something like this. Pact failure exception, verification is failed. It says why it fails. Culture width, value, like this, failed. So this is not found there because I commented out on the provider side. So now I have a failing test. So every single time a structural change happens, I am able to catch it by using this contract generated from the consumer. So it's really helpful because now I don't have to worry anymore that, maybe the other team changed the API that I'm calling, or maybe the type has changed and so on. I have ways of checking that what I expect to receive, I will receive. Or if I'm not going to be able to receive it because things have changed, I'm going to catch it as soon as possible in the development time. So you'll be able to see the code and run it by yourself. There is a thing that I also want to show you in terms of where do you store these contracts? Because it's easy, you have a folder locally, but when you're talking about the entire system and CI/CD, things are different. So there is this notion, this thing called Pact Broker, which is the CDC specific repository that can help you store Pact files. And since it has knowledge about consumers and providers, can also validate them. And it can also help you store different Pact file version, because that's the thing that we would want to version, right? So let's see how it looks. In the project, you will see something that is a Docker Compose. Let's see, Docker Compose YAML. So you'd be able to run Docker Compose app. And if everything goes smooth in the Docker, if you have it installed, where are you, Docker? Here, you'd see contract testing that has the Pact Broker there and a Postgres database running. It needs it, so I had to provide it. So now if we open that port that I mentioned with 9292, let's see, localhost 9292, you'll be able to see an interface that shows you a dummy example. Pretty much this is an API. So if you click on it, you'll see where repository is, which is the branch, and then you'll be able to also see the network graph. This will show you the integration between different APIs that you have. But currently, I didn't push our APIs there. I would do that with publish. There's a bad file that I learning my fresh. I hope it finished. Yeah. I cleaned everything, so now when we refresh this, we should be able to see two more things: our consumer provider and the provider for it, and the products consumer and the products provider for it. So you'd be able to see like the relationship between those. So if we click product consumer, again, the same information, it shows you what it consumes, what it needs. Of course, it's a very simple dependency, but it can be more complicated than that. We have here some options like view the Pact file. It will give you a pretty cool interaction based on that JSON file that is generated. Provider will respond with this, so it's easier to understand which and what response needs, or when no matches are found, product by ID will be here, stuff like that. 404 headers, like so it's simply a specification that this tool uses. What else? Also shows you when it's built, which is the provider, which is the branch, which is the the build version, and so on. You can filter them with tags and so on. It's very, very, very nice. Okay, what is the benefit of using CDC? Well, stubs are never stale. You will always, if you're using, you can integrate in CI/CD pipeline. You can test there. You can publish artifacts to your Pact brokers, or you can store it in your repo. The benefit is that you always know which is the latest version, and the stubs are never stale, so that in pre-production everything works like a charm, and in production the hell breaks loose. Okay, so this is one benefit that I really wanted to add here. Basically, CDC is like TDD, but apply at the API level. Okay, and to summarize, don't test anymore your microservices as if they are monoliths. Don't tie them together back again, and start reducing your end-to-end test number and focus on what your consumer needs, because that's the integration points, and that is the thing that will help us catch bugs. Okay, thanks for listening. I hope I gave you an overview of what CDCs are and how we can use them in order to have better systems, pretty much.
Yeah, that was a really interesting talk. Thank you so much for that. There's actually a lot of questions happening in chat around people's conceptualization of building APIs, integration testing, end-to-end testing. A common one that folks were asking was, does an open API do this for me? I am creating a contract. How is this potentially different than people just following my contract? I think you explained it well, but for folks who maybe weren't paying attention, could you summarize how you think this is different than that?
So basically, open API is indeed a specification, but that only shows you how your provider looks like. right?
Mm-hmm.
If you're consuming that API, you have no way to tell that API, hey, I expect this from you. So
Mhm.
pretty much CDC is moving the focus on the consumer. And it says, hey, I, as your consumer, I expect to have this. Take my expectation and do something with them. But OpenAPI just announces, hey, this is what I can do.
Mm-hmm.
But it doesn't necessarily look at if it breaks or not. An API, OpenAPI will change itself as soon as the API that has that will change, and that's it. It doesn't look at what others expect from you.
Yeah, I think that's a good point. It kind of flips the relationship. It's no longer a specification like like the name implies. It's contract testing. So there's a contract and expectation for behavior, and now it's not the consumer's responsibility, it's the provider's responsibility to make sure that it accomplishes that contract, right?
And to mitigate the changes pretty much.
It's interesting because the thought, Martin, one of our colleagues, just wrote a GraphQL blog post. Folks should go check that out. It's a pretty cool blog post. But GraphQL keeps track of consumers and the fields that consumers are asking for in their queries. Do you feel like contract-based testing is still important if a protocol has that feature built in, or can folks substitute a protocol like GraphQL in place of contract testing?
I think there's a difference of nuance. Basically, GraphQL will allow the consumers the flexibility of taking whatever that GraphQL endpoint exposes. It doesn't test anything. It's simply, here's what you can do. But on CDC is like, hey, I expect this from you. And as soon as you start integrating those tests in your pipelines, you'll notice that the hell doesn't break loose anymore when you move to different environments, from QA to staging to user acceptance testings and so on. It really looks at everything around you and look, hey, a microservice changed. I need that to be as it was. I'm not going to break. But GraphQL is simply for consumer side. You're not testing anything with it. It's just, here it is. I'm exposing this data. Take what you want from what I'm exposing. Yeah, so it's it gives the flexibility with GraphQL, and here it prevents breaking changes pretty much in all those small bits.
Rachel, do you have a question?
Yeah, so there was one from the comments, like, how is this different from BDD? Do you do any BDD stuff at all? And
nope, I used to, but I don't. I don't remember exactly. 5 years ago, it was the last time I touched BDD. I don't remember it having this JSON that you can fly around and pass to the providers. It's simply, it's similar in the sense that, okay, you test what is the behavior that you're expecting, but it doesn't have that end goal of a generated thing that you can move across the pipeline.
Yeah, yep.
So you showed kind of those JSON files that are like the contracts, right? The contracts that consumers and providers are expecting to be there. From a consumer's perspective, having those contracts, does it make it easier to test your applications? You know, a lot of folks were mentioning end-to-end testing, integration testing. Do you still need those things if you're doing contract-based testing?
You need less end-to-end testing if you're doing contract testing. That's a thing that I stand by. Because you, in end-to-end testing, you don't have this speed as you get with contract testing. You want it now, and as soon as you introduce a change, you would want to see if it will break something without you worrying that, oh, I'm going to leave it in the pipeline. Those end-to-end gazillion tests, unmaintained, flaky, not reliable, will run. And after 3 hours, maybe I would be able to see if I broke something or not. But I want to see if I break something during the development time, right? So.
Yeah, it sounds like you're talking from experience.
hard learned lesson.
Yeah.
Rachel, are there any other questions?
Yeah, there There's a few still, yes. So two
I
of
can
them
go
kind
and address them if
No,
it's needed.
we have you here. You're here.
Yeah,
to answer
yeah,
questions.
you're here.
Yeah, don't
Now
worry.
you're trapped for a little while still.
Yeah, I'm fine with that.
So do you feel like this kind of contract-based testing and formalizing the contract verification improves communication between teams? Which kind of
Super
harkens
smart
back
question.
to Laila's talk a little bit, because it was
Yeah.
very heavy on communication and whatnot. So how would that play in here?
Basically, when you integrate this into a pipeline, you don't need to communicate. Things will break and that's it.
You're good until you said break. Okay.
But developers are so good at communicating with other people. Come
Yeah,
on.
you said
Imagine
so.
that. Yeah, so good.
No, I'm just some are, some aren't.
Yeah. But that's very cool. One of the things you showed, if you wanted to integrate contract-based testing into your current workflow, what are some places in your current workflow that you have to kind of reassess and potentially change to adopt this new style of testing?
Basically is in the pipeline, where is this small tool that they provide called Can I Deploy? So it's a CLI tool that is very cute. That will allow you to say, okay, you can deploy because all the tests are passing, or you cannot deploy because something is. So it will prevent the actual deploy from happening.
Yeah,
Just
and
a good guard.
yeah, I mean, we saw in the previous talk the complexity and trying to manage and make sure that deployments and coupling are in a state where you understand where the system is. So a tool like that sounds like an awesome feature that folks can put in just to have that extra guardrail, like you mentioned, to kind of keep them from deploying a broken system. So that's pretty cool.
And having to roll back, because basically that's the most painful part.
Yeah, always roll forward. There's no going back, people. No going back. So, Rachel, any last questions?
Yes, kind of like a spin-off from that next one then. Especially if you don't need as much communication, right? Is contract testing for internal teams, or can you open it up to external parties too?
Very, very good one. It's not necessarily for no, rewind. You cannot use SIGDC for integration points with other providers, with external providers, because both parties have to agree on this contract. So if you're consuming, I don't know, since Cecil will be next, Stripe API, right? Stripe would have to agree to test on its own side so it doesn't break you. And that's not necessarily possible. So for your microservices, your internal teams, yeah, that would work like a charm. But for the other things, there's still integration tests to do. Because that's,
Yeah. On that note, I think that's all the questions. I really love this talk. Thank you so much for doing it. I think, if there's anything, I think it gives people an opportunity to think about their current testing style, their internal communication within teams. And if they're thinking about breaking up a monolith into microservices, I think this talk is very enlightening for them.
One thing to consider, yeah.
Yeah, so thank you so much for this. On that note, we're going to let you go. We really loved it. Again, we'd love to have you back, and thank you so much.
Thank you for having me.
Next
Rachel,
up is Cecil. Yeah.
Yeah, she mentioned our next speaker. So
yeah,
the theme for this kind of day feels like distributed programming. So what other better way to get into distributed programming than to talk about our next topic? So, but before we bring on that guest, I think we're doing a host change.
Oh, so, right.
Yeah.
Although Matt, it's like quitting time for me. Matt's coming on. Where is he?
Matt looked really excited though for a second. He's like, maybe I could get out of a little hosting duty.
I was just about to go and get a coffee. It's like you don't need me anymore. This is good. No, Rachel, it's time for you to relax. It's good. I'm here just right at the very end. This is good. Last session.
Yeah. So Rachel, thank you so much. Any last words as we kind of let you go?
Yeah, I don't get to do the day drink until after quitting time. It's just not fair. Well, so on the last one, just the joke that we were making off chat was that I'm so sad that Pact doesn't have a pinky swear. I just thought that was amusing. So that's all I got.
I'm not sure how you enforce a pinky swear, though. I mean, I think that's
You
also...
know, it's. Have you met children? They enforce this. They enforce this.
It's the law, man.
And I've met enough developers who are like children, so yes, it's it.
I mean, there's that, right? So I feel like this is directed somewhere. Okay.
In the past, Rachel, many years ago, back when I was, doing development professionally.
All right, Rachel, we're gonna let you go so you can enjoy your nap and story time.
Oh, right. Time for a person to go to bed.
Thank you, Rachel. We'll see you later.
See you later.
Yep. All right, Matt. Let's introduce our next guest. So I'll let you do it because you just sound so much better than me. So go ahead. Introduce our next guest.
I'm very pleased to welcome Cecil, who's going to be talking today about composing distributed applications with Aspire. So this is going to be interesting. Hey, Cecil, how are you doing?
I kind of want to have a nap in story time too. I mean, that would be fantastic.
All right, everyone just close their eyes and I'll read you a story.
After the session, though, don't do it. Don't go to sleep.
Yeah, everybody, wake up. This is an exciting talk. Let's get excited.
Yeah, this is a good one. I'm looking forward to this one.
Yeah,
Awesome,
me too.
awesome.
So again, folks, if you have any questions, please ask it in chat. Matt and I are gonna disappear into the back, but we'll be watching chat. So if you have any questions, please ask them. Cecil, stage is yours. We're gonna evaporate now.
Awesome. Thank you all so much. Hi, everyone. Definitely thank you all for joining me today. My name is Cecil Phillip, and we're going to be talking about composing distributed applications with .NET Aspire. Pretty much what we're going to do is kind of just go through, not so much just diving into like an intro to Aspire, like what is Aspire, but really talking about, how can we use the API? How can we explore the app model? And what are some of those interesting combinations that we can make with, what's available to us today? We're definitely going to talk about comparing it to some of the things that folks use today, like Docker Compose, for example. But then in general, right, just trying to understand what does Aspire look like in terms of making distributed application development a little bit easier for developers. And so that's pretty much what we're going to do today. And we're going to have some fun demos and stuff like that. So a little bit about me. Again, name's Cecil, originally from Antigua, little tiny islands in the Caribbean, if folks have never been there, and now I live in Florida. I'm a developer advocate at Stripe. I've been here for a couple of years, and I'm also one of the community managers for the Dapper project. So Dapper, D-A-P-R, not the micro ORM framework, right? And one of the things that Dapper does as well is we talk about ways that we can make microservice development easier for developers, right? Which is not so much different from what we talk about with Aspire, right? And even though they're two different projects, we almost try and solve the same problem, just in kind of different ways, right? Because the fact of the matter is building distributed applications is hard. When you think about what is exactly a distributed application, we think about it could be something as small as I have a web server and a database that they could be existing on different machines, and I have one instance of each, to I have this huge cluster of different services of different instances of each, and there's messaging, and there's service discovery, and there's centralized configuration, and there's all these different things that I need to put together to make this application work. And one of the things that I find exciting but also a little stressful about this space is for everything that you want to do inside of your application, there's so many different options for you to choose from, right? If I want a message broker, I have tons of options that I can choose from. If I wanted to do databases or caching or anything like that, there's so many of those things that I can choose from. But it gets stressful when now you have to put the puzzle pieces together, right? Does this particular service have the functionality that I need? Does it work on the operating system that I'm running on? Does it have client libraries for my application, right? Does it work with .NET as an example? Does it work with whatever other language that I'm plugging it into, right? And then as I pick those individual pieces, do all of those pieces work together? Right? Again, like it becomes a little daunting sometimes. I like to call that like the microservice matrix, right? Because you have to find like all these different puzzle pieces you have to put together, and then you have to configure them, right? And you have to get them running and deployed and all of this types of stuff. And so in the past, we've gone through a couple of different cycles of trying to solve this problem, right? If you remember in the past, like there used to be this project called Project Tie. You know, if folks remember Project Tie, go ahead and like throw some emojis in the chat. But, you know, Project Tie was a previous experiment, you know, within the .NET space of how, you know, we could run multiple services, right? Multiple applications at the same time, you know, being able to share configuration and get them deployed into whatever your environment happens to be. I think at the time it was really focused on like a Kubernetes and stuff like that. But with that being said, like I think we've learned, or at least the team learned a lot from building Project Tie, and that essentially led us to where we are today with .NET Aspire, right? One of the things that's a little bit different from with Aspire from Tie is you'll notice Aspire is really like not just like a deployment tool or something like run a lot of apps, but it's a full stack, right? Like there's so many different things you get when you Aspirify your application, right? But essentially for me, like Aspire, more than just like allowing us to deploy things and run things, it gives us like a glue, right? It's almost like the web that's in the middle that's like taking all of the different things that we already have and it puts it together in a way that kind of just makes sense, right? Like we'll talk about like, you know, those smart defaults that it has, you know what I mean? Like what's the right way for me to configure this application? How do I run this thing? Like how do I plug these things together, right? You know, we talked about the instance of, hey, well, maybe I have just one, you know, web app and one database, or maybe I have tons of different instances of those things. I still need to know where that thing is, right? I need to know like what are the credentials and how do I configure them? I need to know what's the location, right? Like how do I discover those services? You know what I mean? When you're talking about larger applications, one of the things that often comes up is orchestration, right? How do I again like set up those different components and pieces that make up my application, and then how do I, you know, run them together, right, and have them run in a cohesive way that actually like makes sense. On top of that, like Aspire does a lot of other really cool things, right? The developer dashboard is something that we'll take a look at. It does deployments. We're not going to talk about deployments today, but it adds a lot of stuff that, again, ultimately the goal is how do we make building these distributed applications, you know, a little bit easier. And I think it's important too that we kind of define like what we mean when we say distributed applications, right? Again, like it doesn't have to be Kubernetes and it doesn't have to be like this thing that's running on the cloud or anything of the sort, right? I think you can have a distributed application that runs in, you know, on premises. You can have a distributed application that, you know, again, it's as simple as a database and a web server, right? I think most apps today are, you know, we can think about them as distributed applications. If you think about a mobile app that you're building, right? I'm pretty sure your mobile app is going to be calling some web service somewhere. At least I'm sure most of them do, right? It's going to have some database that it needs to reach out to. It needs to have some, maybe it's using a payment service, or maybe it's using Twilio, one of these other APIs, right? Like it has tons of other pieces that make up these applications. And so when we think about them, I kind of want us to move away from thinking about it as, you know, it has to be in the cloud and it has to run in Kubernetes and I have to fit a certain model for us to use these things. I think stacks like Aspire, I think stacks like Dapper even have something that's available for like any type of application, because I believe most applications today are just happen to be distributed applications. But that's just me. That's just me on my soapbox. That's how I feel about it. You can let us know how you feel about it in the chat, but that's just my feeling about that. One of the things I want to do is let's start talking about the integrations. Right. And, you know, integrations, AKA the feature formerly known as components with Aspire, integrations is essentially like the way that you plug into that Aspire application model. And there's two different types of them. Right. And we're going to see demos of these things in a little bit. But one, we have the hosting integrations. And so these ones essentially just represent like what are some of those dependent services that my personal application needs. Right. So again, do I need RabbitMQ? Do I need Redis? Do I need MongoDB? Right? Do I need a secret store? Do I have cloud resources that I want to have set up? Right? And essentially, like these integrations give us like a programmatic way to kind of define like what these things look like with obviously various APIs and extension methods that we can make use of. And then with the client side, right, the client integrations are more so in my actual app, right? So now I'm not defining resources, but instead I'm consuming these resources. So like, how do I bring in like the Redis client? How do I bring in the RabbitMQ client, the Mongo client? But then I want to plug it into like that Aspire convention of configuration and service discovery. But then also it adds a lot of interesting things on top of it, like health checks, resiliency, and how do I plug in open telemetry support, and all these other really cool and interesting things. Now, when we think about integrations, I think one of the fun things about it is that, if you go into the Aspire repo today, you can actually look at the code because Aspire is open source. You can look in the repo today and you can see the code that allows us to create all of these different integrations, right? A lot of them are built by the .NET team itself, but a lot of them have actually been contributed from other folks, right? And I think it's a good opportunity for us to kind of go in and learn and see, hey, how can we make like this ecosystem better, right? Like how can we add some additional pieces to this to make building distributed applications better for .NET, right? But I think as of today, if you kind of go into the repo, like you'll see integrations for tons of different things. I mentioned like message brokers and databases, and it works with Docker containers. It can work with Kubernetes things if you're into that, right? It works with cloud resources, right? And then you can add your own if you wanted to, right? And so I think, again, like these integrations, I think give us a really interesting opportunity to kind of like plug into things when you think about building these apps. Now, as we're talking about integrations, one of the things that you get whenever you Aspirify, right? Like whenever you add Aspire to your application, you get a couple of projects that are added to it, right? Like you'll notice you'll get a service defaults project, right? And again, this is essentially a template with like some predefined defaults. And then you get this thing called the Aspire app host, right? Which is a project in itself. And inside of the app host essentially is where you'll write the code, right? Like you'll use those integrations, or at least you'll use those hosting integrations to define like, this is what my application needs. This is what it looks like, right? So in C#, I can say, hey, add Redis, add RabbitMQ, add Key Vault, add these things. And the app host is gonna, look at my code, it's gonna build it, it's gonna run it. And then it's gonna start up two separate processes, right? One is gonna start up the orchestrator, or the DCP. I think it's the developer control plane, this is what it's known as. And when it starts up that orchestrator, it's going to pass in like those resources, right? Like those resources we defined, in that hosting model, in that application model, and then it's going to go ahead and run them. Now, there's a couple of resources that are, you kind of get out of the box today, right? Like there's executable resources. So we think about us just running commands locally in our machine. Container resources, which could pull from a container registry, wherever it happens to be, whether it's in Docker, Docker Hub, or the component registry, or even if you're hosting containers inside of GitHub, you can pull them from wherever they are. And then like your project resources, which essentially represent like your .NET, your CS proj files, your .NET, projects and solutions. But what happens now is that the app host pulls from the app model. It's going to spin up this orchestrator and give it, give it your code, right? And now it's going to run these things depending on whatever type of resource it is. And it's going to inject configuration. It's going to inject, it's going to create some endpoints. It's going to spin up reverse proxies so we can do communication between those things. And then another thing that it does is it spins up like the Aspire dashboard, which is, another interesting artifact of this space. And essentially what the dashboard does is it kind of gives us like a lot of interesting insights as to like what's actually running right now. So like, what are the services that are running right now? What are the resources that are running right now, right? Can I see my logs and my telemetry and my traces for these different resources that are running, right? And again, through configuration and through some of these environment variables, that information just kind of gets plugged into, again, our resources. And so they already know where the dashboard is. They already know where to send that information. The other process that gets spun up is the resource server. And what this does is, again, like some of that metadata that gets created when we build our applications. This is a resource, or well, this is a server that the Aspire dashboard would also talk to get some additional resources. So again, what are the endpoints? What are the environment variables I have set up, right? So as the, our executable resources, our containers are pushing telemetry into the dashboard, the resource server is there, and it's really responsible for giving us some of that metadata. Like what's some of that non-telemetry, non-observability information that kind of exists in the inside of our application model, right? Now, this is pretty much what the app model looks like, or at least this is a snippet of what mine looks like. And so, using the app model, like I mentioned before, you can programmatically define what your application looks like, right? So as you can see here, like by default, whenever we start, whenever we build up the app model, we're going to use the distributed application builder, right? And then using that builder, we'll have a collection of extension methods that we could use to just add some of these different resources, right? So again, like adding secrets, adding databases, right? Specifying things like, what are the passwords and ports that we're going to use? What are the configuration files that we're going to use, right? And then essentially when we build and run it, Aspire is going to look at all of these different components that we've added together. I'm sorry, these different integrations we've had together. Please don't get mad at me for calling them components, bad habit. Look at all these integrations that we've plugged in, and now we're just going to spin them up for us, right? And they'll all be running at the same time. So if there's a container resource, they'll be running and they'll be configured. If it's a project resource, they'll all be running and they'll be configured for you. Now, like I mentioned, this is a programmatic way of doing things. But before Aspire, well, we used to use another tool to achieve the same thing, essentially, and that's Docker Compose. And for folks that might not be familiar with Docker or Docker Compose, essentially, it's a single file that we could write, and we can define our services, but instead of programmatically, we declare it declaratively, right, using YAML. So you can see I'm doing a somewhat similar thing here, right? This is a little bit different. You know what I mean? So here I'm spinning up like a Rabbit and a Redis service, right? I'm specifying what are the containers, images that I'm going to use, what ports I want to expose, environment variables that I want to inject into these particular containers, and then also what are the configuration files that I want to pass to them as well, right? And now if I wanted to plug in my application into the space, well, what I'd have to do is, well, I'd have another Docker Compose file, right? Let me know if folks do this, right? But like I usually have multiple Docker Compose files. One that is for my infrastructure, right? Like here are the services, databases, queues, things of that nature that I'm running. And then here's another one that's mainly just for my application code, right? And essentially what this does is like, I'll point this to my source folder, and then I'll have another Docker file, right? So another thing that I'm declaratively defining what my application does. And I would say, hey, whenever I run a debug session, I want you to use this Docker file, I want you to build it, and I want you to attach my debugger to this thing, right? But then just like the other things, right? Like I'm defining ports and configuration files and the container names and networking and all these other types of things, right? So essentially we have like these two different models that we could use as we're building stuff out, right? Like we have the declarative model, right? That we can use here with Docker, and then we have like that programmatic model that we're using with .NET Aspire. Now, which one is better? Which one you prefer? I mean, I'll leave it up to you. I know a lot of .NET folks really don't like writing YAML, and I don't blame you, right? I think there's benefits to both of them, and depending on like what you're trying to do with your application, like maybe one might make more sense than the other ones. You know what I mean? I think an interesting thing to notice is that Aspire is still pretty fresh, like it's young. Even though we're looking at, talking about .NET Aspire 9 in November, like just a couple of months from now, the project's less than a year old, right? And so I think over time, like we're going to see a lot more interesting options come into it. But I definitely love the ability to be able to write .NET and use .NET constructs, like if statements and functions and things of that nature, to kind of define what my application looks like using that app model. And then I just feel like I have more control over it, right? Because one of the things you can do in that space now is that, hey, I can actually debug my app model. Like I can debug the infrastructure that I'm setting up that is my application, right? That's just one of the things that you really can't do with a Docker Compose file. It's a little bit kind of like a, run in and see what happens kind of situation. Now, I did build an app, and I want us to take a look at this app that I built. But before we look at the code, I want to quickly explain to folks what it looks like and what it is so that we could really understand what the code is trying to do before I kind of just jump into it. So the app I'm going to show essentially is like, it's a shopping cart application. It's based on the, I think it's called Aspire Shop or Test Shop, right? That was inside of the Aspire repo. And I just kind of added some extra stuff to it, right, to spice it up a little bit. But these are the main projects that kind of exist in that space, right? Like we have the front end that's in Blazor. We have a basket service, and that basket service essentially is creating your shopping cart, right? The catalog service that's going to return the products. We have a catalog initializer that essentially just like boots everything up from the beginning, right? And so it's going to initialize the database. It's going to create my products that exist in Stripe, right? And then the workflow processor that's like, hey, I've submitted an order. Now I'm going to execute my fulfillment, right? So these are the 5 pieces that essentially like make up this application. Now, a little bit more of a crazy diagram, right? Like now I've added like those additional components that are going to actually run it, right? So when we look at this application, right, like the things that we're going to try to model is obviously our services, right? Our core services that make up our application. But then I want to make sure that my front end has access to, well, I'm going to use this thing locally called HashiCorp Vault. Sorry, I got tongue-tied for a second, which essentially allows me to have local secrets, right? I wanted to have access to RabbitMQ, right? If we take a look at the workflow processor, the workflow is actually using a local version of temporal workflows. If folks are familiar with temporal, we could talk about that in a second. But essentially, you could think about it like durable functions, but it's just, it's not running in the cloud, right? Like I can run it locally, or I can run it in a container, or wherever the case is. And then you can see I have dependencies for Postgres and Redis and some other stuff, right? So that's essentially what we're going to take a look at in a second. Okay. Now, let's head over to my application. I'm just going to run this, and I'm going to click through the app real quick. And then we're going to talk about like what exactly it is that we're looking here and why it looks the way that it does look. Okay. So go ahead. I'm going to let this run. And of course, it opens up on the wrong screen, but that's fine. We'll figure it out. So this essentially is the Aspire dashboard, right? Like I mentioned before, one of the things it does is that it shows you all of the different pieces that are inside of your app. And you can see like there's a lot of stuff inside of here, right? I have a lot of different types of resources, from container resources to executables to even my .NET projects that are running in here. And so if I wanted to learn and understand like what's exactly happening inside of here, I could look at the details and I can kind of explore. For instance, if I look at this Redis thing, I can explore like some of this metadata that's inside of here, some of these endpoints, so on and so forth, right? This is some of the information that's coming from that resource server I showed you a couple of diagrams ago, right? Like that's where the dashboard is pulling some of the stuff from. And then on the left side, we have other things like, structured logs and traces and metrics. Like that's, those are the things that our application is pushing into this dashboard because it's looking at it as like an open telemetry server, essentially, right? Okay, so let's go ahead and take a look at the app. This is called Shadow Shop. Again, this essentially is just like a tweaked version of the Aspire Shop. Actually, I'm going to tell you the truth. Halloween is coming up, and what I was planning to do was I generated a whole bunch of AI images of like scary looking costumes and stuff like that. And then I decided not to put it in because I thought it might be a little aggressive. I didn't want to freak people out. I don't know if folks are scared of like clowns and witches and stuff. I'm a big Halloween guy, so I didn't want to put it in there. So if you're wondering why this is called Shadow Shop and it has like all these .NET things in there, that's why, because I was trying to do something different with it. Anyway, back to the app. So this is the application. It has shirts and products and stuff like that I could buy. This cart that's here, this is powered by the cart service that I mentioned before, and that's a separate service that's running. These products that are showing are powered by the catalog service, okay? Another separate service that's being run, right? Now I can go ahead and I'm going to click around on a couple of things. Click, 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 click. Some stuff is going on, right? And then I'm going to hit this checkout button. It's going to take us over to Stripe to do some stuff. I'll just put in a fake email. Doesn't matter what I put in here. And then I'm going to give it a fake credit card. Please do not steal my credit card information. Even though it's not a real card, please be nice. And I'm just going to go ahead and I'm going to click some buttons. Now it's going to go ahead and it's going to kick off my order. Now, what should happen if I head over to Stripe and I refresh this page? Obviously, I should see we just processed some stuff. Hopefully it worked. There you go, $52, right? Just did that a couple seconds ago. And then I should also see, this is temporal. I'm going to refresh this really quick. I should also see, oh, this is probably it right here. I just ran a workflow, right? That just kicked off not too long ago. Yep, this is our workflow, right? And you can see like our workflow has like a couple of things that are firing off, right? Now, again, we could talk about temporal later, but like the main point I want you to see is like this application has a lot of different things that's plugged into it right now, right? I have payments going on. I have my workflow kicking off in the back, right? Like I have a Redis thing that I'm doing. I have checkouts and so on and so forth, right? So now how can I use the application model, right? The app model to express some of these things, but express them in a programmatic way. So I'm going to go ahead and stop this really quick. Now, this is my app host project, right? And what I want to do is I actually created a few different custom resources. We're going to take a look at them, but first we're going to look and see like just on a very high level, like how exactly do I put this together? So again, in the app host, one of the things that you get is you get access to this thing called a distributed application builder, right? And you see we're creating that right there in line 3. And then probably I want to say like these first couple of ones, most of these services that you see at the top, essentially I'm just using extension methods to say, hey, I want you to add this thing to the app model, right? So here I'm adding that Vault secret store. Actually, I didn't show you the secret store. I'll show you again when I run it the second time. But I'm adding Vault to it, right? Like I'm adding an executable here. And this essentially is just, this is not running a container or project, but this is just running a script I have on my file, right? And what the script is doing is that it's just doing some bootstrapping for me, right? Because that's one of the options that I have as I'm building things, again, within this app model, right? I'm adding that local temporal dev server, right? Essentially, I'm just, extension methods to the world, right? Like I'm just adding and adding and adding things, depending on like what exactly is I need to do with them. Now, one of the interesting things that I find is really powerful about like this application model is not just the ability to add things, but the ability to add references to other things. So as an example, right, my catalog initializer, like I'm adding a reference to that Vault server, right? I'm adding a reference to the database, right? If I look at my workflow processor project, like I'm adding a reference to that temporal thing. I'm adding a reference to RabbitMQ, right? And I think depending on what type of resource it is, you might expect it to do different things. Now, I'm going to show you a custom resource I created, which is this temporal dev server. And as we talk about this, we'll kind of see like how we really express things using the application model. Now, before I mentioned, there's a couple different types of resources, right? Like there's container resources, there's executable resources, there's project resources. This temporal resource, this is an example of a container resource. And what I wanted to do was, the temporal CLI essentially allows me to run like a local server. So I wanted a way to express that using Aspire. So one of the things that I did, I created a container resource. I'm just specifying some default ports and the names of the endpoints. So, the default port for, their gRPC communication and the default port for like that UI that I showed you. And then if I open up this extensions project, this might look a little crazy, but as I open up this extensions project, essentially what I'm doing is I am creating that resource, right? So that temporal resource, I'm giving it a name. And then I'm using all of these with methods, right? Now, .NET Aspire is very much like built on like this builder pattern, right? And so if you look at this add resource method, it returns this thing called AI resource builder of T, right? And so in this case, like my T happens to be my temporal resource, right? And if you look at it, it's a very simple class, right? It has some strings and some integers in it. But as I add it, I can kind of go through and I could say, hey, I want you to use this Docker file. I want you to use these HTTP endpoints. And essentially what each of these are doing is essentially adding metadata to that resource, right? It's adding metadata to the resource that I created so that whenever the app host runs my code, it's going to look at that metadata and be like, okay, I know how to set this up, right? Like I know what's happening here, right? Now, a couple of things that I added to this, you can notice that one, even though I'm creating like a custom resource, right? Like a container resource, it's actually not using an image that's being hosted out on a container registry somewhere. I'm actually using my own Docker container, right? And so because of that, like I just have to leave this as an empty string. But if I open up this other file, right? Like I have nope, that's not it. If I open up this config folder, right? You can see this is what my temporal Docker file looks like. Now, I might have created this Docker file anyway, right? But now I'm like, okay, well, how can I use this and orchestrate it with use it with .NET Aspire? So all this Docker file essentially is doing is like it's running some updates and it's installing that temporal CLI, and then it's running a local dev server, and I'm using some environment variables that I'm passing in from Aspire to like populate these configuration values that are in here, right? So how do I pass configuration from .NET Aspire into a compose file? I'm sorry, into a Docker file. And you can see that I'm just doing that here, right? Like with these build arguments, right? So what's the service port that I want to have it run at, right? Like what's the namespace that I want to have it run at, right? And I also have like just some sensible defaults that are inside of there, right? But again, each of these with methods, right? Like with image, with Docker file, with whatever, I'm just adding this metadata, right? Like annotations onto this custom resource so that whenever the app host looks at that app model, it knows what exactly to do with it. And again, because this is just a local CLI, this is, a development time resource, I don't want it to be deployed, right? Like I'm not really thinking about like the deployment of this thing. I'm thinking about like my local dev experience, right? Another reason why I have like exclude from manifest, right? The manifest is the thing that like essentially says, here's a file that like describes your application, right? I'm going to give it to AZD. I'm going to give it to like some CI/CD system, and it's going to spin up those resources for me. I don't want to do that. That's not what we're talking about right now. We're talking about just creating like a local development experience so these things could kind of work together in an interesting way, right? But essentially, this is pretty much like how I set up creating that local dev server, right? Like I had a Docker file, I had some basic configuration, I passed it, and now I'm just using like this application model to kind of like spin that up for me. But now I can run local workflows, right, which is great, right? Like I don't have to rely on something that's in the cloud during development time, right? When I'm ready to, deploy, when I'm ready to go to production, sure, I could use temporal in outer space, right? Or I'm pretty sure I could use it in Azure or AWS or wherever it is, or I can even just use durable functions. But the whole point is like, I want to have a really rich and interesting local development experience that allow me to do the things that I wanted to without having to, again, like spin up additional resources that exist somewhere else. Now, so that is me just like adding it. Now, I also created a couple other interesting methods. So this one, we're going to take a look at with reference, right? If I added with reference to that builder pattern, like what would you expect it to do, right? Like if I said with reference, add like this temporal resource that I created. And so what I'm doing inside of mine essentially is I'm just adding some additional environment variables, right? And so anytime I add a reference to this temporal thing too, it's going to get the temporal address and it's going to get the UI address, right? I don't really need the UI address, but in case you want to look at it, I'm going to be able to populate these other resources with information from this particular resource, right? So hopefully that makes sense. If I head back over to my program CS as an example, here on line 11, I'm creating that temporal resource, right? I just showed you how we did that with that temporal dev server method. But then as I scroll down a little bit, this workflow processor, I'm calling with reference, right? Like this is my custom with reference that I created. And what's it doing is that it's populating my project, right? Because this is a .NET project that's in here. It's populating my .NET project with an environment variable that's based on this custom resource that I created. So hopefully that makes sense. So whenever I, use the configuration and I look for environment variables, I should have these values available to me in my .NET process, but it's coming from like this custom container resource I was able to do. Again, because we have that power of like expressing things in code, like these are some of the interesting things we can do with that space. And then when I run the application again, I'll show you what it looks like. But hopefully that makes sense, right? And hopefully you'll see what I'm talking about there. Now, let's take a look at the Vault server, right? I think the Vault server is interesting because the setup for this actually happens across two different types of resources, right? I have a Vault server resource that's essentially just a container. I have another one here that's an executable, right? So let's take a look at the first one really quick. So again, very similar to what we saw before, right? This one is a container resource, right? Because we have, that's one of the options that we have, right? With some ports and some numbers and things of that nature. And then if I open up my extensions one, so when I want to add the Vault server to my application builder, essentially what I'm doing is this time I'm actually pulling from a container. Containers coming from that Docker Hub registry. And now I'm specifying endpoints, right? These endpoints are essentially like what's the address that the server is going to be listening to whenever I spin up this container, right? And then notice that we give it a port, a target port, and a name, right? The port is essentially what it's going to be listening to on our machine, right? The target port is what it's listening on in the container, and then just the name of it, right? So because there's different types of endpoints, right? And so we want to be able to reference this by a particular name. I think the name of this, I think I just called this HTTP port, right? Whenever it spins up, that's what's happening here. And then when all these additional environment variables, this is really just configuration, right? Like I looked at the docs and like, this is the configuration I need to run this thing. I'm going to go ahead and kick it off and run it for you. Now, the thing is, the reason that I wanted to use Vault, and for folks that aren't familiar with Vault, again, it's essentially like Azure Key Vault, like it holds secrets for you. I wanted to be able to run a local dev experience. I wanted to have a local secret store that I could get used to, like playing around with and doing things with. Now, when I first run this, I'm like, okay, great. I have a Vault, but there's no secrets in it, right? Like I essentially have an empty Vault, right? And I want to populate it with stuff, right? Because, when I hit F5, I just want my application to work. So one of the things that I did was I added an additional resource. And this was just an executable resource. And added it from the perspective of like, I just called add executable, right? Like this one is already built into that Aspire app model. But I added this executable, right? I gave it a name. And I want you to run this bash script in this folder. This bash script is just called setup.sh, right? And I also notice I'm giving it a reference to Vault, right? Because there's some environment variables I'm setting up there, and I want to pass it over this executable script that's running. Now, if we take a look at what that script looks like, I have this little folder over here that has a bunch of stuff in it. Now, this is essentially what my Vault script is doing, right? It's defining a environment variable here, Vault address, right? It's creating a section inside of my application, right? A key value pair where I can store stuff. I just call it shadow shop. And then here, I'm mounting secrets in these different places, right? So here's some of my keys. I know people are going to freak out that they're seeing my keys. It's okay. I'll rotate them. Also, you're not seeing the whole key because it kind of like runs off the screen. So I'm fine with that. Right. So essentially, I'm just adding keys to this Vault space for my application. So now, whenever my app runs, my secrets, if I add a reference to Vault, it could be like, oh, okay, you have secrets. I'm going to pull them out and I'm going to hydrate them, so to speak, into the configuration system inside of my applications, right? So hopefully that makes sense. So I have this Vault store, again, it has some keys in it. And if I look down, you can notice like I've added a reference to the initializer. I've added a reference to the workflow processor. I've added a reference to the front end, right? Because I want them to have access to those keys. Now, obviously, I didn't have to do this. Like we totally could have used like user secrets. I could have used the configuration file that's, the app settings file that's inside of the app host project. But again, I wanted to have something that felt a little bit more realistic, right? Like I wanted to use a Vault, right? Again, whether it's Azure Key Vault or whatever the case is, but I wanted to have a local experience to do that. So I decided, okay, well, let me go ahead and create this, this extension that will allow me to run this service locally and give me like a semi-realistic experience of what it feels like to run this stuff. Now, what happens when I add this reference to a project? Now, inside of my actual project, let's take a look at maybe like the front end one as an example. Inside of this project, I added another extension method called Vault Dev Server Configuration. And essentially what it does is that it adds a custom configuration provider that it goes into Vault and it pulls the keys out, like using a certain convention. There's probably NUKE packages that could do this, but I just built my own. You don't have to use this. But that's essentially what it does, right? And so, but if you remember, when I add vaults to things, right, like I'm adding these environment variables, right? So I'm pulling these environment variables out that I'm getting from that with reference. And then I'm using my custom configuration provider to look inside of that vault and pull some of these things out, right? Hopefully that makes sense for folks, right? But again, the whole point is like, how can we create like some of these local dev experiences, like using like the API that's available, right? So now I'm extending my configuration by every time I added a reference to Vault, I know Vault is a place that stores configuration, it stores keys. I'm going to add a reference to my application, and then now my app is going to look at that resource and it's going to populate the configuration in that particular app with the keys that I've added, using that setup script that I had before. So hopefully that makes sense, and folks, aren't going crazy for what I'm showing you. Let's take a look at some other custom resources. So we saw how the Vault one worked. I think we saw how the temporal one worked for a little bit. The first one, I think both of them were actually container resources, right? I want to show you an example of a custom executable resource, right? And I think this could be interesting for folks, because again, like what is a resource, right? Like what do we really do with them? And I like to think about it as like, what can I do to make like my local development experience really interesting? Now, before, I've actually had like the Stripe CLI running in the background, right? And one of the things that happens, if for folks that are not familiar with Stripe, so I make an API call, I pay for something. Once the payment gets processed, I get a collection of webhooks sent to a particular endpoint, right? And that endpoint could be, I don't know, you can have that running in Azure Functions or be a part of your app. But essentially, the webhook is just going to say, hey, this payment was succeeded, this thing worked, yada, 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 right? Now, what I've been doing here is I've just been running the Stripe CLI locally on my machine manually, because I wanted to be able to forward those events to, again, the workflow processor that's on my machine, right? Because as an event comes in, I want to kick off a fulfillment workflow, right? Kind of like we saw in the image. Now, I'm lazy and I don't want to do this, right? Like I don't want to have to run this every time. I don't want to have to log into it every time. So I'm going to stop that from running really quickly. And instead, I'm using regions. People don't get mad at me. Instead, what I'm going to do is I'm going to show you this resource I created. I actually created this last night as I was thinking about this talk today. How can we orchestrate resources that are, things that are on our machine, right? Now, I have the Stripe CLI installed on my machine, right? It's installed, it's ready to go, but I would love to have it spin up whenever my application starts, because it's a dependency of this application, or at least like receiving those events is something that my application is expecting to do, because if I don't get the events, I can't kick off the workflow. So one of the things that I'm doing here is I'm saying, hey, I want you to add this Stripe dev proxy resource. And now what this is not a container resource like the other ones are. Like this is an executable resource, right? And I just give it a name, a command, and the working directory. But what I'm doing with this particular resource is I'm saying, hey, if you give me a project, right? So I have the front end project. I'm going to pass it in here. If you give me a project and the endpoints that you want me to send the webhooks to, then I'll spin up this Stripe CLI for you. Notice I'm passing in environment variables, the device names, things of that nature. And then I'm going to run this script locally in my machine, giving it these environment variables. And then the whole point is, well, hey, I just want to spin up this environment that'll allow us to, again, be lazy, and it'll just run that CLI for me. and forward those events over into my application, right? So again, just taking one more step out of what developers have to do to get started and building things, right? I can imagine so many times folks are like, oh man, I forgot to forward the events. I forgot to set up the keys. Like, again, like using this app model, it can just be one less thing for us to think about and one less thing for us to do. So if I open this,
Cecil, excuse me, sorry, just to interrupt for a second. Your video has frozen. I'm just going to try and take you off the stage and back on again and see if that brings you back on.
Sure. Sorry about that.
Okay, one sec. That one, I'm back. Oh, no, we've lost your video completely. Would you mind stopping and starting the camera again in StreamYard?
Sure, no problem. Give me 2 seconds and I will
Thank you.
do that.
There we go. Perfect.
There we
Thank you
go.
for that. Sorry to interrupt.
Apologies, folks. Sorry about that. All right. Where were we? Right. So now, what that custom resource does, right, and that the custom resource, like I mentioned, is an executable resource. It's just going to run the script. But notice, like, these environment variables are getting populated from the app model, right? Like the webhook endpoint, right? The Stripe secret key that I'm using, right? And again, I don't have to feel bad about like having keys inside of my application and having you see them because they're not there, right? Like they're all getting passed around because again, I'm using the app model to kind of share that configuration around for me, right? So what I've done, again, I've stopped it running locally, right? So if I go ahead and run this, excuse me, what I'm expecting to have happen is in a second or two, the app host is going to run. This is going to be ready to go again in a second. There we go. And then now I should be able to, I like reusing the same window. I don't like new windows. Now I should have an additional resource, right? Like I should have this thing that says Stripe events proxy. And if I head over to the logs, right, there you go. You can see like it's up and it's running. And now it's forwarding events to this local host, right? Localhost 7276, right? Where did I get that from, right? That is where I passed in the project, right? The project that I want to forward things to, which will be this front-end project, and like the path that I want to send it to, right? Now, using the app model, I can do this. I can say, hey, project, give me the endpoint, right? I want the HTTP endpoint from that project, and then I'm just going to append the path to it, right? Because again, like we have those annotations that represent like the different metadata, and one of those annotation types are endpoints. So I'm like, hey, I want this HTTPS endpoint. Here's the path, and now run the thing for me, right? And so now I should be able to just run the application like I have been. I'm just going to refresh this really quickly, right? And I can click around and I can do the things that we want to do, right? Oh, I also mentioned that this thing was using Redis as well. I want to show you a Redis thing really quick, just to show you like what this thing looks like. I'm using Redis Insider. I'm sorry, Redis Insights. And essentially what it does is, this is a really interesting UI that allows me to look and see what my Redis things look like. So I'm just going to log in to this, right? I know what the password is, as you can imagine. And here you go, right? So this is, okay. Right, and so this is the stuff that's inside of that basket cache that I was talking to you about, right? Like that information that you see there essentially is what's, you know, powering this button that's there, right? But now if I click the button, I should do the thing. I should still work. Like everything should be working fine. I'm just gonna make up some stuff there again, and then again, like I mentioned before, please don't steal my credit card number. I'm just gonna make up some more stuff again. And what year is it? There we go. And I'm just going to blah, 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 right? But then what should happen, if I head over to the logs, right? You can notice, there you go, right? My CLI is running, orchestrated by .NET Aspire. And again, it's not something I really had to think about, right? Like all I had to do was hit F5 or run it, right? And like these things just kind of happen to me. If I head back over to my workflows, I'll refresh that really quickly, right? Oh yeah, that's true. The workflows don't, they're not persistent because it's all in memory. But essentially, again, you can see like my workflows are running, you know what I mean? This is 12:31, which is about my time over here on the East Coast. So that makes sense. And so again, you could see like some of the things that are happening there. And then here's the payload that came over from my workflow instance. So again, the main point that I want to show you here is that like we have a lot of interesting ways that we could look at Aspire and we could kind of compose the way that we want our applications to work, right? Like using the app model, we could use like some of these different resource types. You know, you can see, you've seen examples of how to use like the executable resource type, container resources. And then I didn't really talk about it this much, but I'm sure you guys have seen like examples of how, you know, you could orchestrate your projects, right? And then now giving, you know, using service discovery, giving references to some of these other projects and some of these other services to your applications so that they know, okay, well, this is where they live and this is where they are. This is what the ports are. These are what the connection strings are. This is how I connect to some of these things. Now, if I head over to the dashboard, let's click on some of these really quick. Now, one of the things that the dashboard does that's really fun is it, you know, like I mentioned before, it supports OpenTelemetry. And so in that space, you can notice that I have access to all these traces, these logs, and I can see some of the interesting things that my application is doing. Notice it's even intelligent enough to know like the names of my applications. I didn't really set that up, right? Like talking about like those smart defaults, it kind of just does it for me, right? I can kind of click and see, okay, look, this thing hit my webhook endpoint, it sent a message over to RabbitMQ, and then, you know, some stuff happened, right? Now, again, I like to try and do things that are relatively like realistic. Like what does it actually feel like when I do things like this in production? So one of the things that I created was, hey, what would it look like if I use like a different OpenTelemetry server, like Grafana, right? And how can I plug that into here? And how can I orchestrate that using .NET Aspire? So you probably know the answer. I went ahead and I created a custom resource for that, right? So if I do, I'm going to actually type today. So if I do Grafana, oh look, new, what's this thing called? Builder.add Grafana stack, right? I'm just going to call this Grafana, right? And then now I'm going to just give it some custom ports, right? So I want the Grafana port. I think that ports by default is like 3000, right? And then this other one's going to be 413, right? I actually shouldn't need to put this in, but you know, just to show you, let you know that, you know, this is an option that you have. And now I'm actually going to, like you could probably imagine, I'm going to go to my projects and I'm going to with reference these things, right? So here is this is the front end project. I'm going to do with reference Grafana, and I'm going to go ahead and add that to some of these other services, like the catalog service. I'm going to add it to the workflow processor. I'm going to add it to the basket service. Okay, right? So remember, what was happening before was like now we were getting all this telemetry and it was being sent here. But what if I want to send it somewhere else instead? Right? Let's see how we can do that using a custom resource. And I'll run it first, and then we can actually look at the implementation of that resource so you can see what it does. Right? So heading back over here, I'm going to, let's go back to the main. Let's refresh the page. Reload, please. Thank you. Fantastic. Now I should have a Grafana resource, right? So there's the Grafana resource. If I actually have to click around in this application a little bit because I want to generate some stuff. So I'm just going to click some things. I'm going to do that. I'm not actually going to run that checkout again. I think we all know what that does. Yep, I'm just going to click around, and really I'm just trying to generate some traffic. I'll refresh this a couple times too. Okay, now what I'm expecting to happen is that if I head back over to my resources, I have these two endpoints, right, that I specified. If I take a look at the details, I want the Grafana UI endpoint. I don't want the OTel endpoint, right? I want the endpoint that'll show me stuff, right? Oh man, what's the password for this thing? I think it's admin. Is that what it is? Yep, that's what it is. All right. Admin never fails. So I'm going to go ahead and explore. And now, so what I'm using this container, and I'll show what it looks like. But essentially, it allows me a very easy local development experience using things like Grafana for logs, metrics, traces. and some other interesting telemetry, right? So if I wanted to, here we go, my service name. Remember, we added it to the front end service. I can go ahead and run this query, and ta-da, there you go. We have logs, right? Now my logs, instead of sending them to the dashboard, I can send them here instead, right? Like I can do other things too. Like I can look at, tempo, which is traces, right? Like I can look and see like what some of this trace information is. You know what I mean? I can select my service name. Let's say my service name is equal to that. I can look for span names, things of that nature, right? And I could see, that doesn't look nice. Anyway, I hope you see the point. Like I could click on these things. There we go. That looks better. And I can see like the requests that are being made, like the length of the request and how long they're taking and things of that nature, right? But if we head back over to Spire, right? If I refresh this really quick, you'll notice that, those front end ones are not in here anymore, right? Because I'm only sending the telemetry for the catalog initializer, because that's the only one I didn't add the with reference to. I'm only sending this one to the dashboard because that's where it's going to go to by default. But again, using the programming model, we have the option to change things, right? We have the options to create that development experience and that infrastructure the way that we want to create it. So if I head back over super quick, and I'm going to take a look at this custom resource so you can see, and this is probably one of the easiest, let me not say easy. Easy is not a good word to use. This is probably like one of the least complicated resources that we created. So very similar again, like we're following the same model. Here's a container resource, and I gave it a name, right? These are the ports that I know, and I found out these ports from, I didn't define these ports. These ports are just from documentation, right? These are the ports that this thing is listening on, right? This is the platform that that container runs on, right? So it's running on a 64-bit AMD, right? I'm on an ARM machine, so I have to specify like what type of architecture that actual container is running on, right? And then I have my add Grafana stack extension method, right? And again, we're going through the with methods, right? Like with image, with tag, with registry, right? With endpoints, you know what I mean? And I'm setting that stuff up. But the interesting part comes here, right? Like when we talk about doing, let me move this out of the way because you don't need to see that. When I add with reference, the only thing that this is doing, to be honest with you, is I'm just overriding this environment variable, right? So I'm saying everything that I add with reference to this particular resource, right? I want you to add this environment variable, and I want you to use me, right? I want you to use Grafana instead of using the Aspire dashboard, right? Love the Aspire dashboard, but if you wanted to use something else, you can, because you have that option, right? And one of the ways that we do that is through configuration. We can configure things using, environment variables and settings and things of that nature to, again, craft and create this world that we really want to create using some of these different tools and services and whatnot. So hopefully that makes sense. I felt like I went a little fast because there was a lot of things I wanted to show in a short period of time. But for folks that are curious, again, I know folks are going to ask me about the code. So the code will be here. It's not there yet because I think the repo is still private. I'm going to make it unprivate in 10 seconds. But this is where the code will be. This was real for me. It was a really interesting exercise, a really interesting like show and tell exercise for me to kind of see, hey, well, what are some of the things that we could do with Aspire, right? And what are some of the ways that we could use that programming model to create a lot of interesting scenarios? You know what I mean? I think about situations like onboarding. I think about situations like automated test scenarios. Things where I want to reduce the amount of manual configuration that I have to write. You know what I mean? Like I want to set it up in code and, have my teammates, get checkout and then just run. And things just kind of happen for them, right? Like that's really the world that we kind of want to go into. Because if we go back to that second slide, one of the hard things about this distributed world, these types of applications that we're trying to build, is the fact that there's so many different things that we have to get set up and plugged in together. There's so many different things that we have to get it configured the right way, and let's not make any typos, or let's not delete the wrong file, right? Like it becomes a very brittle, sensitive situation, right? And I think using things like Aspire, using things like containers, can make that experience so much easier for folks. So hopefully that made sense. Hopefully folks, learn something fun and interesting. I'm going to go ahead and make that code available shortly. And yeah, I guess if there's any questions, folks, definitely happy to hear what folks want to talk about.
Yeah, thanks, Cecil. That was a really interesting talk. I really like the way it's showing how to manage the sort of external service dependencies you got there. I find it very aspirational.
I was trying to get some some cheesy Aspire puns in there, but I failed. Next time.
Well, to be fair, you did get Aspirify.
Yeah, you need to trademark that, Cecil, because you're going to be rich. Aspirify.
We like that one.
Yeah.
Yep.
So go ahead, Matt. Go ahead.
No, I was just going to say it was a fascinating session and really interesting talk there. I wonder if you would be able to talk us through a little bit about the project that you're using there. That kind of you had all these custom resources inside a project. I mean, presumably that's not just like your default project for a web service. That's like a separate C# project.
Yeah, so I can head back over to this. Let me stop this debugger really quick. So if we just look at the solution, right? And I'll close some of these things because we don't need to see all of this right now at the moment. So the only thing that's different, right? Because I think for folks, like, they look at Aspire and they think about, hey, I have to redo how my whole application runs, and you really don't have to, right? Like, none of these projects that are here, right? And I have a bunch of catalog projects in here. I just put them in a folder because it was getting noisy. None of these projects that are here really care or know about Aspire, right? They know about configuration, right? There are Aspire packages in them, but only from the perspective of, like, again, like, those packages add configuration and they add service discovery and they add some of the resiliency bits by default. But in terms of the actual resources that we talked about, like, most of the code that we looked at today exists within this app host thing, right? And if you remember from that diagram I'd shown you folks, I'll jump back a little bit. Right, like, the app host is the thing that kind of exists to, like, read that code and say, hey, well, what is this thing, right? Like, what are the pieces that you're trying to put together to make the solution that you're trying to make, right? Like, what are the puzzle pieces that are your application, right? And I am the board, right? Like, there's the puzzle pieces and I am the board, right? And, like, where do you want to place them on the board, kind of thing. So, one of the things I tell folks too is, like, if you only use this for development time, for a development time tool, like that's fine, right? And also, all those additional packages that I talked about that you could use, like, you don't have to use them. I think we have this habit of saying, like, oh, okay, like, this thing came out, I have to use the whole thing. Like, you don't have to, right? Like, you can use the bits and pieces that make sense for your application, right? So yeah, I mean, I think if folks are, really wanting to find a way to, like, hey, I don't want to write YAML because, how they feel about YAML. I think this gives us a really interesting opportunity to, like, do things in code and just give us a little bit more control over things.
Yeah. Speaking of bits and pieces, someone in the chat asked, are there features in Aspire right now that you feel are potentially missing? And what or potentially are you waiting to see implemented in Aspire that would make the experience a little nicer for you? Maybe nothing. Maybe that's the answer.
So Aspire has a lot of different things in it. Mm-hmm. I think one space that I'd love to see more work being done, or at least us as a community talk about more, is the service discovery space. So right now, the default service discovery experience is configuration, right? Like, I'm going to give you the connection string for things, right? But when you think about, again, going in a world where, like, there's multiple instances of services, like, I need more than just a configuration string. Like, I need all the configuration strings. I need to be able to, like, make a request and, like, load balance across many instances of a thing, right? And how do I know where they are and where they live? And like, how do I know when things dynamically come up and down, right? Like, I don't know, maybe, you know, I think that could be an interesting space that Aspire could definitely probably help us as .NET developers with. I don't know what that looks like. But for me, when I think about building distributed systems, you know, it's one thing to say, hey, I have one Redis server and I have one RabbitMQ server and I have one thing. But then when there's many of them, like what does that mean? Like what does that kind of look like?
Yeah, you're right. You kind of have to go on good faith that whatever your development environment is, it's one of everything, because maybe that's the resources you have locally. But once you get into production, you might scale your Redis because the load is just so much bigger. And at that point, is your development environment ready for you to kind of emulate what's going to happen in production, or are you just deploying stuff on good faith, right? Like, hopefully we've done everything right. Yeah, that sounds like a big challenge. I'm not sure what that would end up looking like, but it's a good problem to solve. So
yeah, and I mean, they do have because again, Aspire is just a stack, right? Not just the app model app host. They do have a library that does DNS SRV records. So it's essentially like one of the ways that folks use for service discovery in Kubernetes, or if you're using anything like console or things of that nature. We just don't really talk about it. To be honest with you, I don't know why we don't talk about it. Like, we as like a .NET ecosystem, we don't really talk about it. But you know, I think one of the things I want to do is spend some time playing around with it and seeing what we could actually do with that space. You know what I mean? I think another part of Aspire that I would definitely love to see improve is their Dapper support. Selfishly, obviously, because you know I love Dapper. You know, I think when 8.0 first came out, like there was Dapper support. I don't think a lot of work has gone into it since then. But I definitely love to see some additional support for Dapper and like the different Dapper components, right? And again, being able to you know, programmatically define that infrastructure in a way that I have to write less YAML. I don't think we're ever going to get to the point that we write no YAML. I think that's a little far-fetched for me. But I think we can get to a space that we write less YAML, just like we can write less JSON, you know what I mean, and have some of it auto-generated. But yeah, I'd definitely love to see like some of that stuff.
yeah.
Yeah, I think YAML's okay in small doses, really. It's...
like radiation. Yeah.
Wow. Okay.
Wow.
we worried about pumpkins and witches. It's
that's funny.
Following on from the question really about what you might be missing in Aspire, I kind of noticed you had to write several of your own custom resources there. I mean, do I have to write all of my own custom resources, or you know, does it come with a bunch out of the box? One of the comments in the chat was actually, you know, we need an Aspire resources.contrib maybe.
You don't have to write all your own resources. I'm a control freak, and so I like to put my hands in things. So if you bring up my screen for like 2 seconds, so I want to say I only wrote half of these. It's like this RabbitMQ one. This one comes from the Aspire repo, right? This Postgres one. This one comes from the Aspire repo. So you don't have to. If you go into the Aspire repository, like there's.
So sorry to interrupt. You said from the repo. Does that mean they're the packages, or have you pulled the source down?
No, they're packages, right? And so I'll pop this up really quick, right? So if we look at it, right? So there's the Aspire hosting Postgres, Aspire hosting Rabbit, right? Like there's a client one as well, right? Like these are all packages, but again, in terms of like seeing what's there and what's available, like you can look into. I think the folder's called components under Aspire, and then you can look and see what are some of the different ones that are either being worked on or some of the ones that are just available. There's ones for like if folks are doing AI stuff. There's stuff for like Olama and tons of other things in that space. For me, again, like, I wrote the ones that like I didn't have, right? So I'll give an example, like that Grafana one that I showed that like you could send custom telemetry to. There wasn't one that existed for that, and I'm like, okay, well, let me see if I could do it, and I did it, right? Even the one with like the temporal and the Stripe APIs, right? Like those resources are a little different because those are CLIs, right? And so these are CLIs that I'm like, hey, I want to orchestrate the CLI, right? So, I spun up that local temporal server so I could run local workflows, and I spun up that local Stripe thing so I could, get webhook events, right? Because again, outside of just thinking about Aspire as like, hey, what do I do when I'm running my app in production? I think about the app model as like, what can I do to make my development experience a little bit richer? Like, I want to do less stuff because I'm lazy, right? I want to do less stuff because I don't want to mess up the configuration. I don't want to forget a semicolon or whatever the case is, right? Like, I don't want to forget the path or what the default password is. I just want to hit run and have things happen, right? So the short answer is no, you don't have to. But I just did it because when I think the programming model is approachable enough that it allows us the capability to do some of these things and experience some of these things if you wanted to. I'm sure some folks probably have, if you're talking about building things in-house, you probably have some services and tools that, are not exposed to the world, and you might want to orchestrate, the runnings of those things as well, right? Like, you can use some of these programming models to do that. And you don't have to push them on NUKE, right? If it's just something that you have in-house, you can have your local, maybe you guys have local templates or local repos, right? Like, you can pull that stuff, and so all of your team can share in that resource without really having to worry about, oh man, like this is the dependency to plug into the thing, and all of that type of stuff.
Yeah, I mean, historically in the Microsoft .NET space, sometimes teams wait to see kind of what Microsoft has to offer before they do anything. But I think the thing that I got from just kind of watching you build out these resources, these integrations yourself, is like, you don't have to wait. You can just do it yourself, and you can add value immediately to your team. Speaking of value, somebody asked, what do you do about testing? Does Aspire come with like a testing framework out of the box, or should you even be testing kind of your Aspire applications with something like end-to-end tests?
I mean, there is testing support. So very similar to how, if you have a web application, right? Like, there's the web application test builder, like create test builder, right? Like, there's a very similar thing, right? There's a distributed application create test builder, right? Or so and then there's templates for those as well, right? So you can definitely do that if you wanted to.
Okay, very cool. Matt, do you have another question? I'm looking through here.
I just wanted to follow up a little bit with the building your own custom resource there. The with reference method that you're using.
Yeah.
Obviously, there's no sort of that was a static method, I believe, an extension method. Is that just a convention, or is that do the kind of out of the box ones have a similar with reference method? So it's just a common convention, or
yeah.
is it something you've done?
So kind of going back, so out of the box, you have a default set of resources, right? You have executables, project resource, container resource. And so again, if you do nothing, right? Like, as an example, I'll show this one, right? So like, this is a project, right? And I'm adding a reference to another project, right? Like, this one is not mine. Like, I didn't create this, right? But by default, like out of the box, you have like these different methods that are available that, based on the type of resource, it'll do a different thing, right? Which is why I think like the API, the expressiveness of the API is interesting, right? So if I add a project to a project, what would you expect with reference to do, right? Versus if I add vaults, which is where I keep my secrets, if I add vaults to a project, do you expect it to do the same thing, or do you expect it to do something different? You know what I mean? Like, what is, again, like, what's the intent? Like, what do you think is happening there? If I add RabbitMQ or RabbitMQ or Grafana to a project, again, what do you think is going to happen? Or if I have an executable, if I add a reference to something from an executable, what do you think that's going to do, right? So I think from a conventions perspective, it's it's an interesting way for us to. And one of the things that you can't really do with things like Docker Compose is, generate things dynamically and then kind of like share them across the stack, right? And then you can almost like redefine the meaning of the word reference, right? If you think about it, You know what I mean? So like here with this executable one that I'm showing on line 8, right? It's like here, there's an executable, but like when I add Vault, I really just want you to add environment variables, right? Versus when I go down to this one, well, what this is adding, it's adding the environment variables, but it's also adding the endpoints, right? So like when I want to make a service call to this thing, what's the URL? What's the port number? What's the, whatever, right? Like what's the information I need based on the type of resource that I am to, get my job done, right? So it's one of the reasons too why, like, I really like that these are all extension methods, right? And so what you can do, you look at mine, for example, right? Like I can use the base one, right? Because by default, what it'll do is like it'll look at these interfaces. I didn't really talk about this too much. Maybe I should have, but it'll look at these interfaces, right? And then based on the interface, these are all marker interfaces. There's nothing in them, right? This is the service discovery one. This is the endpoints one. Like you see, these are all empty interfaces. But based on the interfaces that they are, with reference is going to be like, okay, you're a type of this thing, right? I'm going to treat you this way, right? So again, if I add a project, if I add a service discovery annotated thing to a project, it's going to add the endpoints, right? But if I add it to an executable, maybe I don't really care about the endpoints. Maybe I just want the environment variables, right? Like I think it's very much again, like based on the, I have a resource of this type and a resource of that type. Like what happens when I put them together? What do I expect to happen in that space? Or what even makes sense for my application, right? Like I mentioned, you might have a custom thing that's inside of your company on your own. What would it mean if I had with a reference and I gave it a bunch of JSON? You know what I mean? What would I expect that to do, right? Like if I had add Postgres with JSON, would I expect that to populate data in the database? I don't know. Maybe not, right? Like, is that the configuration? Maybe not, right? Like I think the expressiveness there is interesting from what we can do with those APIs.
Yeah, you had mentioned kind of like this team language and getting people to maybe go beyond talking to each other and kind of formalizing your application and infrastructure. And you're right, this kind of expressiveness is like codifying the conversations that you've had as a team over time. And I think that is really, really interesting. So on that note, I think that's all the questions we have. Cecil, this was just an awesome talk.
Awesome. Thank you for having me, man. Appreciate it.
Yeah, just all the things you've done in this talk. We put the link to the project, so anyone who wants to get access to that, you may need to wait a second, but if you're watching this in the future, it's probably already available.
I'm going to do it right now. So I'm going to tell you, the only reason I do demos and I leave them private is because I take a long time to add the readmes. And if I don't add the readme, it's going to be like, oh shoot, here's a bunch of code. Like, how am I supposed to run this thing, right? And I feel bad. But
honestly, a developer who doesn't want to write documentation.
I've never heard of such a thing.
I've never heard of that. It's
never heard of it.
Strange.
But I'm going to go ahead. It's public now. So if folks,
awesome, thank you.
Folks, head over there, and I got to do this GitHub mobile app thing where it approves your request. Great. So yeah, it's there. It's up. It's available. I'll write the README in like a couple hours.
Hey, you take pull requests, I bet. So if someone
I take pull requests. Someone could send me a README pull request. I would very much.
Sounds like you were volunteering there, Cleve.
Oh no, I don't know. I don't know about this, but well, again, thank you so much. We loved having you, and you're always welcome here at JetBrains. So thank you so much.
Absolutely.
Thank you so much.
Great session. Thank you,
everybody.
We'll
Take
see you
care.
later. Yeah, we should probably also give a bit of a shout out to the Aspire plugin for Rider as well. If you're doing anything with Aspire, get the plugin. It's going to help you immensely. So quality.
The plugin brings some of those dashboard features into Rider. It also allows for distributed debugging. So if you have multiple .NET services or integrations, you can set breakpoints across all those services and kind of debug your distributed application. So, and it's available on GitHub. So if you ever have any issues or would like to add a feature, you can always go there and request one. So that's pretty cool. On that note, Matt, I think we've reached the end. Is it only you and I? We're the only ones left standing? Oh,
We're the only ones left standing. It's all gone very quiet. It's there, but it's been a fantastic 2 days. Lots of really, really good sessions. It's been very, very interesting, enlightening, and yes, aspirational.
Very aspirational. I have a
Doing it
few
again.
ideas after these last 2 days of like getting into some programming, maybe trying some few ideas out. So I'm excited about the future. So
This is good.
Yeah, very good. So
we should probably say then that the we'll be splitting the talks up into their own little videos as well, and we're posting those up to YouTube over the next week or so. We'll be publishing those on the blog and social media and all stuff like that. Follow JetBrains TV for more details, I guess.
Yeah, I mean, for the few folks still watching, like this content, if you like these kind of live stream events, it really helps us figure out whether we're doing a good job or not. Leave some comments. We read the comments. And subscribe, hit that notification bell, and you should just watch everything we do. It's amazing.
And chat has been fantastic as well the past 2 days. Lots of great conversations going on.
Yep. So I want to thank you, Matt, because you're great. And I want to thank all the other advocates. I want to also thank the people behind the scenes who make all of this possible. So thank you to our video team, our marketing team, and everyone at JetBrains. So on that note, let's say goodbye.
And thank you to all the speakers.
Oh, absolutely. Absolutely. They're fantastic.
And thank you to Khalid.
Yep. All right, folks. See you later.
Bye-bye.